Hi team, welcome to my session on Coffee with Prab, and today we're going to discuss about SOC Analyst Masterclass. In this video, we're going to cover end-to-end the knowledge which is required to become a SOC Analyst. And I'm sure after this video, you get some kind of visibility, and based on that, you can master some of the core skills. One more important thing, when I was working on this video, I took some snapshots of my old content and I added that also in the sequence. So it gives you the end-to-end visibility. And I'm sure after this video, you will get a better insight about how to become a SOC analyst and what content is required to make a mastery in a SOC analyst. It's a long video, but I'm sure it will be very informative. If you're new to the channel, do subscribe to the channel and click on the bell icon to make sure you should not miss my future videos on a similar topic. So without wasting a time, let's start with the first part. Thank you. So before we jump into SOC and all that, let's know the basics. See, when you're talking about cybersecurity, what is cybersecurity? Because we're talking about security, it's a very hot trending word. So cybersecurity is a process by which we protect the digital assets. Okay, so let's say example, this is my phone. In the phone, we have a WhatsApp. So WhatsApp chat is there, and that chat basically has some sensitive information. I don't want someone else to see my information. So what I did is I protect this WhatsApp chat with the PIN. So that give me assurance that only person know the PIN can able to read the chat. So PIN is a control that we implement to protect my data which is basically is WhatsApp. See, data is a single information, group of data is from the information. So cybersecurity is a process which is used to protect digital data. But on the other side, when we say information security is a process which protect all type of data. With the same example is, this is the phone I kept in a physical locker. So this is my physical locker. And I lock this locker with the key. And I also hire a security guard to make sure no one should able to access the locker. So now what happened? Cyber is a part of the information security. Cybersecurity protect digital assets, but to protect all type of assets, whether digital, physical, verbal, is basically come under the information security, because information can be anything. Okay, so you can say cybersecurity is a part of information security. So when I say tomorrow I'm maintaining a cybersecurity, it means we're talking about protecting a digital assets. When I'm saying information security, it means I'm protecting all type of assets. So when we're talking about cybersecurity, information security, in the information security, we have a multiple verticals. The first vertical is called as a offensive testing, or we call it as a security testing. So we have a roles like doing a pen testing and all that. Then second is called as a defensive, where you try to protect the organizations and all that and investigate alerts and everything. Third is called as a security governance, where you're building process and creating a security process, and based on that, offensive and defensive will maintain the security. And then fourth is called a security products, where we're implementing firewall and all that. So in this slide, in this video, we're going to discuss about the defensive content. What are the different kind of profiles we have in the defensive, and exclusively we also talk about the SOC analyst. Okay, so let's understand what is basically SOC, so you get a better visibility here. So when you say SOC is a centralized team of cybersecurity professionals who monitor, detect, and respond to the potential security threats. Very important, okay? Monitor, detect, and respond. Understand in layman term, like, you're staying in one society, right? You're staying in one society. This is your society. Okay, you have a multiple house here. We hire a security guard. We have a police officers who just monitoring to make sure no one should able to access the society in an unauthorized manner. And if they do that, we can investigate to make sure it should not be happen again. Same like in the company, we build a SOC center, security operation centers, who monitor what kind of an attack is happening on the business, what kind of an attack is happening on their IT, what kind of an attack is happening on the process. Because if any of the layer is compromised, it has a complete impact on the organization. So we have a SOC center here who monitor all the activity which is happening on the business, IT, and the processes. So that system is called as a SOC department, security operation department. So they monitor the attacks, they detect the attacks, and their goal is to make sure they can able to respond to the attacks as early as possible. So what is threat? What is incident? In my next slide, we're going to discuss. But for your information, threat is like anyone who triggering the action. Example, if any hacker trying to hack my website, his action is called as a threat. Okay, someone is threatening you, I will kill you, or I will see you outside. So that is basically threat. Okay, so security threat is something you cannot able to control. You got some random question in the exam, that is a threat for you, right? So that is a threat. Threat is any action which basically, compromises security, and incident is a confirmed action. So they are responsible for monitoring, detecting, and responding to the potential security incidents. Along with that, we also have another important matrix about the SOC is that it acts as an organization cybersecurity command center. Okay, and that something is there. So let's understand what the why the company need a SOC. The first is that it do the continuous monitoring. Okay, to make sure there should not be any attack happen. Second is early threat detection, security operations center. So early threat detection before it trigger, we can able to detect. Example, like some phishing email is coming. Okay, or in layman term, you can say someone from outside of the society is looking at our society. They just passively monitoring the things, and security guard understand, okay, someone is monitoring our society. So he immediately report the police. So that is called early threat detection before it execute. And if it happen, we can able to respond to the incidents. Example, virus already attacked my system. So isolating a system and everything is part of a quick incident response. Compliance and reporting, because sometimes we need to protect the organizations from the compliance like answerability to the legal authorities and everything. So that is part of a compliance and reporting. And protect the reputation also, because tomorrow, just imagine, if your website got hacked, if your infrastructure got hacked, and that become the news in the market, it will basically impact the reputation. Just imagine you selling security services and your website itself got hacked. So it impacts the reputation, right? And last but not the least, cost saving. Okay, how? We'll discuss in the later stage. So that is why nowadays the company need a SOC people. They will monitor the things, what is happening wrong, what is happening right. And also we monitor what is happening with our competitor, what kind of an attack is happening with the competitors, so that we can able to detect the threats early. We can able to have a quick incident response. If any incident happen, isolate a system immediately. Same like in your society, if any fire occur, or in a locality any fire occur, to reduce the impact of fire, make sure comply with the laws, protect the reputation, cost saving, all those things is basically part of the SOC. So it's very important nowadays in the companies, they go for a SOC, and SOC is also two type. One is you install everything in-house, or second is basically third party provide you SOC as a services, which is called as a MSSP, that I'm going to discuss in the later stage. So now we're going to discuss about a different type of SOC team architecture. The first is called as a L1. Actually, he is the one or she is the one who received the ticket. And whenever you start making a career in the SOC and all that, the 90% jobs are in this vertical only, because they are the like a first responders. So they monitor the SIEM. What is SIEM? In my next, I'm going to cover that. They do the triage mean identifying, sorting, categorizing what is critical, and if something very critical, they escalate to the L2. So when you are a fresher, you actually start your journey with level 1. Then we have a level 2, which is called as an incident responder. So they are the one who investigate, escalate incidents. They conduct the deeper analysis and respond to the incidents by containing, mitigating threat. What is IOCs and all that? Don't worry, I'm going to cover that. Okay. So you can say that level 2 is more C than level 1. Then we have a level 3, which is called as a threat hunters and advanced analyst. They perform the advanced threat hunting and forensic investigation, proactively identifying new threats, new issues, analyze the malware and zero-day threats, and they develop and fine-tune the detection rules for the SOC playbook. And there's a guy who will basically heading or manage this entire team, is called as a SOC manager. He oversee all the things. So it's like we have a L1, we have a L2 and L3, and everything is basically managed by the SOC manager. Okay, so your first goal is to become an analyst, then you have to become a responder, and then you need to become a threat hunter. Okay, so in layman term, you can say the company receive a phishing attack. Investigating, confirming it's a phishing attack, it is triggered by the L1. To identify how this happened, why this happened, it is done by the L2. Identify similar kind of patterns or proactively protect in the future. Then we have a threat hunters, advanced analyst, and make sure they're working correctly and creating a process and policies and everything, and building KPI and demonstrating that my team is working great and all that. That is called a SOC manager. Now in some companies, what happen is we also have one more department, which is called as an incident response team. They work with the SOC during a critical incidents to contain and recover from the breaches. Is it clear? And also provide the recommendation. Otherwise, most of the companies, you can see this hierarchy only. So let me explain you the entire flow, how it works, so you get a better visibility. So SOC workflow is first is we do the continuous tracking of system activities via tool like SIEM. What is SIEM is collecting a log from all the source. You can see it is like a one command control center where we can collect all the logs. As I said, in the future videos, in a future section of this current video, I'm going to cover this, don't worry. So first we monitor, then we do triage. As I said, like when any person go to hospital, it is not possible for the doctor or surgeon to give attention to all the patients. Same like, and then what we do, we understand the urgency and impact. Like, what is the urgency of this patient? And if we don't treat him, what is the impact? Same like we receive multiple incidents on the same time. Now it is not possible for me as a professional that I can able to give attention to all. So I will do triage where I will classify the alert, determine the severity, which is handled by the L1 people because they are the one who classify and validate. We have a playbook, they maintain one rule book and all that, and according to that, they will follow that. The next is basically called investigation. We do the deeper analysis to confirm and assess the incidents, which is handled by L2. And then we contain and mitigate the threats, restoring operation, which is done by the L2 and L3. And then they have a post improvement, which is called as an incident review to enhance the defense and update the playbook. So that's how it basically works. So one more important thing which I miss here is detection. So we identify suspicious activities or anomaly, which is part of the requirement. So first is monitoring, then we identify detection, suspicious activity, then we go for the triage where we classify, categorize what is important, what is not. Then we go for investigation and then we respond to that particular incident and then we try to improve the overall process. So this is the entire workflow we have for the SOC. So now question is, what is the day of a SOC analyst? So he starts the day with handover notes from the previous shift. Its handover is important because SOC is 24 hours. Then we review the priority alerts. That's the most important part. Then we monitor triage. We monitor the SIEM tool for the new alerts. We classify the alerts, which one is low, which one is medium, which one is high severity. Then we do the basic investigation where we validate the alerts by reviewing the logs. We identify the false positive. What is false positive? In my next slide, I'm going to cover. Then if something is very important, they escalate. They document that because they need to maintain the ticketing system. By ticketing system, they can able to track. And then we have a communication. They have to collaborate with the L2 analyst, another team for update. And this is how the end of the day. So focus will be on the real-time monitoring because they are the face. And the challenge they have is they have to handle high volume of alerts. They have to distinguish between the false positive and the real threats, false positive and true positive, and according to that, proactively protect the organization. This is the day of the SOC analyst. So when you start your job and all that in a SOC, this is basically your first job. Now next is called as a L2 guy. L2 is the one who do the detailed investigations, incident response and coordination. He start the day with reviewing the incidents which is escalated by L1. They analyze the logs, network traffic, endpoint activity to get the more visibility, and responding to incidents by isolating a compromised system, work with the L3 for advanced analysis, how it happened, who did this. We also use a threat intel. What is threat intel? In the next section we're going to cover, and we also review the malware samples. Then we follow the incident response playbook for the common incidents. Playbook is just like a diary. You have a diary, right? Where what we kept and all that. So same like they have a diary of step-by-step process. Then they also provide the actionable insights for the remediations that, if this is the issue, this need to be patched. And then according to that, they will update the reports with findings, actions, and recommendation. And this is how they basically do the end of the day. So their critical part here is you need to understand is they focus on detailed investigations. That's a very important part. And they coordinate for the incident response and coordination. And challenge they have is they have to handle all the high critical incidents. And they need to balance the investigation at once. They have to identify which one is important and which one is not. So that is how you basically do the activity. Now we are moving to the next part, which is called as a SOC L3 analyst. So that is basically the last part where we basically review the findings of L2. We plan for threat hunting to identify more important information about the new threats from there. We look for the new threats by threat huntings and by analyzing a pattern in the logs, traffic. In my further video, I'm going to discuss about IOC and IOA. We always have a malware analysis here. We reverse engineer suspicious files using a IDA Pro and Ghidra. Then we fine tune the security tools, like we optimize the SIEM, EDR policies and detection mechanism, and then we have a collaboration with L2 and L1 on the new updates and everything. They also, apart from that, do the new they do the research on the new attacks, what kind of an attacks is happening, vulnerabilities, tools, and then they guide the L1 and L2 analyst on the further investigation. And this is how they basically end the day, and they document the findings, refine the playbooks, provide the recommendation to improve the overall SOC performance. So that's something, the activity they actually follow overall. Yeah. So their focus will be more on this one. The advanced threat huntings, malware analysis, and tuning the defenses. And the challenge they have is they're dealing with the sophisticated attacks, zero-day exploits, and all that. So I will give a layman example. Any phishing attack happen, confirmed by L1, investigate how it happened, from where it is coming, done by the L2. L3, what it does, they involve with L2, but also do the further analysis on the malware with the help of phishing, which is triggered. They also identify proactively what are the other type of phishing activities happening in the organizations or other of the organization. That's what threat hunting. So you can imagine one of the dream job of most of the people is to work on the L3 guys, which is called as a threat hunters and expert. But as I can see in 2025, we can see some emerging role. Like now we have a AI ML specialist who are using artificial machine learning to creating a rules to detect the new threats. So here you need to have a knowledge of data science and all that. Then we have a IoT security analyst. A lot of companies are using OT and IoT, and they want to monitor the alerts on that. So, and the third is important part, is a dedicated profile nowadays companies hiring is cyber threat researcher. It is like a L3, but their focus will be researching on the new attack vectors. TTP stand for technique, tactics, and procedure. Example, like there's a thief who attack your house or attack the respective house. So you understanding his technique, what a technique he used, what tactic he used to target, and what was the procedure. So we use the same technique, tactics, procedure to attack or test the attack against our organization and see, is my organization safe or not. So TTPs, they identify the TTPs, what is the modus of operandi they are using, and they're creating innovative defense. So these are the emerging roles you can see in not only in 2024 we had, but 2025 also the same thing we have. Now there are some tools which SOC analysts used, like SIEM tool, which is used for collecting the information. So we have Elasticsearch, Wazoo, Greyhawk, and all that, and Splunk and everything. So these are the tools we are using for the log collections, correlations. Wazoo is basically SIEM and security monitoring agent-based capability, and Greyhawk is log management analysis, focusing on the speed and efficiency. So as a SOC analyst L2, we have to investigate the packets which is exchanged between the two systems. So how to capture the packets? We have Wireshark and TCP dump. So we capture the packet with the help of these tools. We also install the tool on the endpoint mean like host. So we install the OSSec, which like HIDS, and then we have a Sysmon, which provide the detailed log for endpoint activity. And if you're looking for collecting a threat intel and all that, we are using MISP, OpenCTI. We're going to cover everything in detail. Don't worry. It is just a high level I'm giving. Then for threat hunting, we use Zeek, we use Maltrail, which detect the network traffic and all that. Then for forensic analysis, we use Autospy, Volatility. Autospy used for digital platform for analyzing compromised systems. Volatility used for memory forensic, because whenever any attack happen against any host, memory hold the gold mine information. Then we are also using for network monitoring like Nagios, Zabbix, which is monitoring the systems, network infrastructure. And if you really want to practice your skills on SOC and all that, you can try Cyber Defender, try HackMe, or try HackMe is one of the things. And if you're looking for samples for the packets and everything, then we have other open source websites. So these are some of the tools that as a SOC analyst you must be familiar with. So let's start now the basics. Okay, this is just a basic benchmark I want to explain. And now let's start with an action. We're going to start with the first, called computer network. So I want to start with the, a very important stuff, which is called as a computer network, because when you're doing a monitoring and all that, computer network, basically by end of the day, you're doing a monitoring on the computer network only. So what is computer? Is a system which process the information, and if we have a group of computers over the space or network, that's called computer network. So in layman term, you can say computer network is a group of interconnected devices that are communicate and share resources with each other through the wired or wireless communication. I repeat again, computer network is like a group of interconnected devices. So let's say example, we have a device 1, computer 1, we have a computer 2. It can be directly connected via media, which is called wired or wireless, or they are connected by the help of one device, which is called switch or hub, that I'm going to discuss in next slide. So these are the devices we have. We have a cable by which they connect. So that's why called as a computer network. Now we have a different type of computer networks, but here what happened is we need to understand the key component first. So here the key component of the computer network is computer A itself and B. Switch is the component which is used to connect the multiple systems, and then we have a cable which help them to connect the systems, or wireless. Now we have a different type of computer networks. The first is called as a PAN, personal area network, a small network of personal devices like smartphone, tablets. Okay, they are connected by the Bluetooth connection or hotspot. Example, like, you know, when we don't have a WhatsApp feature, what we used to have via the Bluetooth, we exchange the information. So that is a network called personal area network, or you enable the hotspots and multiple devices are connected to that in a particular distance. Second is called as a LAN, local area network. LAN is a network confined to a small geographical area. Okay, so let's example, I go to the office. So if I go to my office, I can see the group of systems there. So the network within that particular office location, within that office, that is basically called as a LAN. Or when I see the Wi-Fi that I use at home and we have a multiple people connected with that within that house, that is a LAN. Now next is called as a MAN. MAN is basically stand for Metropolitan Area Network. So I have a multiple branches. Okay, in a respective city, they are all connected with that. So that is basically called as a MAN, which cover the city or large campus connecting to the multiple LAN, or you can say city-wide Wi-Fi network, you know. And last is called as a WAN, wide area network. A wide area network means a network that span large geographical areas, such as connecting multiple LANs. And best example is internet. Like with the help of internet, you can connect to any server from anywhere. So that something is there. So by end of the day, SOCs are basically doing a monitoring on the PAN, LAN, MAN or WAN. Now we have some devices which works on the computer networks, because another important component we have called networking devices. Networking devices are the parameters, are the device by which systems communicate. So first device is called as a hub. Hub is a basic networking device which connect the multiple devices in a network. See, if I have a system A, okay, I log into the system, I'm doing my activity, but now system A want to send some data to system B. How to send? One is direct cable. Fine, I can directly connect the cable, that is possible. But now we have a system C, system D. Now I need to install 4 cards in this laptop, then only I can able to connect. Instead of that, what I did, I connect with the hub. So they are connected with the hub, and through that A, with the help of hub, can able to send data to the D. But problem with the hub is a broadcast device. What is the meaning? It means if A send the data to the hub, hub will broadcast to all the ports. In layman term, it is just like a main switch of your house. If you switch off that, it will shut down the entire light. That is why it is called as a non-intelligent device. Second is called as a switch. Switch does the unicasting. Broadcasting means one to all, unicasting is to one to one. So in switch, what happened? This is my switch. We have a system A, we have a system B, and we have a system C. Okay, so we have a system A, we have a system B, and we have a system C. So they are all connected with the switch. Okay, so A is sending data to switch, and switch will send data to the particular port only instead of doing a broadcast. How they do that? Actually, what happened? It maintains the MAC address, which is the physical address of your system. So when A is sending a data, they check the destination MAC address on which particular port, and on that particular port only it sends the data. That's called switch connecting a multiple device, and they send the data to the particular system. But firewall is a device which is used to protect the organization from the external attacks. Exactly, that is called firewall. So we have a system A, we have a system B, we have a system C. Make sure no unauthorized traffic to come to the network. That will be protected with the help of firewall. So it's a network security solution, or it is a device that monitor and control incoming and outgoing network traffic based on a predefined security rule. You can say it is just like a guard standing on the main gate to ensure only authorized people will be allowed to be entered into the apartment, or it is just like a bodyguard who was standing outside of the club and he maintained the guest list and make sure anyone which is not in the guest list cannot able to access the club and all that. So one more device which is missing here is router. Router is a device which is used to connect to different network. Example, like we have a network here and we have a network here. So we have a system A and we have a system B. So this is one LAN, this is one LAN. But now this LAN want to send data to this and this LAN want to send data to this. So here we introduce a concept which is called router. Okay, so router is a device which is used to connect two different network on the same time. So now let's discuss about the type of address. So we have a two type of address, IP address and MAC address. IP address is a logical address and MAC address is a physical address. Okay, like when you buy a phone, you have a IMEI number, that is a MAC address, and the number that you purchase is a IP address. So you can change the number, you cannot change the IMEI, right? So IP address is a logical address used to identify device on a network, but physical address used to identify device on a local network. IP address work on the layer 3. In my next slide, I'm going to cover OSI model, and MAC address work on the data link layer. Now IP is also two type, IP version 4 and IP version 6. So when you're talking about IP version 4 is basically have a 32-bit address, and IP version 6, IP version 4 has a 32-bit and IP version 6 has a 128. So today we prefer to use 128 because of space and all that. IP version 4 is a dotted decimal, 192.168.1.1. We just taking example. IPv6 is a hexadecimal where the values range we are using from 0 to 9 and A to F. 0 to 9 and A to F. And MAC address is 48-bit. So as that IP version length is 32 and 128, and MAC address is 40. I apologize for that. MAC address is 48 bits. So IP address is logically unique within the network and can be changed, and MAC address is physically unique, assigned by the manufacturer. So IP address we assign with the help of network administrator, and MAC is burned into the network interface by the manufacturer only. So we can change, but MAC address cannot be changed. Now IP address itself is two type. One is called public IP and one is called private IP. Private IP is a IP which is used within a LAN. You don't need to pay for that. But public IP is IP that you have to pay for the IP. Example, like when you subscribe to any internet connections and all that, you get a public IP by which you can able to access the internet, everything. Is it clear? So that something is there. So address is very important because as a SOC analyst, when you're investigating attacks and all that, you need to identify from where the attack is happening to where the attack is going. So that's why the IP address is very important for you to understand. Okay, so let's move to the next part. Okay, so now we're going to discuss about the data flow. It's very important as a SOC analyst. You need to understand, you're going to investigate network, you're going to investigate the traffic and all that. So you need to know the basics of traffic. So we have a three type of data flow. So we have a system A and we have a system B, hypothetical scenario. So we have a three way to send the data. The one is called as a simplex, which is a one way. It means one person sending a data. Okay, simplex is one way. Okay, it just like I know, yeah, FM you are listening and all that. That is basically one way. Second is called as a half duplex. It means two way, one direction at a time. It means if A is sending, he will send first and then B will basically send. That is called as a half duplex. Full duplex is you also sending and B also sending. Okay, so simplex is one way, unidirectional radio broadcasting, or when you enter keyboard on display, it will be one simplex. Efficiency is low and analogy is one way street. Half duplex is two way, which is one direction at a time, bidirectional, alternating, like walkie-talkie. You know, when you speak on walkie-talkie, hey, hello, Charlie, 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 over. Then the second person says, so that is called as a half duplex, walkie-talkie, Ethernet hub, medium, one lane bridge with the traffic light. Then we have full duplex, like on a call, you know, when you're speaking to your partner also abusing you also abusing on a parallel. So that is called as a full duplex, two-way communication. Okay, so telephone, conversation, modem, Ethernet, It is highest and all that. So as a SOC analyst, you should know the basics of data communication. And we have these 3 types of data communication. And this is how the data communication evolved. First, it started with simplex. Then it introduced half duplex. Today, what we use is full duplex. Okay, so it's very important for you to know this duplex. Okay, so next topic is called as the topology. See, when you're working on the network and all that, you should know the basics of topology. What is topology? So topology is called as a layout of the network. Layout of the computer network. See, when you're building a house, when you're constructing a house, you design the architecture, right? Same like when you building a network and all that, first you design the network, and that is called as a topology. And we have a different type of topology. The first is called as a bus topology. Bus topology is like we have one cable and all systems are basically connect with that system. All systems are connected with that cable. So data is passed to this cable. Okay, but problem is that if the cable is down or damaged, then entire data flow communication get impacted. So that is called as a bus topology. And this is your traditional network. So if you talk about 20-25 years back and all that, when we talk about computer network, this is how it looked like. So we have one coaxial cable here, coaxial cable. How to understand coaxial cable is that cable TV network we used to have in the black. So we used to have this one coaxial cable, and from there we give a connection to all the computers. Okay, so that is called as a bus topology. In cable TV network also we use that. Second is called as a star topology. Star topology mean we have one device, hub or switch, and all systems are basically connect with that. But problem is that if the hub is down, everything is down. Then we have a tree topology. Now tree topology is we have a bus here and one is basically connect with the hub, and we have other systems which directly connect with the cable. So all data is going through that only. But if cable is down, everything is down. That is called as a tree topology, which is a combination of bus and star, bus and tree. Bus and star. Next is called as a ring topology. Ring topology is all systems are connected. It is used in IBM. So there is a token used to have. So token, it's basically passed like that. Whoever want to send the data, he will attach the token, grab the token, attach the data, and then release the token. And whoever want to receive the data, he will grab the token and copy the data. So that is basically called as a ring topology. But one of the most secure topology is called as a mesh. In mesh topology, one system is directly connect with the other system. One system directly connect with the other system. And this is today we use in data applications and when you're sending a sensitive data and all that. But problem with the mesh topology is the scalability. It will not able to scale up more resources, more systems. Otherwise it will create some kind of complexities and all that. So these are the type of topology we have. So before building a network, we design this network. Now next topic we have called as a protocol. Okay, so next topic is called as a protocol. See, we understood about IP address, we understood about the MAC address, but there is a set of rules computer has to follow, and through that only two systems can communicate with each other. I'll give an example. Okay, so protocol is nothing. Protocol is called as set of rule. Now, if you take an example of this video, I'm speaking in English. English is a one language that we follow. We follow one set of rule of English, and that is the reason everyone can able to understand. If I'm speaking in the Malayalam community, then I have to speak in Malayalam. Malayalam is a protocol there because destination also understand Malayalam. If I'm speaking in a North, in a Hindi and all that, they also understand Hindi. So we are using some rules, we're using some parameters, and by which we are explaining the topics. So we agree both sides that we'll use English as a communication parameter to communicate in two systems. So same like when we have a system A and we have a system B. When they communicate to other system, okay, they communicate through a particular port. Okay, port is the address, like we have an IP address, so by which we can locate a system B. But in the system B, I want to speak to a particular application. So that application has a port number. Like example, like I'm trying to connect with the website. So this is the website. Website IP is 1.1.1. So I can able to identify the location. But in the website, I want to understand the HTTP parameter. So I want to communicate either on port number 80 or 443. Okay, so every application, whatever is working, they listen the data from a particular port number. Like I'm connecting a telnet on the target system. So I need to know the IP of the system that is used to locate the host but on that host, I want to connect to a particular application, and that application has a particular port. So protocol is a set of rules and standards that define how device communicate, exchange data over the network, and it ensure the device, even from a different manufacturer or running different software, can understand and interact with each other. In simple term, protocol is like a language for a computer to talk to each other. Now, without IP, can you communicate? No. Without adding a preferred DNS, can you able to translate the name? So it is a set of rule. It is a set of rule. Like you need to add the preferred DNS, then only you can able to translate. You need to type HTTPS, the URL of the website, then only you can able to access the page if on the destination the port number 80 or 443 is open. And that is the reason it's very important. So when we're talking about protocols and the ports, we have, so you can see major protocols are work on the transport layer. So we have a TCP and UDP. TCP is the connection oriented and UDP is the connectionless. Same like, when you speaking to your friends, you start with hi, hello, how are you? And it can go up to 1 hour. That's a TCP. Same like here in TCP, what happened is we have a system A. So we have a system A and we have a system B. Before they send the data, they send the SYN packet. SYN is just like, hello, I'm audible. They said, yes, you're audible. So he also sent the SYNAC. And then he sent the acknowledgement. This is called three-way handshake. But in the case of UDP, this is called TCP. In the case of UDP, you just simply sending a data without considering any response from there. It is same like, speaking to your friend, you start with hi, hello, how are you? But when you go home and your partner say, where is a paneer, where is a milk, where is a curd, simply. So when you're having a conversation between the partners, when you're having a conversation with the partner, it's like a UDP, it's prone to error. It starts with no logic and finish at no logic. So port address operate at the transport layer. Okay. Port address protocol works on all the 7 layers of OSI, but all the 6 layers, which is like application, presentation, session, transport, network, data link. But when we're talking about physical layer, we don't have a protocols. So purpose of the but port addressing is done on the transport layer. So what is transport layer of OSI? We're going to cover in my following slides. Okay. So when you're talking about the port address, it targets a specific application or device. And usage is only for the service identification. As I said, like I am a system A and I'm communicating with the web server. I'm communicating with the web server. So I have to send the request. I'm using HTTP. So HTTP only listen on port number 80. No, I want to take a remote connect. That is only possible if I establish a connection on 22 or 21. Example, I'm giving FTP and all that. So every service listen through a particular port number. That port addressing done on the transport layer. On the other side, IP address, IP work on the layer 3 network layer, target the device itself on the network, and it is for a device or identify the host in the network. So in layman term, if I say I'm connecting on 192.168.1.1, it identifies device on a LAN. But 192.168.1.1.80 indicate HTTP service running on that device. Okay, that's the important part. Now, another important thing when you're talking about port address, port has a classifications. Okay, port is been classified by ICANN. So ICANN is the authority who classify the port. So we have a 3 range of ports, 0 to 1023, which is known by Microsoft also, Linux also, Apple also. Example, HTTP, right? It can be used by Apple also and Microsoft also. So it's a well-known port. Okay, reserved for the address by INA. So HTTP, HTTPS, FTP, DNS, it's used by Mac, Apple and all that. It's a fixed assign for the standard protocol, not a vendor centric. Then what happened? Microsoft has registered some ports. Linux has registered some port for the services. So it is reserved for a specific application, but not as a strictly standardized. So Microsoft has reserved some ports for the SQL. Apple has reserved some ports. So that is basically come from this range, which is called 102.4 to 491.51. And then we have a 491.52 to 65,535. That's called dynamic port. Anyone can use that. It is temporary assigned for the outbound connection or inbound connection. Because when any client initiating connection, suppose we have a system A and we have a system B, and they are connecting with the server, which is called web server. They're connecting on 443. So both are connecting on 443, but how the web server identify who connecting? So here the source will be any random port, which is like a 109000. Here also 10, or let's say example 49153, 49154. So source port is this, but destination port is same. So by identifying which source is sending this packet, we are using this dynamic port. So dynamic node always used by source for sending a data, which is randomly assigned for outbound connections like web browsing, video streaming, and all that. So as a SOC analyst, you should know this, and that's why it is asked in the interview also. Okay. Now we're going to discuss some of the protocols which is used for remote management. What is remote management like? I'm a SOC analyst. I want to remotely connect to SIEM. So we have to connect to the SIEM through a particular port. Let's say example, we have a system A. Okay, and this is my system B. So today, if any friend has reached out to you and said, I want to troubleshoot my system. I want to troubleshoot, like, I'm facing some issues. Can you take a remote access of my phone? So we use this tool, VNCs or AnyDesk and all that, right? And through that, you can take a graphical access of the B system. But it was not like that 20 years back. We used to have a DOS-based systems. So we basically take a remote connection of the command prompt. Like today we see a CMD command prompt. So we take the remote command prompt access and then we send something via command. Problem is that anyone can able to intercept that. But Telnet was used for the remote management. So we have other protocols also which is used for remote management. Let's take example, I'm a firewall administrator. Today I'm working from home, but I want to connect to the firewall interface. So I will use this SSH and all that to remotely manage the firewall. So that's why we have a different type of remote management protocols that we need to understand. Okay, so the first protocol that we're talking about SSH, as I said, Telnet send the data in a plain text. So we were looking for an alternative for remote command that we can use to send in a secure manner. And one of the popular is called as a SSH. So we have a system A, we have a server, which can be firewalls, anything, or server. And I will try to establish a connection on port number 22. And through that, I will send the data. And by SSH, it offer you multiple things. It offer you encryption, compression, authentication, accountability, integrity, and all that. So today, if you're talking about remotely managing the servers, remotely executing any kind of a commands on the remote firewall, remote server, we use SSH. And this is the interview question. What is the, they will give you scenarios which say, okay, you are working from home and you want to connect to the firewall. What kind of a protocol you use for remote management, remote command. I repeat, remote command. So we use SSH. It's a secure protocol for remotely managing a server and device. So use case like accessing Linux system for log analysis, configure device remotely, and security feature is encrypt communication in public private. Second is RDP. If you're looking for graphical access remotely, you want to take a graphical access. Then for Windows system, we have RDP protocol. Remotely, I want to take an access of the system, investigate the incidents, monitoring the Windows server, support encryption, MFA. But if you're looking for vendor neutral, which can be work in Microsoft, also Linux, also we use VNC, a graphical remote access, which can be for GUI requirement. Basic encryption is there and it can be enhanced with the help of SSH. Telnet, as I said, it sends the data in a plain text. We also have one more protocol called SNMP. SNMP is used for remote monitoring. Like I want to monitor my systems remotely. I want to monitor the logs remotely. I want to monitor the device remotely. So we use one protocol called SNMP. It is used for monitoring and managing network devices. Okay. So we can gather logs or metrics for the network devices, and current version is SNMP version 3, which is more secure. Then if you're looking for web-based interface access, like I want to connect with SIEM over the web, then we use HTTPS. I want to connect with a remote server over the web by HTTPS, so I will use HTTPS. So it's a protocol for access management dashboard for device or application. Like if you want to access remotely VMware administrator access and all that, today when you access the AWS consoles and all that, what you do, you go to browser and type https server.com or aws.com. So with the help of HTTPS, you can have a web-based access. HTTP is also there, but HTTP send the data in a plain text, but HTTPS send the data in an encrypted manner. So today, SOC Analyst using to remotely accessing the firewall web page, SIEM dashboards, and cloud management tool. So it offers the TLS encryption, which is use the AES for the encryption. We also have one more thing which is nowadays are using is called PowerShell remoting. It is a protocol for managing Windows system remotely via PowerShell. You can say alternate of Telnet and alternate of SSH. And these are basically used for automating your incident response task. And more important, it is used for fetching the logs from endpoint. Okay, then we have a net flow. It is again a protocol for analyzing the remote traffic, network traffic. It is used for monitoring the anomalies for data exfiltration, and it is a secure implementation depending upon the collector. And then we have a RPC. See, RPC is used for execute the process. If RPC service are disabled, then it is difficult for you to execute the function. So RPC is very important. It is a protocol for executing process on a remote systems. And it is exclusively used for managing Windows services, and it can be secure using a firewall and network restrictions. I don't want someone to set up a connection with the remote server over the RPC. So these are protocols we are using for a remote management. Now we're going to discuss about some common network protocol, which is called as we discussed that the TCP and UDP. TCP is a three-way handshake we set up and then we send the data. In UDP, we don't follow any three-way handshake. We simply send the data over the network. So that's called TCP and UDP. So if you open YouTube and all that, okay, so first time when you open the YouTube page, it is happening on TCP. But when you start playing videos on YouTube and all that, it is happening on UDP. So why it is important for a SOC analyst to know TCP and UDP? Because we have a SYN flood attack where we monitor the three-way handshake of SYN and we analyze the packet flow for anomalies. There we need to intercept the TCP header and all that. And why we need to know UDP? Because when we're having a DOS or DDoS attacks, we'll discuss in later stage, we need to identify how the UDP packets are generated. And that is the reason it is very important for the SOC analyst to know how it works. Hope it is clear to everyone. So these are the two communication protocols we have, and all the protocols come under this category only. You know, this is the two major category, and under which we have a subcategory. So DNS can be UDP, TCP. So TCP, UDP is just like a family. We don't have a TCP as a protocol. TCP is a protocol representation. Okay, so DNS is a UDP, it work on TCP also, HTTP work on TCP. So TCP, UDP is a functionality that we are using, and through that we're doing a communication. Okay, that is how it works. So now we move to the next part, which is called as a network management protocol. So when it comes to network management, network troubleshooting, as a SOC analyst, definitely you're going to encounter these protocol ICMP, SNMP, and ARP protocol. So first we're going to discuss about the ICMP, Internet Control Messaging Protocol. So we have a system A and we have a system B. So A want to check whether system B is available. So we use the command called ping. You know what is the full form of ping? Ping stands for packet intranet grapher. So it is a protocol by which you can able to do the ping connectivity. So what I did here is I type ping space IP address, and I send the ICMP echo request. I send ICMP echo request to the target system. If port is up, if system is up, it will give me the echo reply. So ICMP is a protocol which I'm using for investigating a network issues. Tomorrow I'm trying to connect the website. I'm unable to load the page. So I will use ping space IP address and check the connectivity. If I'm getting request timeout, it means the system is up or network is down, something is there. So ICMP is used for remote troubleshooting. So it is used for diagnostic purpose like ping and traceroute. Ping is basically check the connectivity, traceroute get to know where the packet get dropped. Okay. So why it is important for the SOC people? Because there's a lot of DOS attack happen through the ICMP. Multiple packets will be sent. So we have to investigate from where it is coming, and ICMP works on the layer 3 of the OSI model. Next is called as a SNMP. In my previous diagram, in previous section, we discussed about SNMP. Let me explain you what is that. Simple Network Management Protocol. It is a protocol which is used for monitoring, manage and configure devices on a network. So if you take example today, any monitoring software. So let's say example, this is my server. And I have some clients here, or it can be server. Okay. So in this case, we called as two things, SNMP manager and SNMP agents. SNMP manager or SNMP agents. So we have two important thing here. Exactly. So SNMP manager and SMP agent. So that's something we need to understand. So when we're talking about the requirement of SNMP agent and SNMP server, so server is basically connecting with the systems. That is how it works. Yeah. So that is how it works. And according to that, So clients are basically sending the information to the server here. So agents, okay, are running here and they're sending information to server. That is how we have. So now what happened is when you're talking about SNMP manager, it is basically like a centralized system that query and receive information from network device, and agents are running on the network device like router, switch that respond to the changes. Now server maintain one information called as a MIB, management information base, a database structured information about device resource and configuration, and every device has a OID, object identifier. It is just for reference. Okay, so how it works is SNMP agent is installed and running on the device here, okay, and SNMP manager here. So they send the information to server. SNMP manager basically monitor the things and remotely they troubleshoot the things. So agents can basically, or the server can remotely able to manage all things, monitor everything and check everything. So it has a 3 version, SNMP version 1, SNMP version 2, SNMP version 3. So if you take an example from an interview perspective, remember SNMP version 3 is more secure because it provides the authentication, encryption and message integrity. Along with that, SNMP version 3 is configured on the private strings. So we have a 2 type of strings in SNMP, public and private. Public is like read only. Anyone can connect with your SNMP port number 161, 162, and you can able to extract how many services are running, what are the users we have, which is a concern. So we need to shift to the private string. So private string is basically mean read and write. You need to have authentication, then only you can able to connect. So today when we running any kind of a monitoring tool and remotely want to monitor any device, we have to enable the SNMP services which work on the port number 161 and 162. Okay, so next is called as a ARP. ARP is a protocol which translate IP to MAC and MAC to IP. And today it is used for the remote management from the sending data traffic. So let's say example, we have a system A and this is my switch and this is my system B. Let's say example, here we have a router. So B configure, A configure, B configure with the IP called 10.0.0.1 and B MAC address is 9B at 7. A IP address is 10.0.0.2. His MAC address is 8B at 7 and router IP address is 10.0.0.3 and MAC address is 9B76. So A maintain the ARP table. This is how the ARP table look like, in which we maintain the neighbor IP and MAC address information. So 10.0.0.1 and MAC address is 9B at 7. 10.0.0.2, the MAC address is 9B at 6. So when A want to send the data to router, because the gateway for him is the router only, so they will say 1.10.03 is basically mapped to which MAC address, 9B at 6. So that has a 9B at 6 and through that it send the information to switch. Switch work on the unicasting, they will check this MAC address 9B at 6 on which particular port, and on that particular port we send the data. So ARP works on the layer 2. It resolve IP address to MAC in a local network, and it is also become an attack target for the people. So these are the protocol we have, but we also have some kind of a you can say web application protocols that you also need to know. Example, HTTP, HTTPS. Whenever you're trying to connect with any web server, or you want to connect over the web, so use HTTP or HTTPS. DNS is a protocol which is used to translate name to IP, because you know it is difficult for you to remember the IP address of any server. So here we have a DNS. Here we have a DNS, and this is my web server. Web server IP is 1.1.1.1. So in the DNS, we maintain the record that if anyone requesting for kk.com, it mapped to 1.1.1.1. So now a user in preferred DNS, he give the IP of the preferred DNS IP. So DNS IP is 2.1.1.1. So he had 2.1.1.1. So then he typed kk.com. The request goes to DNS. DNS will check into records. kk.com is mapped to which IP, and then it provide that IP 1.1.1, and through that he connect with the respective web server. That's a live example of DNS. DNS is service which translate name to IP and IP to name. So today, as a SOC analyst, you should know DNS and all that, because 90% of attack they're targeting a DNS, because by manipulating a DNS, we're redirecting a user traffic to some other websites. You can understand DNS is a name translation, right? It is just like, you know, you have a phone. Now in phone, you have saved your girlfriend number or boyfriend number with same name. Now someone hack into your phone and change the name. So when you try to type the name, it translates to someone else's number. You're getting a point. So that is why today DNS security is the most important thing. Then over the web, you want to access the file server. Over the web, you want to access the file window. We use FTP. FTP is a protocol that we use for that reason. Okay, 2021 is the port we have, which we use. FTP defaults in the data in a plain text. So we are using FTPS or SFTP. FTPS over the SSL. SFTP is on port number 22. So when you're sending any kind of email by email server, we use one protocol called SMTP. But when you're receiving an email, you use the POP3. SSH we already discussed, which is used for the function. So these are some of the web application protocol, and as a SOC analyst, you should know, because sometimes what happen, you have to investigate the email server logs. So you should know, okay, some mails are coming, so SMTP is involved. Sorry, mails are sending. So SMTP is a protocol. It is used to sending an email outside, and POP3 is used for recovering. So whenever we're receiving any kind of phishing emails and all that, we have to investigate POP3 logs. Understood? And when anyone sending data outside, or any attacker remotely connecting to server, mail server and trying to send the data, we're investigating SMTP traffics. So it's very important that you have to understand how SMTP POP3 works. Then we also have another important protocols, that is, as a SOC analyst, you should know SMB, very, very important, server message block. So if SMB service is disabled, you cannot able to share the files. So SMB used for sharing a file and printer in window environment. It is just like you go to library and they have a entire panel where the files are located. So SMB is like that only, server message block. It's inventory where the services are there. So if SMB services are disabled, you cannot able to send the file. And as a SOC analyst, you need to investigate the SMB logs, because when any attacker access to your internal network, he do the movement from one system to other system. So we have to investigate the SMB traffics. So as a administrator, as a SOC analyst, you should know how SMB works. Then RDP we already discussed, remote desktop protocol. So you have to also check for the RDP ports, because hackers, when they hack into the internal networks, they actually hack by the RDP ports and all that. So you have to investigate any kind of an attempt, brute force attempt has been done on the RDP port 443 or something else, or detect the suspicious remote connections. So that something is part of the requirement. Okay, so we're going to discuss about now network connecting and troubleshooting protocols that you're going to use, or command utility that you're going to use when you are in L1 positions. Like ping is testing the connectivity to specific IP and host name. That's something we are using. The second one is called as a trace set and trace route. Whenever you want to understand the packet drops, you type trace set space the destination IP address. You will get to know where the packet get drops and all that. So we are using this to display the path packet take to reach the destination. The next one is called as a NS lookup. So NS lookup is a tool utility by which we can able to resolve the DNS name to IP. You open the NS lookup in Windows Linux, enter the domain name. If it convert into IP, it means it is working effectively. Then we're using dig. Dig is just like a NS lookup. We perform the detailed DNS query better than NS lookup. Then we have a telnet. Telnet is used for remote commands, but we don't use today because it sends the data in a plain text. So we use the alternate of telnet, which is called as a SSH. Then we also have a curl, curl, which basically tests the connectivities, tests the HTTPS connectivity and retrieve the content from URL. We are using this when we're doing a malware investigations and when we're doing OS fingerprintings and OSINT. Then we have a wget is a utility. We download the files or content from the specific URL. So we use a wget. So there's again a utility in the Linux and Windows. So these are the network connectivity and troubleshooting commands we are using. Otherwise, we also have assist internals window utilities, which is also used for the same thing. Now, next topic is OSI model. For that, I have already recorded one video. Please check that OSI model video. Thank you.
Okay. OSI model is a very important topic for the CISSP aspirant, CISA, CISM, and it is also good for the COMSHI and all that. So I always love to do whiteboard presentations. So I thought today I will do some whiteboard presentation on OSI model. So OSI model is a reference model which gives the visibility about how two systems communicates with each other. Because when in 1969 when network was formed, we need to understand if we have a system A and we have a system B, okay, how two systems are basically communicates with each other. So that visibility we need. to understand that visibility, we introduce this reference model. Later on, we also introduced a TCP/IP model because the network was formed based on the TCP/IP suite. But to understand, have a better visibility, we have launched this model, which is called as a OSI model. Actually, OSI model was introduced with the objective of how destination receives data. That is why the first layer is always a physical layer. Then we have a data link layer. Then we have a network layer. Then we have a transport layer. Then we have a session layer. Then we have a presentation, and then we have a application. So OSI model was basically introduced with the objective how destination receives data. But whenever any trainer or any consultant or any presenter try to explain OSI, he always use source and destination concept. So here we have a source and we have a destination. Okay. So when you're talking about OSI, we're starting with the source and we're finishing at the destination layer. Okay, I will try my best to explain in a very simple layman term. Okay, so a user normally is interacting on the application layer first. Let me give an example. You open a browser and type. So you open a browser and type gmail.com. So you type gmail.com. That was a browser, you open gmail.com. So it is a layer where you're interacting. Okay, like because that is called as a live interaction we have. So it is a layer where you're interacting with the application. So first question, whether it's an interview or exam, which layer where the user is interacting? The answer is application layer. So it is a layer where the user is interacting with the application. So when you type https gmail.com, you're actually interacting on this layer. Now you basically move to presentation layer. Now presentation layer is responsible for presenting a data to the lower layers. They have a two major functions. One is called as an encryption. One is called as an encoding, encryption, and the most important thing is compression. So they basically encode the data, they basically encrypt the data, they basically compress the data. So their ultimate goal is to shrink the data in such a manner that my lower layers can able to understand. So ultimate goal of the presentation layer is to present the data. Okay. So data was presented by compressing, encoding and all that. Then the data is basically moved to session layer. Session layer is the layer where the user is interacting with the destination session layer. The difference between the session and connection. Normally you open internet connection. Okay, so in the internet connection, you can able to connect with the multiple sessions like GoToMeeting, Gmail, Facebook and all that. Same like whatever the application you decided through which you're interacting, HTTP and all that, it create a multiple session. So session initiation between the two hosts first is done on the session layer. We have a two type of session, half duplex, full duplex. Okay, half duplex is you are saying, then he will listen, then he will say back. Walkie-talkie, that is called as a half duplex. Full duplex is you also saying, he also saying. Fight between husband and wife, that is a full duplex. But sometimes you also work in a half duplex where you just listen to the wife. Okay, I'm not against anything, I'm just giving example. Vice versa. So session layer is the layer which is a first layer which is initiating a session between the two systems. Now we basically move to the transport layer. Transport layer where we have a message. The message is divided into segment. The message is divided into segment. And that segmentation happens on the transport layer. Quick question in the exam. Segmentation occurs on which layer? And that is happen on the transport layer. So segment 1, segment 2, segment 3 and segment 4. Each segment has a sequence number. So that destination transport layer, because data go like this, destination transport layer use the same sequence number by which it will reform the data. So first thing you need to remember is segmentation occurs on transport layer. Second thing, transport layer basically has a two type of protocol. One is basically called as a TCP and one is called as a UDP. TCP and UDP. So when you're talking about TCP, TCP is a connection oriented. What is that? Suppose this is the system A and this is my system B. Now A wish to communicate with the B, but we need to make sure the port is open or not, because port communication happens on the transport layer only. So he will send the SYN. If the port is open, he will send the acknowledgement hi, and then he basically send the acknowledgement. Because he sent the SYN, then he send the SYN plus acknowledgement of yes I received, and he also sent the SYN, and then he sent the acknowledgement. This is called as a three-way handshake, which is actually happening in the TCP. But in the UDP, without this handshake, we are initiating a communication. The perfect example is when you open a YouTube. In YouTube, what happens is you type youtube.com, so you are actually establishing on the TCP. But once you play the videos and all that, audio streaming, video streaming, that is happening on the UDP. So UDP is basically established without three-way handshake. So TCP is faster, UDP is basically slower, because TCP think and then it send, UDP is randomly send the data. So lot of error issues are coming in the UDP, but UDP is faster than TCP. So these are the two protocols which is basically work on the transport layer. Another important thing is called as a flow control. Flow control. Flow control means this is my host A and this is my host B. A basically send packet 1, packet 2, packet 3. The fourth will be coming from the B. It means he received the first 3 packets. So by this way we get acknowledgement that yes, we are on the same page. Same like when I used to conduct a session, after 15 or 20 minutes I used to ask, is that clear? Is it clear or not? So I need to make sure we are on the same page. Instead of just sending a data and on the later stage I understood that okay, they are not receiving a data. It is like an overflow. So maintaining a flow control is also done on the transport layer. They use a windowing concept. So summary here is transport layer basically has a segmentation where the data divided into segment, and each segment has a sequence number. So the destination transport layer, when it receives each segment with the help of sequence number, they reform the data. Another important thing, they do port addressing. Port addressing. Whatever the application decide, the application parameter, all those applications sending a data through a port, and that port addressing will be done on the transport layer. Example, when I type HTTP, so that is I'm interacting on the application layer. But that HTTP receive a data on a particular port, and that port addressing done by the transport layer. Okay. We have a 3 type of port categories: well-known port, registered ports, and ephemeral ports. In CISSP, ephemeral port is important. I'm making one coffee shot video after this particular session, so you get a better visibility on that. So we have a 3 type of port categories: well-known, registered, and ephemeral port. So transport layer is one of the most important layer we have in the OSI model. Now what happens is, when each segmented data, so segment 1, segment 2, segment 3, 1, 2, 3, 4, then each segment data is further moved to network layer. It is further fragmented into packets. I repeat again, each segmented data, segment 1, segment 2, segment 3, segment 4, each segmented data is further fragmented into packet 1, packet 2, and packet 3. Quick question in the exam. Fragmentation occurs on which layer? The answer is network layer. Fragmentation occurs on which layer? The answer is network layer. Network layer, let me draw it again. So if you see here, we have a segment 1, 2, and each segment we have a packet 1 and packet 2, packet 3, packet 4, packet 5, packet 6. So each segmented data is further fragmented into packet 1, packet 2, packet 3, packet 4, packet 5, packet 6. Now each packet, if I say packet here, each packet basically has a source IP and destination IP. Source IP and destination IP, from where we need to send and to which host we are sending. So network layer is responsible for defining a logical addressing. Okay, Smurf attack occurs on network layer. Please note down from a CISSP point of view and CSAM. Smurf attack occurs on network layer. Router device work on the network layer. IP addressing done on the network layer. So all the IP which we are assigning to the each packet, it is done on the network layer. So we have a two type of protocol. We have a two type of protocols which work on a network layer. One is called as a routing protocol and one is called as a routed protocol. Routing protocol and routed protocol. When you're talking about routing protocol, example of routing protocol is RIP, and we have a OSPF that is called as a routing protocol. Routed protocol is IP, IPX. So routing protocol define the route and routed protocol carry the data on that route. Okay. So these are basically called as the two type of protocols, and mostly connection-less protocol works on the network layer, who is responsible for just delivering the data on the defined address. It doesn't matter whether it reads or not. So when every packet, so this is the packet we have. So where we are assigning a source IP and we are assigning a destination IP. So the destination network layer will basically use the same IP and destination by which you will verify. Now what happened? The data moved to data link layer. Sorry, packet, because packet is formed on network layer. Each packet moved to data link layer. Now data link layer has a two sub layer. Okay, one is LLC and one is MAC. So we have a LLC and one is basically called as a MAC. LLC is the one which is coordinating with the network layer. LLC is called as a logical link control. It is a layer which is coordinating with the network layer. So it means when we receive a packet, suppose this is the packet we received. Okay, we receive a packet. Now in that packet we basically add, so this is the packet we received. We add source MAC, we add destination MAC, and we add tailor, which is like a CRC check. So when you add source MAC address, destination MAC address, because we need to give physical address, source MAC address, destination MAC address, and tailor, which is just for the integrity check, it formed a frame. We call it as a frame. And that frame is basically hand over to MAC. So when you add to the fragmented packet, each fragmented packet, source MAC and destination MAC and tailor, it become a frame. And that frame is delivered to MAC. What MAC does, MAC will unstructure the data and hand over to the physical layer, and physical layer convert the data into binary. Actually binary initiate by the MAC and hand over to physical layer, because there is no protocol working on the physical layer. So when data is in a physical layer, it is in a binary format. Okay, in a form of electrical signal. So this is how we basically add the process. Now if I go by application presentation layer, so we have a data type is message, and we add the respective header, which is called as a application header. Then we move to presentation header, where we have a message type, we already have an application header, we adding a presentation header. In every layer we are adding a header. Then we have a session layer. Here data type is message. It already have an application header. It already have a presentation header. What we are adding is session header. Okay. Then we have a transport layer where the data type is segment. So already have an application header, presentation header, session header, and now we are adding a transport header, which include the source IP and source port and destination port. Then it basically goes to the network layer. We have a data packet is fragmented into packets. Here already have an application header, presentation header, session header, transport header, and now we adding a network header, which include the source IP and destination IP. Then it moves to data link layer, where the data type is frame, where we adding an application header, presentation header, session header, transport header, network header, and data link header, which include the source MAC and destination. So here we have a source port and destination port. Here we have a source IP and destination IP, and here we have a source MAC and destination MAC, and here the data is converted into binary. So now what happens is, when data is basically goes to physical layer to physical layer, this physical layer, what it does, we have, as I said, we have a two layers here, LLC, and we have a MAC. So physical layer hand over the data to MAC. MAC will basically form the data back into frame and hand over to LLC. LLC, what it check is the destination MAC is same or not. If it's same, it will remove the header. So this is how they remove the header. Then the data is basically moved to network layer. Network layer will check the source IP, destination IP is same or not. If it's same, they will remove the network header. Then it basically go to transport layer. Transport layer will check the destination port is same. They will remove their respective header. Then it go to session layer where we finish the session, we terminate the session, there we remove the session header. And then we basically go to presentation layer, we decompress, we decode, we remove the respective header, and then we present the data to the application layer. So this is how the entire OSI works. Okay. So when I say application header, as I said, okay, the type of data is message. The presentation layer, the type of data is message. Session layer, type of data is message. Transport layer, the data type is segment, because each message was further divided into segment, and each segment basically mention the source port and destination port. Okay, and each segment has a sequence number by which the destination will use a sequence number to form the data. We also have a two type of header, TCP and UDP. TCP is they establish the three-way handshake, and UDP doesn't start with three-way handshake. Same like the communication between two friends without any fight is TCP. We start with hi, hello, how are you? But the communication between the husband wife is a UDP. It starts with nothing, finish with nothing. So it does not have any sense, right? So TCP have a three-way handshake and UDP is a connection layer. So in TCP, as I said, we have a system A, we have a system B. When A is sending us packet, he will send the SYN packet. He will send the SYN packet. If the port is open, SYN means synchronize. If port is open, he will send SYN and also ACK. Hey boss, I received. Is your port is open? Yes. I will also acknowledge. But if D want to finish the session, he will send the FIN. And if the port is closed, in that case, it will send the RST. But in UDP, we don't have anything. We just start sending a packets. Same like, when wife see her husband say, you don't understand me, without any sense. So that is called as a transport layer. Then we move to the network layer. Each segment, as I said, we have a packet here. So segment is further fragmented into packets. So packet 1 and we have a packet 2. So we are adding a source IP and destination IP. Okay, routing and routed protocols working here. The router is a device that work on layer L3 firewall that work on stateless firewall work on the network layer. Then we move to data link layer. Data link layer has a two sub layer. One is called LLC and MAC. So when packet is received, we add source MAC, we add destination MAC, and then we add a tailor because we need to give the physical address, and then we have a binary. So this is how the entire OSI works. If you find this video useful, do share to your network. And I'm also coming with the question series based on that. So if you understood this, if you do those questions, your OSI model is clear. So summary here is all people seem to need data processing. Hub, repeater work on physical layer, switch work on the data link layer, router work on network layer. Stateful firewall work on transport layer, circuit level proxy work on session layer, application layer firewall work on the application layer. Okay.
So when we're talking about cryptography, let me first explain you the basic fundamentals of cryptography. What is crypto and what is graphy? So crypto plus graphy. Let me split that. Crypto means secret. Okay. Secret mean encoded, unreadable. मुझे नहीं पता क्या होगा. So what I did, I spoken in Hindi. Now those who don't know Hindi, for them it's a secret. But those who know Hindi, they can able to understand what I said. So for the people who are not a Hindi listener, they will not able to understand. And my goal is to make sure that this information only available to the authorized user. Okay, so I spoken in a language which can only known by Hindi. So this is called as a secret text, encoded text, unreadable data. And graphy is called as a science of writing. Science of writing. That's why if you see the definition, it says science of writing data. Science of writing data into secret text is called cryptography. Now in cryptography, we have some basic terminologies. The first terminology is called as a encryption. It means it is a process itself which convert the data from plain text into the unreadable format, which is only and only available to the authorized user. As I said, this is me, which is Prab. And this is my friend whose name is Manish. My best friend, you can say like that. He's my lovable friend. So I always use this example. So what I did, this is my text we have. Okay, and now we have some set of 70 people here. They knows English only. So what I did, I convert this text, which is an English text, into Hindi. And I told Manish bhai, I'm sending you some data. Okay. And I mention in Hindi because if I pass through the 70 people, they will be able to understand. So I converted into Hindi. So when you receive, you read that. So you'll get to know what I want to convey. So what I did here is I convert the English into Hindi so that only Manish can able to understand. This process is an encryption. Okay. A technique by which I convert English into Hindi. So from the information security point of view, you can say like that. It is a process by which I convert the readable data into the unreadable format so that only authorized party can able to access. In this case, Manish can only able to understand because Manish know in that group Hindi. But decryption is a reverse process where we decrypt the encrypted text or unreadable text back to the plain text. The representation of the readable value that is called as a plain text. Here the English was the plain text. And encoded value, unreadable data, that is basically called as a ciphertext. Okay. So this is the high level process or terminologies that we used in the cryptography. Now before moving ahead, let me give you a very basics overview of entire element that we're going to cover. Now if you take an example here, if I say cryptography, crypto plus graphy, it is actually divided into two parts. We have a modern cryptography and we have a classical cryptography. If we're talking about the modern cryptography, we have a two type of modern cryptography. One is called as a symmetric and one is called as a asymmetric. But when you're talking about the classical cryptography is basically two types. One is called as a substitution and one is called as a transposition. Actually, classical cryptography is more like an encoding concept. And modern cryptography is more like a core encryption. Now let me explain you the thin line difference between encoding and encryption also. Now when I say encoding, this is my text we have. Example, this is my text money. This is my plain text. I use one encoding language. I convert M into B. I convert A into H. I convert N into D. And I convert I into A. Bada. So I replace character to character. That is called encoding. But in the encryption, what happens is we have a plain text called money. And that will be converted into binary. Then, so this is my plain text. Now we need a key. Key is the logic. Sorry, key is the factor. So key is like a passcode, capital P A $$ W0RD example, which will be converted into binary. Then between that we do the XOR, just giving example, and that value will be my ciphertext value. That is why encryption take more time than encoding. Encryption take more processing than encoding. So we are doing a changes in the binary level in the encryption, where in the encoding we introducing a changes in the character level. Coming back to the cryptography part, in cryptography we have a two important component. One is called as a key and one is called as an algorithm. One is called as a key and one is called as an algorithm. So key is called as a factor and algorithm is called as a logic. Let's take example 1 and logic I use plus. I'm using one base language here, which is like a alphabets. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this is the alphabet I use. So when I use in a classical cryptography, what I did, I use key as a 1 and plus is a logic. Then I combine that plus 1 because algorithm is called as a logic. English I'm using as an algorithm, but what is the phrases I'm using in the English to communicate, that is called as a key, because key is the factor. I will show you the example. Now in the substitution cryptography, what happened is, this is my plain text called, let me delete that. Okay. Now I have a plain text which is called security. Okay, this is my plain text. And now I want an encoded text. So what I did, I use a +1. Substitution means using an alternate value. So we have a S, that is S. S plus 1 is T, because S after S plus 1 is coming as a T. So I use the T as a value. E plus 1 is F. C plus 1 is D. U plus 1 is R plus 1 is S. I, we have a I. Then we have a J. Then we have a T. We have a T, U. And Y, Z. So this is basically my encoded text. If you notice, if the key length is small, it is easy to find the pattern. Now instead of +1, I use -1 example. So we have a S, we have a S. S before minus R. So this will be the R. So in substitution, we're finding an alternate word. But when you're talking about transposition means trans plus position. Transparently, we're changing the position. Transparently, we're changing the position. How? S plus 1 is E. So E will be the first. E plus 1 is C. C will be the second. C plus 1 is U. U. U plus 1 is R. R plus 1 is I. I plus 1 is T. T plus 1 is Y. Y plus 1 is S. So this is how I use the transposition cipher. Okay, in substitution, we're finding an alternate word, but in the transposition, we're just replacing the character. So this is the high level summary of classical cryptography. But what we're going to learn in modern is a symmetric and asymmetric in my next slide. Now, when you're talking about cryptography, as I said, encryption, decryption, plain text and ciphertext, in modern cryptography, we have two major components, a very, very important, which got enhanced. One is called as a key and one is called as a cipher. Another name of the cipher is algorithm. So key is a specific piece of information that is used in a conjunction with the algorithm to perform the encryption and decryption. If you saw in my previous example, plus and 1. So plus was the algorithm and 1 was the key, which is used together to perform the encryption and decryption. I told Manish, hey Manish, A plus 1 is B. So remember, so plus is the algorithm calculation with the alphabets and 1 is basically the factor. So one simple rule you need to remember with reference to the key, longer key produce the stronger encryption. Let's take an example. My key length is 1111. So it will produce the fixed output of 111 example. But if I have a larger key plus 2, 3, 5, 6, 7. So they will see the 2, 3, 5, 6 pattern and by which they basically form the key. That's why we say larger the key or bigger the key, more secure and more stronger will be the encryption output. Now I told Manish, okay, remember plus 73. So then they will calculate the plus 73 values and then it produce the output. But problem is that bigger key, higher key, bigger key size will produce the more secure output, but it take more time also. So whenever we selecting the key for the encryption, okay, we need to balance the performance and security. That's why we called as a key is the process which is used with algorithm to encrypt and decrypt the data. And cipher is called as an algorithm. Another name of cipher is algorithm, which is used to encrypt, decrypt the data. And there is a process called science of breaking the code or learning the cryptography algorithm or finding a weakness. And that process is called as a crypt analysis. A lot of company hire crypt analysis whose primary role is to discover the weakness in the cryptography algorithm, study the cryptography system so they can able to break it. Now there is a possibility like me running a cryptography solutions. So what I did, I hired the cryptography professionals and I told them, find the weakness in my system, find the weakness in my algorithm. So they tried to break my algorithm. How? The data which is encrypted by the algorithm, they try to break the data. They try to recover the plain text from the data. And then they will give me the report. Okay, by this factor, we are able to break it. So we will add that information and make the algorithm more secure. So study of algorithm, process of breaking, that is called as a crypt analysis. Moving to the next part, we're going to cover about type of cryptography, which is called symmetric and asymmetric. Let's move to the next part. Okay, so symmetric encryption and asymmetric encryption. If you go by the description, symmetric key used to encrypt and decrypt the data. Symmetric key use the same key which is used to encrypt and decrypt the data. That is called symmetric encryption. And asymmetric is basically used two-way encryption that is used with pair, public key and private key. It means one key is used to encrypt and one key used to decrypt. Okay, so how it works? Let me explain you. So let's start with the first part, which is called as a symmetric encryption. So if you read the description, it is clearly say that two-way encryption scheme in which encryption and decryption are both performed by the same key. How? Let's take an example. We have a system A and we have a system B. This is my data. So we got one key which is called as a, this is called as a symmetric key. Now we have a different name for that. We called symmetric key, we called session key, we called secret key. Okay, we called private key. Okay, so we have a different name. Or in your language, you can say this is a password. You can say like that. In a very layman term, it is called as a password. So what I did, A basically use his key plus algorithm to encrypt this data and produce the ciphertext. The same example I have shown you. It is same like, you have a WinRAR document and you protect the WinRAR document with the password, right? So here the password is called as a key. Okay. So key is suppose 12798. So this is the key we have, which is used with the algorithm to encrypt the data. And this is the ciphertext we produce, which is called as unreadable data. Now A sent this data to B. Okay. It is a encrypted data, which is sent to B. Now B received the encrypted data. Same like if I protect the file with my password, you will ask for the password only. Now concern here is I have to send my key, the same key. So I sent 12798. So B applied 12798 by which and plus algorithm and decrypt the data. Okay, so that is why we use 12798 to encrypt the data and to decrypt the data. That is why today's symmetric encryption is used for the data encryption. Today, if you take an example of AES, you heard about AES on your browser, wireless AES. They all are symmetric encryption only, where we're using a same key to encrypt and decrypt the data. Now there is a one concern here. The concern is if you sending the data and key in a same channel, this is called as a same channel. Now what happened? There is an attacker. He can intercept the encrypted data also, and he can intercept the key also. So by this way, he get the data also and key also. So that is why the biggest concern with symmetric encryption is the key exchange. Key exchange. And that is why they use multiple technique. One is called OOB, out of band. It means sending a key by email, sending a key in a hard disk, sending a key in a pen drive, or calling the person and dictate the key. Or the second process, they will use asymmetric process that I'm going to discuss in the next slide. So the primary concern with symmetric encryption is the key exchange. But today, primarily symmetric encryption is used for encrypting a data because it is faster in processing the data, because same key used to encrypt and decrypt the data. So when you're talking about symmetric encryption, we have a two type of symmetric encryption. One is called stream based and one is called block based. Now, when I say stream based, example YouTube. Okay, so in stream based, what happened? Whatever the data we have, it is convert into binary. And whatever the key we have, okay, it is also convert in the binary. So in the stream based encryption, it encrypt the digital data stream 1 bit or 1 byte at the time. It means they do like this way. So bit by bit stream is basically happen. Example, in my video, if I upload this video on YouTube and you're playing my video, okay, smoothly without any interruption, thanks to they using a stream based encryption. Okay, they encrypting bit by bit parallelly. Okay, bit by bit parallelly. Okay, bit by bit parallelly on the same time. So that is called as a stream based encryption. But when we're talking on block based, in block based, what happened? We have a data here. Data divided into block 1, block 2, and block 3. And then each block is basically encrypted by the same key. And then we send this block. Now, if YouTube is using a block based encryption for the video streaming, so my voice will be like that. Hey guys, is that clear or not? So if you see, there's some interruptions because data was not something parallelly getting encrypted and decrypted. It is not something parallelly going bit by bit encryption. Data divided into block, and each block is basically encrypted by the keys. That is why block-based encryption used in that case when data resides somewhere in a storage. Okay. So stream-based use in application, block-based use in a hardware. So these are the two type of encryptions we have. So key exchange is a concern because same channel we are using. So we use the out of band exchange. Scalability is another challenge we have because for every user, we need to have a unique keys. Example like this way, we have a system A and we have a system B, we have a system C, and we have a system D, B, C, D. For every encryption, we need a unique key. So imagine more and more hosts. Now B want to send data, he need to send his key. B need to send to C, he need to send to his key. So for every user, B need to issue the new keys. For every user, A need to issue the new keys to every user. So as more and more hosts increase, scalability become a concern. And we have some algorithms which support the symmetric DES, 3DES, RC4. These are the symmetric algorithms we have. Currently we're using AES, which is a replacement of the DES algorithm. The biggest reason of not using DES is it requires a lot of compute and all that. And AES, which is advanced encryption standard, they basically provide the better security and better functionality with better compute parameters. So that is the advantage we get when you go with the symmetric algorithm, AES algorithm, sorry. So I'm sure you get the understanding of symmetric. So how it works, symmetric algorithm in a real time, let me show you. Let me show you the practical demonstration of symmetric algorithm. Okay, so this is the practical demonstration. So I use this website called xcode.com. Okay, that is the name of the website we have, which I used in this reason. Now what I did, I'm going to type the message here. Hi, Prab. Okay, hi Prab. I use AES algorithm. This is the key we have that I'm using. This is the key which I'm using to encrypt the data. Let me try to perform the encryption. So this is the ciphertext we have. Okay, this is called as a ciphertext. So this is called as a ciphertext. Now what I did, I copy this and paste here. Sorry, I copy this and I paste here. Okay, now I'll try to decrypt. So you can see hi Prab. So we have used the same key. We have used the same key to encrypt and decrypt the data. So I'm sure you get a visibility about symmetric encryption. So now the next part is called as a asymmetric encryption. In asymmetric, we use the pair of keys. Each pair consists of public key, which is known to others, and private key, which is only known to the owners. So that is what is called as a asymmetric encryption. So how it works, let me explain you. Now we have a system A and we have a system B. Okay, so we have a public key here. Let me draw it. So we have a public key A and we have a private key A. B also have a public key and private key. Let me draw it. So this time we have a two keys, public key and private key. So now we have a data. So this is my data. Now A want to encrypt this data and send it to the B. So when I say public key is something which is known to other. That's what we share. And private key is basically may not be known by anyone except A. Okay. So A first request B public key. Then B sent his public key. A basically apply public key of B and encrypt the data. So this is the encrypted data we have. And then A send this encrypted data to B. When B receive encrypted data, he apply his private key, and by which we decrypt the data. Now, if there is an attacker, suppose if there is an attacker and he intercept from here, he intercept here also, and it intercept here. So he got the access to the encrypted data. He got the access to the public key of B. Still, he cannot do anything with that because he need another portion of a key which is called as a private key, which we don't share. So one key is basically used to encrypt and one key is used to decrypt. So this is how it works. That's why we use asymmetric encryption to exchange the symmetric key. Let me give you that example also. Now, we have a system A and we have a system B. As I said, we have a public key A and we have a private key A. We have a public key B and we have a private key B. We always generate a key pair, okay? Now we have a data. This is my data. What I did here, we also have one more key which is called as a session key. Another name of session key is symmetric key. So now A have a 3 keys. Always remember in cryptography fundamental, sender generate the session key. Sender generate the session key. So here A is the sender and B is the receiver. A is the source and B is the destination. So A basically use the session key and encrypt the data. So this is the encrypted data A will send to the B. A sent encrypted data to B. Now B received the encrypted data. Problem is that now B need to decrypt. So in this case, B will send his public key. You know why? I will tell you why. So B sent his public key. The reason why, by this key only we decrypt the data, but A cannot send the session key over the network. So B will send his public key. A will basically apply B public key. A will apply B public key to encrypt the session key, because by end the session key is a value only. And then we encrypt and send back the encrypted session key to B. Now B received the encrypted session key. B will apply his private key to find the session key, and then session key used to decrypt the data. That is how asymmetric is used with the symmetric. So summary is that symmetric used for data encryption and asymmetric is used for the key exchange. I'm sure this point is clear to everyone. One primary advantage with symmetric is it is faster because we're using the same key to encrypt and decrypt. But one primary disadvantage with the asymmetric is that slow, because one portion of the key used to encrypt and one portion of the key used to decrypt. Let me show you the practical demonstration of asymmetric encryption. Thanks to Khan Academy, they did the amazing job. So I'm using their website reference for this practical. Another name of the asymmetric cryptography is also called as a public key cryptography, because we're using a public key to encrypt, right? So this is the website called Khan Academy. Here we are generating a key pair. Okay, key pair. So we generate the public and private key. So what I did, I copy the public key and now I type hi prep. I click on the public key I encrypt. So this is the ciphertext we have. Now what I did, I paste the ciphertext here. Now we have a private key here. I copy that. And we have a private key. See, I got the same message. So you can see the size and all that, okay? So when you're talking about asymmetric, one portion of a key used to encrypt and one portion of a key used to decrypt. The biggest concern is performance and primary use for the key exchange. We have a different kind of algorithm like RSA, ECC. ECC was the alternate of RSA because it takes less compute to perform encryption. We have a Diffie-Hellman also. So asymmetric algorithms are used to encrypt the keys and symmetric algorithms are used to encrypt the bulk data. So this is what we have. When you're talking about the overall cryptography offer the confidentiality. Okay. It offer the integrity where the data has not been altered in an unauthorized manner since it was created, transmit and store. How? We're going to discuss in my next video. It also offers the authentication by which we verify the identity of the user or system that created the information. Authorization, those who have a key, they can able to decrypt. And by this performance, it able to achieve the non-repudiation where the sender cannot deny for his actions. So cryptography offers 5 major services. With the help of cryptography, we can able to provide the 5 major outcome of information security. So this non-repudiation, authentication, integrity, we're going to cover in my hashing topic, which I'm making soon. So this is all from my side. And if you find this video useful, do share in your network. And do let me know what is the best thing you like about this video. Another important thing, I want you to do one homework and let me know what is the thin line difference between the AES and DES and ECC versus RSA. I need your reply in my comment box. Thank you for watching my video. So first we're going to learn about hash function. So if you go by the definition, it is saying that cryptography hash function is an algorithm that take arbitrary amount of data input and produce a fixed size output of a text called as a hash value. And hash is a value created by the hashing algorithm. So again, it is written in a slide. So let me explain you with the reference. See, hashing is basically used to provide data integrity. Let me give one practical demonstration of that. When I say integrity and how the hash play an important role. Suppose this is a food which I order from Zomato. Zomato is a food aggregator services in India. Now, if you notice this food package, whatever I order, it has a seal. This is called as a seal. Can you see that? This is called as a seal. This seal, so example like this is the restaurant. Okay, who cooked food and placed that food in a box, and he then sealed that box with some tape and all that, and he just told a customer, which is me, that we have sent a food to your house. So now what happened? The food is carried by the food delivery guy and it is delivered to me. When I receive the food, I can see a seal on the food, like this kind of a seal. It gives me assurance that during a transit from this point to my point, no one has altered the food. And I receive the same state of the food which is packed by the restaurant, and that shows the integrity of their services. And how I verify? With the help of the seal. Same like in data security, we need to provide data integrity. So if you take an example of the bank, now bank sent me a statement. This is the statement, bank statement. And what they did before sending a statement, they generate the hash value of the data. So what is this hash value is? Hash value is the fixed value they generate for this data. It doesn't mean that, okay, they convert something. No, this is the bank statement we have, which is produced by the bank, and they generate, not convert, they generate one fixed hash value, a digest value of this particular bank statement. And they attach same hash value on the email and send it to me. They told me, hey Prab, when you download the statement, check the hash value of the statement and compare the hash value with the hash value what you obtain in an email. If both hash values same, it means the data came without any unauthorized modification. Because if you're getting a same state of value, you're getting a same hash value, it means data was protected from unauthorized modification. You haven't received any kind of a different data. Same like we have a Amazon. When you order something from Amazon, any liquid component, or when you buy something liquid component, Pepsi and all that, they clearly mention if you receive the product with a broken seal, do not accept. There is a probability during a transit they have opened that and mixed something, which is creating an integrity issue. So hashing is a function used to provide the integrity to the data. How? Suppose this is the name which is called HiPrub. So I use a hashing algorithm like SHA MD5, and with the help of that, it produces one fixed hash value. You don't trust me? Let me show you the practical demonstration of the hash. So this is the website called tool4noobs.com, and I type hi prub. I selected MD2 and hash this. So this is the hash value has been created. Okay. So it doesn't convert, it generates the fixed value of this data. Okay. Now what I did, I just remove H. And now you can see a different hash value. Now if you notice, by changing one bit, it changed the entire hash value. So when I received the data, they told me on the bank statement, on the email, this is the hash value of the bank statement. But when I scan it, I found this, I use the same website, or I use a hash calc by which I scan my data. And I found this hash value. So it means the data what I receive is not an authorized one. So this is how we can able to detect the unauthorized modification of the data. And that is basically called as a hash function. So hashing used to verify the integrity of a data such as email, download files stored on the disk. And we have some common example like MD5 and SHA. SHA is basically more secure because it providing me a larger length of hash value. Because if we have a smaller length of hash value, then it is a chances that, okay, two different data can generate a same hash value. Okay, high prub or high money can generate the same hash value because it is not converting, we're just generating. So that is basically, and that is a irreversible. Normally in the encryption, what happen if I convert high prub into something with the help of key, I can reverse back. But in the hashing, we cannot reverse back because we are not converting something. We're generating a fixed value from the data. So that is what is called as a hashing. So next topic, what we have is called as a digital signature. Okay, so digital signature are similar to the handwritten signature on a printed papers that identify user, but it is an electronic verification of the sender. Okay, so digital signature is a hash value that has been encrypted with the sender private key. If you need to understand this better, you must refer my previous video where I cover the cryptographic fundamentals, because digital signature we can achieve with the help of asymmetric cryptography. Now let me explain you with the practical demonstration. If you saw my previous video where I discussed about asymmetric cryptography, so we have a system A and we have a system B. Both have their own public and private key. Public key and private key. B also have a public key and private key. If B want to you want a session key, he will send his session key. So you can check my previous video. So in digital signature, what happens? Suppose we also have a C, we have a D, and we have a E. Okay, so we have a multiple systems here. Now what happened? Accidentally what happened? E, A, C and D all have a common public key of B. Example. Because public key is accessible to everyone. So D use the public key, encrypt the data and send it to the B. C use the public key of B, encrypt the data and send it to the B. A will basically use the public key of B, encrypt the data and send it to the B. And E will use the public key of B, encrypt the data and send it to the B. And B will use his private key to decrypt the data. But my question here is, I want to verify the authenticity. I want to know who sent which data. Okay, and who sent this data. I want to verify the source. Because my key is accessible to everyone. So anyone can use the key and encrypt and send it to me. But I would like to know who sent this data, who sent this email to me. Okay, who sent me this data. I want to verify that. And that is why we use a digital signatures. That is why, you know, when you're signing up papers, documents and all that, they say, please sign here, please sign here. Tomorrow you should not deny that. And by the paper, we can able to identify the authenticity of the document. Same thing happen here. So when sender sending a data, he add a signature into that so that destination can believe it is came from a respective source. And that is why we use a digital signatures. Example like if A want to send a data, okay, and he want to give assurance it is came from me. So this is the data which is basically generate. Okay, right now the time is in India is 9:55 PM IST. At this particular state, we generate this data. Okay, so A is saying that boss, this is my data. And for this assurance, I will generate the hash value of this data, which is a fixed value of the data. This hash produced by me only, I will encrypt this hash with my private key. And as you know, no one share their private key. So when you use the private key of A to encrypt the hash, it produces one DS value. I repeat again, private key of A used to encrypt the hash. It produces the digital signature value, and that is basically add to the data. And A send data to the B. When B receive the data, it has a DS value. So B use the public key of A to decrypt the hash. So by decrypting the hash with the public key of A, it gives the assurance to the B it came from the A. And then he scan the data and find the hash and compare this hash with this hash. By this, it achieved the integrity. So by this way, we achieve the authenticity also and integrity also. So this is basically called as a digital signature, where you're encrypting the hash with the sender private key. Digital signature, apart from providing the solution, it also offers other things. Okay. If the recipient means receiver of a digitally signed email can be decrypt the hash, it provides the 3 security benefits. First is called as an authentication. I have already demonstrated you practically that when I receive an email, I decrypt the hash value of the email with the sender public key. So by this way, I can able to verify from where it came, right? So I can able to validate that. And no one share their private key, so it give me the assurance. Second is, now if it came from the sender, I able to verify. So in that case, sender will not able to deny. Now example, you are the sender and you send me the data, which digitally signed with your private key. So you cannot deny on a later stage that it was not me who sent the data. Come on, this data is now decrypted. This hash value now decrypted with your private key. Okay. One more example I can give you about the non-repudiation is basically like, imagine we have Amazon. So Amazon sent an order to sell stocks using a digitally signed email. If the stock increase after his sale complete, he cannot deny the transaction because it is add with the digital signatures. And that digital signature is basically generated from their private key. So that is why, see, the proof I have the DS value, which is decrypt with the public key, that is an authentication, which is / called as authenticity. And because of that, the sender cannot deny for his action. That is called as a non-repudiation. And along with that, I'm able to achieve the integrity already, because when I generate the hash, I check the hash to verify the integrity of the data. So digital signature provide the authenticity, because there's a unique piece into that by which we can able to identify who sent this data. And when I'm able to verify who sent this data, the sender will not able to deny for the later stage, because I'm able to decrypt with his public key. That is called as a non-repudiation. And third, by the hash value, I'm already validating that point. That is called as a integrity. So if you find this video useful, do share your network, and please let me know what are the common algorithms we can use for the hashing. Okay. And do let me know what is the common algorithm we can use to map with the digital signature. Thank you for watching my video. Bye. Take care. Okay, so next topic is called as a virtualization. See, as you're working in a SOC L1, so you will run a lot of tools, and this is my system A. Okay. And I want to run some tool. When I'm running some tools, it can have some malware which can compromise my operating system. It can infect my operating system. And sometimes what happen, some application demand dedicated kernel. What is the meaning is, we have a, let's say example, this is my laptop. Okay, 8 GB RAM and 240 GB hard disk. Hypothetical scenario. So what I did, I installed the operating system and I'm running one application on it. But problem is that the application support the dedicated kernel. Now I want to install another application which is on a Linux platform. I need to purchase a new hardware, install the Linux, and then I can run the Linux application on the Linux system. And the current system is only utilized 1%. It's a complete waste of hardware. But now what happened, I will install the, we have a hardware. I will install the OS, and then I will install one application called VMware Workstation. And then on top of it, I will create a virtual kernel system, virtual operating systems, like the same like operating system, but now we have a multiple operating system running on one hardware. And through that, I can able to run multiple things. That is a live example of virtualization. So virtualization, what it does, it virtualize your hardware. See, today, if you want to run Mac directly on your Lenovo laptop, that is not possible. Same like on the Mac, you want to run Windows, that is not possible. So you will install VMware Workstation, which creating one virtual hardware environment, and then you can able to run anything. So virtualization is two type 1 and type 2. Now what is type 1? Type 1 is basically mean we have a hardware. Directly we install ESXi. There is a one operating system we call it as a ESXi. And then we run the virtual machines. That is called type 1. From a security point of view, it is the most effective. In data center side, we use this only. Let me show you an example. So if you can see this one, this is the operating system we have. Okay, this is how it look like once you install ESXi. Most of data center sites, they use that. On the other side, we have a, so this is called type 1. Directly we install on the hardware and then we run the machine. Like same like, we're running Windows and then we're running the application. So here the Windows is not, we don't install in Windows, we directly installing the virtualization operating system. So that is called type 1. That's why it's called one layer. But type 2, which is called as a hosted one, this is called type 2. So in that what happened, we have a laptop. Okay. Then we install the operating system, Windows or Linux, and then I will install the VMware Workstation. And then I will create a machine. Why it's called type 2? Because layer 1 and layer 2 is there, then we install, and parallelly we run other application also. But it is not secure, because if someone compromise this application from their compromise the OS, they can able to compromise everything. So if I want to show you how the type 2 look like, this is how type 2. I'm sure you also know this VMware Workstation that you install. So when you're working in the SOC and all that, you will get access to the virtual environment. We have to see what kind of a virtual environment you have. By the end of the day, you will get access to virtual machine. So here, if you can see scenario, type 1 is run directly on the physical hardware, enterprise data center, VMware ESXi, Hyper-V, Zen server, high performance due to direct hardware access, direct hardware interactions, required advanced skills, production environment, IT profession. On the type 2, run on the top of the operating system, personal use, VMware Workstation, Oracle VirtualBox, lower performance due to reliance on host OS, access to the hardware, okay, easier to install, and then local development, testing, running, multiple OS on desktop, developer, testers, personal use. So these are the set of peoples we are using. So that is called as a virtualization. So as a SOC analyst, you should know virtualization, how it works. And mostly if you're working on the standalone laptop, you will get access to the type 2. Otherwise, you will get a directly virtual machine, which is hosted on type 1, and directly you get a virtual machine access. So example, like on the server side, there is a hardware, and then they have installed the ESXi, and then they're creating a machines. So you have direct access to this machine. That's a one case. Or you will have a laptop in which you install the VMware workstation, and then you're creating a machine. So you have to see what kind of environment you get. In another term, it is also called as a sandbox. So now we're going to start the cybersecurity journey. Okay, so next topic. Now we're going to start with the cybersecurity fundamentals, and because as a SOC analyst, you should know cybersecurity. So far, whatever we have covered was more about networking and networking protocols. And now we're going to discuss about cybersecurity. So as I said, cybersecurity is a part of information security, and the three important pillars we have in cybersecurity or information security is CIA triad: confidentiality, integrity, and availability. So confidentiality, if you take example, it is an information that should be only accessible to the authorized individual. That is basically called as a confidentiality. Understand in this way that let's say example, you want to share some information with the respective user. Okay, let me explain you with the example. So here we have a user A, and here we have a user B. Okay, so we have a user A and we have a user B. Now A want to share the information only with B, and he doesn't want the C to read that. So what A will do is A will protect that with the password. So this is the data which is protect with the password 1, 2, 3, 4, and it sends the data to the B. Is it clear? So by this we ensure the B can only read the data because 1, 2, 3, 4. So there is a security team is there who ensure the data only read by A or only read by B, no other one. But if the data read by C, it's a breach of confidentiality, and that basically exploit the trust. So confidentiality ensure the information only accessible to the authorized individual. Now let's say example, I join a security analyst in the bank. Okay, bank is running a website. There is a hacker who hack into the website and he enumerate all the data. What do you think? Will you trust that bank again? Your information, your statements are now available on a Reddit. Will you be happy? Will you be comfortable? No. And it exploit the trust. So we have hired a security analyst to ensure that, okay, no kind of attacks will be happen on the websites. If happening, we can able to detect and respond immediately. We should have a limited impact. So confidentiality is achieved with the help of encryption, access controls. Even you can have a confidentiality achieved with the help of physical controls also. The second control, we talk about the integrity. Integrity, information should be accurate and consistent. So we have a system A and we have a system B. There's a dedicated video I made on a cybersecurity in the description box. I will share. Please check that. Okay. So we have a data here. This is my data. Right now the time is 11:10. So at current state data, this is the hash value. Okay. Now I send this data to B. When B download the data, he check the hash and hash is the same. So hash is nothing. It is just like a seal. You know, when you order something from Zomato or when you order something from food aggregator app. So this is the restaurant. So they pack the food with a seal. And when it deliver to the destination, you have to make sure the same state of food should be delivered. So by the checking the seal, we ensure the integrity. Same like when you order something from e-commerce and all that, make sure you get a same state of food. So by checking a seal, you ensure the integrity. The third is called as a availability. Availability means the information must be available whenever it required. So today I want to access OTT. I open the app, I can watch my movies. It is available. I want to access the net banking site. It is available. So as a SOC analyst, we have to ensure the service must be available. So in a layman term, understand, okay, I have shared some secrets with my friend. Okay, and he give me a promise he will not share with anyone. That's how he maintained the confidentiality. I asked for the advice and he gave me the right information. So I will trust him. He said, Prav, whenever you need my help, I'm available. So he's available. But on the opposite side, I shared some information with him and he told everyone. So that's a disclosure. Will I trust that guy again? No. I asked him for some advice. He gave me wrong information. Will I trust him again? No. He told me, Prab, whenever you need, I'm available. When I try to call him, he's become unavailable. Availability. So when you work for the e-commerce, availability is a priority. When you work for the banking sector, integrity is a priority. When you work for the defense, or you work for the healthcare and all that, confidentiality is a priority. So that's how it works. Okay. So let's move to the next part, which is the important terms used in a SOC. Okay, so we have some important terms that you need to know as a SOC analyst. The first is called as an event. Event is a sequence of activities, what we can see in the system, or you can say sequence of activities which is trigger some activity, that is called as an event. So let's say example, I want to start a session by 9. I precisely log in by 8:45 and I log into system before 9. It's an event which is agreed with my customer. But if I log in late by 9:05 or 9:10, it against the SLA. So it become an incident. So incident is any activity which impact the organization in negative manner. Okay, but event will be recorded in the logs. Log is a detailed record of event generated by the system, application or device, and that is used for the monitoring, troubleshooting, forensic analysis. Okay, 9:30, I logged in, I told. Do you have any evidence? Yes, in the log you can see my timestamp. So event is recorded in the logs. So as a SOC analyst, when you're investigating any events, okay, we validate with the help of logs only, and logs cannot lie, right? So that's why logs are very important, and make sure it should not be altered. Another important thing we need to understand here is timestamp in the logs is very important, because timestamp is used to correlate the event. Okay. Next is called as an incident. As I said, incident is a confirmed security event that compromise the CIA of the information system. So you go to any marriage event and later on you got to know your marriage got fixed in the same event, then it become an incident, right? So incident is anything which compromise the CIA. Now next is called as a threat. Now threat is any potential danger or malicious activity that could be exploit a vulnerability and harm the organization assets. So let me explain you the example. So let's say example, there is an attacker. Okay, and this is my server. So attacker doing an attack on the server. So this action is called as a threat. The attacker is called as a threat agent, and he doing something which is called as an action. Okay. So there is a relative who bring marriage proposal for you. Okay, that is a threat. Can you predict when he comes? No. Is it clear? So threat is any action, okay, which could be exploit the vulnerability. Now, what is vulnerability? Vulnerability is called as a weakness. It means server is configured with the weak password. So that is called as a vulnerability. Server is open with some port. So open port, weak password is a vulnerability. See, what we can control is vulnerability only. See, I have a weakness. I'm an introvert guy. I simply say yes to everything. So that's my weakness. So there is a relative who bring the marriage proposal. I cannot say no to that. So marriage proposal is a threat. Because I could not say no to that, okay, I said yes to the proposal, and that lead to the risk of getting married. So here what happened, threat is the same thing. Threat is any potential danger or malicious activity that could exploit a vulnerability. I want to go a bit off the topic here, and I want to discuss about threat has a 3 principle. Okay, M, O, M. M stand for mean, O stand for opportunity, and M stand for motive. Mean method what he use, opportunity mean weakness, and what is the motive behind that. See, we can control now opportunity because for him opportunity is my vulnerability. Method nowadays controlled by the threat intel, but we cannot control someone's motive. Is it clear? So that's why we can control only vulnerability, not a threat. You are weak in a particular subject. You cannot predict what question can be asked in the exam, right? So it's very important for you to know what is threat. Next is called vulnerability, a weakness or flaw in the system. One thing always remember, threat is always dynamic in nature. Vulnerability is always static in nature. What is the meaning? So if we have a system A, it is configured with some open port. It's a one vulnerability, but it can be exploited by remotely also and locally also. Is it clear? If you have a vulnerability that you cannot say no to anything. You can be vulnerable for the manager also and your relative also. So that is why for one vulnerability we can have a multiple threats. Then we discuss about the next topic, which is called as a risk. So risk is a potential for damage, potential for loss or damage when threat exploit the vulnerability. Let me give you an example. Now here the vulnerability we have is an employee not trained to recognize the phishing email. So what is a threat? Phishing email attempting to steal the employee login credentials. Now what is the risk? Loss of customer trust and financial damage. One more example, you're preparing for some certification. You're weak in domain 1, chapter 1. And the question has been asked from the area. And if you're unable to answer, you will lose your money. That's a risk. So risk is a probability. Risk is not a confirm action. Because it's a confirm action, then it is not a risk. It's a confirm incident. To prevent the incident, we do risk assessment. Okay. So risk is a potential for a loss or damage when threat exploit the vulnerability. And they focus on two important things: impact and likelihood. Impact and likelihood. Is it clear? So what is the meaning of impact? So there is a hacker. Okay. He tried to attack server. What is the chance of this happening? Likelihood is high because the server is connected on the internet. And if he hack, he can able to access to the PI data. So overall risk is likelihood and impact. Likelihood is 4, impact is basically 4, risk is basically 20. So this is also risk is arise when threat exploit the vulnerability. And threat exploit the vulnerability enable the threat to act. That's how it works. So is it clear? So by end of the day, we say there is a risk. One more example we can take, when we talking about risk is like, I already told you that you're giving an exam, you failed in the exam, that's a loss. So do the assessment before doing the things. That's a very important part. So it's very important. You should know these 3 elements. Another important thing is called as identification, authentication, and authorization. Now let's take example of identification. So when we're talking about identification is a user provides some claim of identity like username or some form of identity proof. Like example, I go to airport and say, hey, my name is Prab and I'm traveling from Mumbai to Delhi. So first thing, they will check my name in the list. If they found my name in the list, yes, that's called confirm the identity. Then they ask, no, like, can you show me the Aadhaar card, passport or PAN card? Just to prove I'm the same person who claimed to be. That is called authentication. Authentication system is basically has a knowledge of the user account and identity proof validate the provided information. And then they give me a seat number 3637. That is called as an authorization. Same time when you open Gmail, the first time when you open Gmail, it will only ask for email address. If email address valid, it means identification. Then they ask for the password. That is called authentication. Then they give you access to mailbox. That is called as an authorization. So to establish a strong authorization, we need to have a strong identification and authentication. So IEEE is always a works in the systems. So when you're working as a SOC analyst, you need to see how many users have attempted to log in, how many times they have a bad authentications, do they have a access of their particular thing or do they have a more access? So all those things need to be validated. So it's very important you should know IEEE from a SOC perspective. Now when we're talking about identification is different type, like username is identification, bank account number is identification, passport number is identification and all that, right? Now authentication is 3 type. So first is called as something you know. Something you know is a password. Okay, but the most secure is passphrase, which can prevent the dictionary attack. Why? Example, my name is Prab. Okay, I left Petty, example. So it's a complete sentence. So I convert the entire sentence into password. I was going to write the entire sentence. So that is called passphrase. But I said KIT. So that is basically my password. So if you want to defeat the password attacks, you always use passphrase. But it is always the weakest. Then we have a something you have, that is called token, device, smart card. You know, where you receive a OTP and all that, that is called something you have. And next is called as something you are, which is called biometric. One thing always remember, when you're working in the SOC data centers and all that, they always configure with something you are, because we need to make sure the presence of ID must be there and the presence of person should be there. When you are in mobile locations and all that, remote location, we use something you have with something you know. So these are things we have that for the functions. Now we're going to discuss about some of the solutions which you might be going to encounter in your SOC analyst jobs. When we're talking about controls are basically introduced to manage the behavior of the people, process and technology in the organization. That's why we have a 3 type of controls in the organization. The first is called as a technical control. Something you implemented technical in nature. Example, firewall, antivirus. So you just installed, their technical function is involved there by which they try to detect, by which they try to block, and they do their activity. So something was technical in nature which tried to manage the behavior. That is called as a technical control. One more example I can give you. Suppose this is the firewall we configure and we created a rules in the firewall. So my work is over. Now any packet is going to the firewall, their technical function is going to inspect the packet, compare against the rule, and based on that it will allow or deny. So my involvement is not there. The technical function was involved to inspect the packet and take the further decision. So that is called as a technical control. So if you go by the layman term, hardware, software mechanism use the manager access to resource and system and provide protection for those systems like encryptions. All are basically example of the technical control. Second is called as a physical control. The control that you implement physical in nature, which block, detect, alert physical in nature. Example is physical lock that you install on the doors. So you need a physical key to insert and operate, and by which you open the door. Otherwise you cannot able to access the facility. That is a perfect example. Then physical detective camera. Camera is there which is physically installed and detect your activity. Something was physically configured there, something was physically placed there which monitor your behaviors, which block your behavior. So that is called as a physical control. Third is basically called as a administrative control. Administrative control is set of instructions which is set by the management to control the behavior of the people. Example, management has introduced one notice, one rule that we have to resume the office from the March. And for that, you need to carry your vaccination certificate. So it's an instruction. Clearance process, hiring process, background check, it's instructions. It's instructions which is used to control the behavior, not something technically implemented, not something physically implemented, but it is set of rules or soft cultures or soft control which used to control the behavior in the organization. So these are the 3 type of controls we have. We're going to discuss each and every type in more detail in the next slides. Okay, so first part is called as the administrative control. Okay, so we have some examples here like operational procedure, like we have a document with us, and according to the SOP document, we follow all the instructions and everything, which is set by my manager. I join the organization, I need to access something. So I have checked the policy. In policy, it is mentioned until unless you don't have a clearance, you can't access the thing. So something was set by the management by which we controlling the behavior. That is a different story. Through the technology we can implement, but that become a technical in control. But here some instructions, some policies already created by the management to control the behavior. Then we hired a human which monitoring and supervising the people and checking whether they're working as per the policy or not. That's administrative control. We have a user management process. Okay, I'm sure user management and privilege management, you might be thinking it is a technical control. No. Suppose someone join as an organization as a new employee and all that, through the user management process, it's a process, it is a policy we have created, and according to that user management process, we issue the new username password, we manage the username password. Through the tool like SailPoint and all that, we are issuing that, then it is become a technical control. Okay, any kind of a privilege credentials we need to manage, it need to be managed through a privilege management control. So these are the examples we have for the administrative control, like introducing a separation of a duty policy that one person will not perform end-to-end task. So it's an instruction. So we have to make sure we have 3 people in the process where the one person will approve, one person will sign, and one person will make the payment. So it's an instruction, it's an order, it's a requirement which is used to control the behavior. Okay, so that is called as an administrative control. Now next thing is called as a physical control, something we implemented physical in nature. Example, network segregation. So we have one physical switch and we have another physical switch. So by which we can able to segregate the host physically. So that is the one example we have, network segregation. Okay, then we have a perimeter security. It is a mechanism that provides the physical access control by providing protection for individuals, facility, and the component within the facility. It means one human or one user cannot able to access the other part of the perimeter physically because his card doesn't work. Example, this is the facility we have. This is the one parameter, this is another parameter. One person came from outside, he can able to access this area physically. But if he try to access this area, he need to punch card. When he punched the card, his access was rejected. So physically, we prevent him to access this area. Physically, we prevent them to access this area because there is a guard, there is a door, there is a proper lock control is there. So something was physically installed there which prevent them to access that particular area. Then we have a computer control. Computer control, like we have a locks on the laptops, we have a locks on the system, so no one can take it physically from there. Okay, then work area separation, like we creating a cabins by which we ensure one person should not be able to access the other area. Data backups ensure access to information in the case of emergency or disruption of a network or a system. So that is a data backups. I'm talking about data backup here is physical access of the data backups on the offsite and all that. Then we have a cabling. All cables need to be routed through the facility and all that. So we're providing a proper physical security to the cablings. So they should not be able to access that cable directly. They should not burn it. They should not cut it. Okay, which can be lead to the eavesdropping. So something you have implemented physical in nature. So that is called as a physical control. Okay. Next thing is basically called as a technical control, which is technical in nature, like user access. Now, as a user, I want to access. So I have a system A and I want to access system B. So when I request for an access, like request for the IP, B automatically asks for the user and password. It is not something a user is there who follow the company order and ask. No, there's a technical function is involved which automatically asks the system A. I'm sure whenever you're accessing any kind of a folder, resources and all that, it always asks for the user and password of the target system. So it is an authentication procedure. So single factor is there, multi-factor is there, two-factor is there. Same thing happen in the case of network access also. In network access, you're trying to connect the systems on the network. Okay, with the help of router, with the help of switch, we're creating a logical segmentations. So there is a technical control in the switch we have by which we're creating a logical segmentation. Okay, we can do physical segmentation by physically isolate the switch. But within the switch, we can have a logical segmentation. We call it as a VLAN. So that is because of a technical control we have in the switch. Remote access like VPN. So user is connecting via VPN server asks for the username password. So there is a technical function is involved. Then we have a application access where the application may have a layer of control like user activity, object security, internal services. Then any malware in the system, there is a malware control is there which detect the malware. So it is a technical function by which they try to block. And finally, we have an encryption, which is used to protect the data in a technical manner. So key is need to be feed by which encrypt and decrypt the data. So these are the control which are technical in nature. Okay, we just configure it and they just work technically. So these are the three type of controls we have, but the question is how they work. That is why we have a 7 category and that I'm going to discuss in my next slide. Okay, so we have discussed about type of controls, which is a 3 type of controls. And now we're going to discuss about 7 category. Perhaps 7 category? Yes. But here I can see on the screen 6 categories. Yes, so 1 category is missing here, which is a deterrent control. We don't implement, but we just create that environment. That is why it is missing here. So moral of the story here is we have a 3 type of control and each type performs 7 type of functions. If I say we have a lock, why we need a lock? So we can able to block unauthorized user to access a facility. So it's a physical preventative control. So this is how it works. So whenever we organizing a control, we organize them in a form of type with category. So categories are the function. So the first control here is called as a directive control. Directive control is like giving instructions. Okay, a mandatory control that have been put in place due to the regulations or environmental requirement. One example of the directive control is speed limit sign, which is a common example of a directive control. Okay, when you join the facility, when you join the organization, they have given the direction. For the masked people go this side and non-masked people go this side. So it's a directive, it's a direction. Okay, so some controls are there which basically give the direction. And that is called as a directive control. One more example is no one's supposed to browse social media 9 to 5. It's a directive control, a kind of a technical directive, because there's a technical information is there which instructing the people. No one's supposed to browse social media 9 to 5. That's a directive control. Now in this message, if I add one more point, if I find anyone browsing social media 9 to 5, we will take a very strict action against the employee. So this message create a fear. This message create a deterrent environment. Deterrent. Oh, so I am new to the company and I heard this thing is that I have seen this in the policy that no one's supposed to browse social media 9 to 5. And if they find us browsing social media 9 to 5, then they can terminate me. So it create a fear and I will think twice before doing this activity. So here in the directive control, this word was added to discourage the user. One more example is when you go to the bank. In the bank, it is mentioned you are under CCTV monitoring. It's a directive control. It giving you direction that the system is under the CCTV monitoring. If they don't put that message, it is considered as a spy. That is why they post this message. They post this sign that, okay, this area is under CCTV monitoring. So for an intruder, it is like a deterrent. Oh, there is a CCTV monitoring camera. It might track my activity. So deterrent access control or deterrent control is deployed to discourage the violation of our security functions. Deterrent control pick up where the prevention leaves off. Deterrent does not stop with trying to prevent an action. Instead, it go further to exact the consequences in the event of attempted or the successful violation. Okay, so we have a strong fence. We just created this information. We have a strong fence. Oh, they have a strong fence. Oh, I am unable to get into this facility. They have a too much security control. So this kind of an environment discourage my behavior. So that is called as the deterrence control. That's why it is not mentioned here, because it is just like a placement of the environment or create an environment. Next control is called as a preventative control. It is a control which used to avoid an incident in the organization. Okay. It is introduced to stop the unwanted or unauthorized activity from occurring. Example of a preventative control, like technical preventative, is firewall. We install the firewall to make sure unauthorized user should not able to access my facility. Okay, we install the lock, which will make sure physical user should not able to access the unauthorized area. Okay. Everyone has to sign in the register. So it is an administrative preventative. Until unless you don't sign, you can't access the facility. So message convey the meaning of preventative parameter. So that is called as a preventative control. Same example, everyone have a clear mandatory parameter. No one's supposed to browse social media 9 to 5. Now there is a one user. What he did, he tried to open social media. But there was a endpoint DLP installed in his laptop, or there was a proxy which is installed in the network. So whenever he tried to send Facebook request and all that, this proxy will try to block that. So that solution will prevent from browsing such kind of website, which is against the company policy. So we cannot completely rely only on a directive control. That is why with the directive control, we implement the preventative control. That is why it is part of building defense. But only rely on one single preventative control will not be a good effective practice. That is why we introduce the compensating control. Compensating control is basically introduced to support my existing controls. One common example I can give you. We introduce a policy parameter in the organization that every user must follow 8-character password. Now some users are frustrated. They set only 4-character password example, but we need to protect their accounts. So what we did, we enabled the OTP with that one-time password. So tomorrow, if their account get hacked, their password get hacked, still the hacker need a OTP access. So my first control, which is a password, is already hacked. But thank God we have enabled the OTP which stopped that activity. So that is a perfect example of the compensating control. So in this case, when he tried to browse social media, okay, he's sending a request by proxy. So proxy will try to block that, which is installed on the network. So what he did, he disconnect the network and he trying to connect his dongle. And through the dongle, he want to browse the private surfing. But what happened is there was an endpoint DLP which is installed in his system, which prevent him to run that internet connection. My primary control is failed. And that is why we introduce a secondary control, which is an endpoint DLP, which is installed in his laptop. Same like he trying to open the Gmail and through which he want to upload some data. And he discovered that, okay, he unable to send through his proxy. So he disconnected, he connect the pen drive, but there was an endpoint DLP installed in his laptop, which prevent him from copying those files. So my primary control was failed and secondary control is there to block that. But by hook and crook, he was able to browse the social media. So his actions get detected in the SIEM. That's why we have a detective control here. Detective access control is deployed to discover the unwanted or unauthorized activity. And here he was able to bypass the policy, he was able to bypass the proxy, he was able to bypass the DLP, so his actions get detected. So first thing what we did is a corrective action. So corrective control is basically like a temporary activity that we can do against the system. Okay, so corrective is like remediate the circumstances or mitigate the damage which is during the incident, which is done during an incident. So corrective control is deployed to restore the system to normal, not complete normal, but partial normal. One example I can give you that in this scenario that he was able to hack, he was able to access the social media. So he went against the policy. So HR took the corrective action is terminate the person, and security team, what they did, they have seized his laptop, or we have discovered the system was infected with the virus now. So corrective action was remove the system from the network instead of doing an investigation there. So that is a temporary activity what we did. And then we have a recovery control. Recovery control is basically restore the operating condition back to the normal. So with the same example is HR will find a new candidate and replace the person. So that is an administrative recovery control. And incident management team, what they did, they removed the virus, reinstall the new window and system back to the production. So corrective control is a temporary activity, whereas a recovery control is a permanent activity, repair and restore the resources. So I'm sure you get the visibility. I can give you one more example from a COVID point of view. The government has announced no one's supposed to go out. So it's an instruction. Some SOC people, what they did, they wore mask, they carry the vaccinations, which is part of a preventative and compensating. Preventative means they have a vaccination, but still they cannot trust that. That's why we're wearing a mask and maintaining a social distance, which is a compensating control. When they reach office, they detect with the RT-PCR test and all that, and we discover they have a COVID symptoms. Definitely there we cannot do the investigation further. So we have isolate them immediately from the family and from the company. That is a corrective control. And then we went for the 14 days recovery. That is a recovery control. So this is how the control category work. When we're talking about these controls are basically applied in a different states of data. And we have a 3 states: data at rest, like it is stored data reside on a hard drive, tapes, in the cloud or storage media. And this data is prone to the extraction by the insider or external attacker who gain access to the system and able to, browse through the content and all that. So data resides somewhere in a storage. Second, data is sent over the network. Okay. So when data travel on the untrusted network, it is open for eavesdropping attack and all that. And data is most vulnerable in a processing. Another name of data in processing is called as a data in use. Right now I'm running a PPT. It is a data in use. I'm uploading this video on YouTube. You can take a print screen of any PPT. So that is the data in use. So we use masking. Okay. We use tokenization during a data in processing. During a data in transit, we can use TLS, SSL, and data at rest, we can use a storage-based encryptions. Okay, so next topic is malware. You're one of the best friend if you're working in the SOC and you're going to encounter this. So these are the biggest threat for SOC analyst, because these are the one who's creating a problem. We have a doctors. So doctor investigating every day some kind of virus. Same like SOC, people will investigate a different kind of a malware. Okay, like we say a software. Same like we have a malware. And these are basically the one who exploit the systems. So first is called as a virus. Now virus is a kind of a malware which replicate from one system to other system with the help of human interference. Okay, so that is basically called as a virus. Now virus required human interference to replicate from one system to other system. Without human interference, it cannot be replicated. How? Let's say example, we have a system A which is infected with a virus and it slowed down the process and all that. I plug the pen drive and I copy some file. Along with that, virus also copy into the pen drive because it required power, it required memory. But when I connect the pen drive in the B system, automatically virus jump into the B system automatically. So that is called virus, which replicate from one system to other system. So worm doesn't require human interference. It can be replicated from one system to other system without any human interference. What is the meaning is, if the system A is infected with the virus, if system A infected with the virus, then, if system A infected with the worm, even B ping the system, automatically the virus replicate from A to B. That is called as a worm. Ransomware is a new kind of an attack where it is hack the system and encrypt the file. It hack the system and it encrypt the file. That is basically called as a ransomware. And then it asks for ransom. The primary goal is to hack and encrypt the files. Okay. Spyware, when you install, it start recording a keystroke. So the purpose of spyware is not to slow down the system, but slightly it's basically installed in a system, and whatever you're going to type, whatever you're browsing, remotely it send the information to the hacker. Purpose of Trojan is not a objective to slow down the system. Trojan was introduced to gain access to the system. So when you're talking about Trojan, we have a system A and we have a system B. I convince the B, hey, this is a very good application, install that, and the person installed that. Now what happened? I gain access to the system through that particular backdoor port. See, if I'm going to initiate the connection from the A to B directly, B will ask for the password. I need to provide the username password. But in this case, I installed the Trojan by convincing him. So now I'm gaining access to system B without any username password, which is called as a covert channel, stealth channel. Is it clear? But one of the biggest, and actually the biggest concern for us, Trojan, because by installing a Trojan, we perform a ransomware attack. We hack the system, we gain access, and then we encrypt the files. Another important malware which is difficult to detect is a rootkit. Root mean root level and kit is a construction kit. See, if you talk about the system architecture, this is how the system architecture look like. So we have a kernel, we have a driver, and here we have an antivirus. So antivirus install here, but if hacker basically hack into the kernel and he installs some kind of a rootkit on the kernel, antivirus will not able to detect. So if system is infected with the virus, worms, spyware, we can able to investigate because this is happening here. But rootkit is installed on the kernel level, which is like a backbone of the operating system. The only solution is basically clean installation, because it is easy to identify virus worm, but it's difficult to identify the system is vulnerable for rootkit or system is infected with the rootkit. So as a security analyst and all that, the major challenge for us to investigate the rootkits and the ransomware. Okay, so that's a very important part. So that is why to handle this kind of an issues and everything, we introduce the first thing called antivirus. Antivirus are the tool detecting, preventing, remove the malicious software from a system. That is basically called as an antivirus. So let's say example, we have a system A and system A is installed with the antivirus. So now what happens, any file comes, antivirus scan the file and check the file signature with the antivirus database. If any signature of the file is matched with the database of antivirus, the antivirus will block that. But if signature doesn't match, the file can enter into system. So one primary concern with antivirus is that if it's not up to date with the new signature of virus, it will not able to detect. That's why today we use a new modern solution, which is called as a EDRs. So antivirus is a tool designed to detect, prevent, and remove the malicious software from a system. And why it is important? Because logs from this tool often feed in SIEM for further analysis. So that is the reason. Some examples we have: Norton, McAfee, Kaspersky softwares. So these are some of the antivirus we have. I'm not here to recommend any solution. I'm just giving an example here. Another important tool that we are using is called as a firewall. Firewall. See, and antivirus install on the endpoint, but firewall we install on the border of the network. So if you take example, we have a system A, we have a system B, we have a system C. So we have installed the antivirus in every system. Okay, which inspect the data. Okay, but when we're talking about firewall installed here on the border of the network level, it monitor the traffic. It monitor the content based on IP. Okay, it monitor the content based on IP. So now what happened? So whenever any packet pass to the firewall check source IP, from where it is coming to where it is going, from which port is coming to which port is going. If it's allowed as per the firewall, they will allow the packet. If it's against the rule of the packet, it will block. So firewall was introduced to monitor the primary incoming traffic, what comes in. But whatever is going out, for that we also have a dedicated solution which is called DLP. But primary objective of firewall is to monitor what kind of a traffic is coming from outside. That's called fire. Wall is like a thick wall. So primary purpose of firewall is to monitor the attacks which is happening from outside. That something is part of a requirement. And firewall is a first line defense. So SOC Analysts often review the logs to identify, block, or suspicious traffic. That's why we have a different type of firewall here that I want to discuss. So first firewall is called packet filtering firewall. It's a very basic firewall. So when you're talking about packet filtering firewall, let's say example, this is the packet filtering firewall that we install on the border side. Here we have an internet. Okay. And here we have a system A, and here we have a system B. So A IP address is 10.0.0.2 and B IP address is 10.0.0.3. So now what happened is we have a user. So in the firewall we create a rule like source is any, because we cannot monitor from where it is coming. But if anyone is coming to 10.0.0.2, the source port is any, but destination port is 80. So if any traffic, when it passes through the firewall, so this is the packet content. This is the packet content. So we check from where it is coming. It has a destination IP, source port, and destination port. But we have a content also. So when the packet passes through the firewall checking from where it is coming to where it is going. Destination, it's mentioned 10.02 in the rule 10.02, fine. Source port is any, destination port is 80, yes 80. So they will allow this packet. But one primary challenge with packet filtering firewall, it does not inspect the content. Second is it does not track the session from where it is coming, no. And if A want to send the data back to the client, we need to create a manual rule in the firewall. So it's a very simplest type of firewall that we install on the border of the network. Now to maintain the session, I will install the circuit level proxy. With the packet filtering firewall, we install the circuit level proxy. So now what happened, the connection come by packet filtering firewall, and then circuit level proxy maintain the information about the connection from which we basically access the B. So that's why circuit level firewall works on the layer 5 of the OSI model, session layer. But again, the challenge is it unable to inspect the content. It track the session but unable to inspect the content. That's why here we install another firewall which is called as an application level firewall. So now the connection come by the packet filtering. Then from there it go to circuit level and then it terminate here, because application level proxy has to inspect a new connection initiate from this point to B. Now B send back the information to proxy, and then from proxy we take the connection to the user. So by this way we are adding the internal network from external. So you tell me in the comment box which one basically slow down the process, circuit level or application level. I'm waiting. So answer is basically application level. It slow down the process because it terminate, inspect, and reinitiate the connection. Then we introduce another firewall which is called stateful firewall, works on the layer 4. And it basically, the thin line difference in packet filtering and stateful is stateful maintain the information about the state from where it is coming to where it is going. And we don't need to create a rule for reverse side. But today we don't do all this, we use a next generation firewall which work from layer 3 to layer 7 of the OSI model. It inspects the source IP, destination IP, source port, destination port, and everything. Now, if you want to stop the video for a second and take a screenshot, you can take, because it gives you more clarity. Packet filtering firewall based on the IP address, works on the layer 3, only do the header. High performance because it doesn't do much inspection. Basic traffic, simple attack, simple and fast to implement, cannot inspect the application. Cisco ACL IP tables is the best example. Circuit firewall work at the session layer to monitor TCP UDP. Session layer, session level, moderate performance, filtering based on the sessions, session hijacking, invalid connections, validate the sessions, limited to session level, and checkpoint firewall is example. Application level works on layer 7 only, do the deep inspection data. Lower performance because it's a resource intensive. It can also block the SQL injections. Performance bottleneck, squid proxy, Zscaler is an example. Stateful firewall track the state of active connections. Layer 3, layer 4, deep track connections, moderates, protect the enterprise, monitor the attacks, track the session states, offering the enhanced security, and more important, more complex and resource intensive. So these are some of the solutions we have which is used. Hope you got the visibility on this area. Now the next topic what we have is called as a IDS and IPS. It's a very important topic, IDS and IPS. So when you're talking about IDS and IPS, IDS is a solution which detect the alerts, and IPS is the one which detect but block the content. Okay, so IDS is outline mode and IPS is the inline mode. Let me explain you with the example so you get a better visibility. Okay. Yeah, definitely. So when we're talking about IDS, let's take an example. We have a two type of IDS. One is called as a NIDS and one is called as a HIDS. So here we install the NIDS on the border of the network. We install the NIDS on the border of the network. So now what happened is we have a web server here and we have a DNS server. Okay, hypothetical scenario. So now what happened when the traffic, so we have attacker here sending a traffic. So traffic is going through the NIDS. NIDS will basically check the attack patterns, or they basically detect any kind of deviations from the baseline. What is the meaning of this signature base? So example like the traffic, what we have, they collect the traffic and they compare the traffic stream signature with the database signature. Do we have such kind of an attack? Or we can see multiple packets on the same time, which is an anomaly. So we have a two type of detection here. One is called signature base and one is called anomaly. Okay, it's very important for you to understand. So signature base match the known attack patterns and anomaly detect the deviation based on the baseline. Example, if any traffic is going on port number, it is okay. But if someone is sending on some other port, it's a concern. Is it clear? Like we have an alert that admin that has a high volume of traffic is detected, or we detect the malicious traffic and log into analysis. So these are things we have. So that's the thing. So here what happened, an NIDS install on the border of the network. But when the traffic pass, what kind of a changes it does in the web server DNS, it will not be inspect on the NIDS. That's why in every system we install the HIDS, host-based intrusion detection system. So IDS used to detect and alert, but here with that we install the IPS. So IDS will detect, but IPS will basically block. So that's why called IDS is a passive. If the traffic is going against the system and all that, it will only log, but IPS will basically block that particular attacks. So IDS is best for monitoring, alerting, and forensic analysis, but IPS is best for the real-time threat prevention and network security. Is it clear? That's something we have. And examples of the free tools we have, and why this solution is important for the SOC is because they use the IDS IPS logs to identify, investigate the potential intrusion. Okay, and examples as Nord, Suricia, and Palo Alto network. So there is a question might be coming in your mind, firewall also does the same thing. See, firewall provide the broad parameter protection, which like controlling access based on a rule. Where the IDS IPS was an old solution which provide deep inspection and real-time threat detection on the sophisticated attack. So the key takeaway you can say like that, the firewall focus on access control while IDS and IPS focus on content and behavior analysis to protect the more advanced sophisticated threats. That's the reason. Understood? Because if you take example of firewall, it block the traffic based on an IP, port, protocol, where the IDS IPS analyze the packet content for malicious payload. Okay, Firewall is limited to the basic rule matching, where the IDs IPS detect the malware, phishing exploits and all that. Okay. And if you're taking example of IDs IPS, they detect and respond to malicious traffic within an allowed connection like SQL injection, payload and all that. That's the reason. Hope you got the visibility why we need a firewall. So firewall operate on the perimeter, which is a border of the network. Here we can install the perimeter firewall, and IDs and IPS we can install on the deeper level like application or transport layer things. Today, if you're taking example of next generation firewalls and everything, it does all this inspection. So we don't need to take too much content or too much solutions. Okay. So next is called as the DLP. See, so far, whatever the solution we have discussed, it is monitoring the traffic which is coming from outside. Whatever is coming from outside, it will be blocked by the firewall. But when we're talking about DLP, DLP is a solution. So we have a system A, we have a system B. Okay. So what the DLP does, DLP is a tool designed to prevent sensitive data from leaving the organization. So DLP, what it does, it ensures data should not leave in an unauthorized manner. Let's say example, we have a user A, he is serving a notice period. Okay, so we have a user A who's serving a notice period, and now he has a culprit mind. He want to upload data on the public portal. He want to upload data in a public portal. So he tried to connect to the Gmail and tried to send the data. So what happened is when he's sending a data, DLP is installed here, which monitor the content and it will block the content. But now what happened is he disconnected from the network. He connect the pen drive and copying the content. That is also data leaving in an authorized manner. That's why in every system we install the endpoint DLP. So firewalls, IDs, IPS monitor what traffic is coming from outside to inside, but the DLP monitor the solutions, monitor the data which is going from internal to external. So this is the tool designed to prevent sensitive data from being leaving the organization control. So why it's important, because SOC team monitor DLP alerts for potential insider threats or extended data leaks. So examples, we have a Symantec, DLP, ForcePoint. These are the solutions we are using for this activity. Okay. The next is called as a honeypot. Honeypot is also very important things, because when you're talking about honeypots are like a dummy system we install. So before we having a threat intel concept, like discovering the threats and all that, we use this honeypot only, because here, let's say example, we have firewall. We create one zone which is called as a DMZ. And there's a very interesting story behind that. And then we have another firewall. And then we have a internal network. So why we have such kind of DMZ is a concept came from military. Whatever the public facing server we have, we always keep it in the DMZ. Whatever the public facing server we have, we always keep it in the DMZ. Why we introduce that? Because initially, if we have all system in a same network, let's say example, we have a web server and we have a database. So in the comment box, please let me know which one is critical. Web server is critical, but database sensitive. And if we have firewall here, if I consider this database, I have to put more restrictions. But if I consider web server who providing service on the internet, we have to have a limited firewall rules. If we have a limited firewall rules, anyone can able to bypass the firewall, attack the server. Understood? Understood. So that's why we segregating a network. So whatever the sensitive server we have, we can keep it in the internal network, protected by the strong firewall. And whatever the public facing server we have, we can keep it in the DMZ, like web server, VPN, DNS and all that. So here we also install the honeypot. See, I know I have a weakness in the web server, the port 80 is there, example, but I don't know what kind of an attack can be done on that. I don't have money to invest money on the pen testing. So we install the dummy systems and wait for the attacker to attack that. So when the attacker do attack on those systems, we learn from the attack, and according to that, we improve our defense. And that is called as a honeypot. So interview question will be there is honeypot is an enticement or entrapment. So it's an enticement. We never use the word entrapment in our enterprise. So it is an enticement which commit the person to do the attack, and we learn from the attack. So with the why it is important from a SOC point of view, because it provides the intelligence on the attack behaviors and TTPs. And examples, we have a KF sensor, HoneyNet. Okay, so that is basically called as a honeypots. So let's move to the next part called type of attackers. Okay, so now we're going to discuss about the type of attackers, or you can say hackers. So first is called, so attackers or hackers are the one who play with the functionalities, who use their brain, and you optimize the technology in such a way which can be used for offensive and defensive word. Hackers are always not a negative statement. Hacker can be positive also. Okay, we have a different type of hackers. See, example like I am a chef. I'm cooking something. Okay, I'm cooking dal. I'm making pizza. But I add my own taste in that by using my skill. So I am also a hacker. Okay, I am also a hacker. So hacker is mean using an existing functionality in such a way to create a value in any way. It can be offensive, it can be defensive. Now same chef can mix some elements into that. That is also possible. So we have a different type of hackers. So first is called as a black hat. They are the hackers, are malicious hackers, and their objective is always offensive. I want to hack a server because for my personal gain, not for social service. So that is called as a black hat hacker. White hat hacker, I know what hacker can do. I know hacking, but I'm not going to use the hacking for the offensive. I'm going to use hacking for defensive. Let's say example, company has hired me as a white hat hacker. It is also called pen tester. And he told, okay, Prab, do the hacking on my websites, do the hacking on my servers, and let me know what kind of a bug we have. So before actual hacker hack for their personal gain, we are trying to hack to see how to secure this. So I'm doing a hacking not to do damage, but for the defensive purpose. Now, one more category of black hat hacker, we used to have a script kiddie. They are those people who using a predefined tool. Let's say example, I'm the one who developed the hacking tool, but the script kiddie will use the same tool to perform the hacking. That is called as a script kiddies. I'm hacking for a particular cause. Okay, I want to promote the social message. I want to promote the economic message. I want to promote the political message, religious message. That is called hacktivists who hack for a particular cause. Like let's say example, during a WikiLeaks, lot of hackers basically targeting the, this Amazon or MX websites and all that, because they have stopped the payment for the WikiLeaks. So they're hacking for a particular cause. So they hacker motivated by political, social and ideological reasons. Nowadays, you have seen the clash between the Russia and Ukraine, then Iran. So we have a lot of clashes. The hackers basically hacking the known websites. They know, okay, people going to visit those websites. So hack those websites and publish the political agenda there. So that is called hacktivist. Sometimes what happened, government hire these hackers, which is called as a state sponsor attacks. So hackers backed by the government, and they are called as APTs, Advanced Persistent Threat Groups. So it backed and supported by the government. Let's say example, today we have a new concept called cyber war or warfare. So Russia hire the hackers to target the Ukraine infrastructure. Ukraine hire the hackers to target the Russian infrastructure. Let's say example, I'm trying to hack their airport systems, or I'm trying to hack their nuclear plants. So they always have a public funded, government funded and all that. So their goal is to intercept the political messages, political campaigns, what is happening in the other countries. So their motivation is to espionage, political advantage and disruption. So APT campaign, election interference. Let's say example, 2016 when the US election happened. So hackers tried to hack the machine, they said. They tried to manipulate the election campaign because for their personal benefit. So that is called as state sponsor attacks. Cyber criminal is a kind of black hat hackers. Okay, their purpose is to financial profit. Insider is not a attackers. Insider is not a hacker. We call it as an attacker because insider, like I join based on a fake data, and I got access to the Intel networks and I'm doing something bad. That is called insider. Or I'm not happy with my increment and now I want to exploit, I want to damage my company reputation. So I'm an insider. Okay, he's not a hacker. Okay, insider, like, take some information, giving to the competitors and all that. Then we have a whistleblower. Whistleblower is an individual revealing the unethical practice within the organization, often using a hacking technique. You heard about the Edward Snowden and all that. They are the whistleblowers. They're doing for the cause also. But might be from a company point of view, it's a bad practice because they're leaking a classified informations, internal emails and all that. Then we have a now new concept in 2024 called bot master, where hacker controlling the botnets to launch an attack. Let's say example. So we have our parents. Okay. They're convincing us to get married. And we know we will not going to listen. Now parents, what they did, they compromise the relatives to convince me to get married. That is called as a botnet. Same like hackers are there who hack the multiple systems to launch an attack against the target. That is called as a botnets. And their target is to do the financial gain, power down, launching DOS, sending spams and mini cryptocurrency. Recently in Japan, airline is also a victim of the botnets only. Nowadays, the advanced version of APTs are called as a cyber terrorist. They basically hack who target the system to cause panic, fear or destructions. Their objective is political, ideological, religious, and disabling the critical infrastructure, spreading propaganda through the cyber channels. So in this particular SOC analyst sessions, we're going to focus on one particular group which is creating a big impact, is APT, Advanced Persistent Threat. They are a highly skilled, organized, stealthy cyber attacks typically conducted by nation state or highly sophisticated group. And one thing we need to understand is these attacks focus on gaining unauthorized access to network, maintaining a persistent access, and they maintain the access for 7 to 1 year. Example, like one government has hired a group of hackers to hack the another government database, websites, and all that. So this is called government funded. So the characteristics of APTs are, they are like a hackers, but they're a group of hackers. They are more sophisticated, more advanced, and they maintain the persistent access of the organization network. A good SOC analyst is the one who can detect this as early as possible before they do any damage. So they have a characteristics. So first is called advanced. They use a sophisticated tool and techniques like zero-day exploit, custom malware, social engineering. They're not a script kiddie. Second is persistent. The attackers stay hidden within the network for a month, even year. See, if we talk about the new hackers and all that, they don't have a patience because they're not getting any kind of funding and all that. But they have a patience. That's why they're maintaining a persistent access. And last is targeted, focus on specific organization, industries, and defense, government, and all that. And last is called as a motivation, which is called geopolitical, economics, and all that. So that something is a motivation they have. Is it clear? So we have some example of APT groups, like we have one of the famous one called APT Cozy Bear. They are associated with the Russian intelligence, they claim, and focus on espionage targeting government, think tanks, and healthcare. So notable attacks, what they did is SolarWind. I'm sure you know that SolarWind. Then COVID-19 vaccine research targeting healthcare infrastructure, and the origin of the country is Russia. Then we have a APT 28 Fancy Bear, again another Russian group linked to GRU. 2016 US elections attack the NATO's. Then we have a APT 41, a Chinese group that blend espionage with financial gains, target the industries like healthcare, telecom, and gaming, exploit supply chain vulnerabilities and cloud environment, China. And Lazarus group, oh my god, it's one of the biggest group based on North Korea. They are the one who hacked the Sony Pictures, WannaCry, cryptocurrency exchange, and all that. So these are the common groups we have that you must be familiar with. So I must say, if you're looking for the great learning on the SOC analyst, or if you're looking for the great learning on defensive sectors and all that, do research on these APT groups, how they hack, how they attacks and all that, what is the method they use. So it can be very important for you for your great defensive learning. Now next topic is called as a malware investigations. Okay, so we have a next topic which is called as a malware investigations. See, when you're working in the defensive sides and all that, one of the profile we used to have a malware investigation or malware analysis. And I'm sure you can see definitely in the future a lot of demand for the malware analyst professional. So what they do actually, whenever any organization infected with the malwares or anything happen on the enterprise or anything happening on the industries and all that, so these people, what they do, they investigating that malware. Okay, so three things we check. One thing is missing here. So one important thing we talk about is the behavior. That's the most important part we have. And the second important thing, who is the author? So example, if our organization is infected with one malware, I need to identify the author. Who is the author? Because by doing the author identification, we get a better visibility. Then we identify the behavior. Then we identify intent, then potential impact. So by doing a malware investigations, mostly done by the L2 and L3. So ultimate goal is to understand so they can able to reduce, or which is called contain or remove the malware, update the defense to block the future attack, update the signature, and provide the actionable insights. Now question is how we do the malware investigation. The first step is called as an initial analysis. So let's say example, we got a malware and we need to determine if suspicious file or activity is a malware or not. So we use a open websites which called VirusTotal. Okay. Apart from that, we have a EDR logs, hash analysis, which is used for the analysis purpose. So with the first thing, on the safer side, we check the file hash value and compare it with the known malware database like a VirusTotal. Then we use a EDR solution to review the suspicious files, which basically activates trigger by the file. Now, once we're done with that, then we do the static analysis. Static analysis, we analyze the file metadata. Now, when I say metadata, we include about file types. Okay, we look for the creation date, when it's created, what is the size of the file. So we try to extract the strings to find the hard-coded URL, IP or commands. And we use a tool like pstudio, strings, exeinfo, and .p. The third is called as a dynamic analysis. We passively analyze the behavior of the malware. We run the malware in a sandbox environment and we observe and observe the activities, like we see the processes, we see how many file it's creating, what kind of a registry it's basically modify, and more important, we also look for the important elements like network connections established on which IPs. So example, like if my system is infected with the malware, so that malware is creating a remote connection, revert connection on some IP. So we will investigating on which IP the establishing connection. Then we do the behavior analysis, where we use a network monitoring tool like Wireshark packet to analyze what kind of a packet are sent or received by the malware. And we also monitor the system performance. Example, like we check the memory usage and CPU spike. If you involve the coder and all that, we can do reverse engineering. So with the help of advanced analysis, we can decompile the malware using a tool like IDA Pro, Ghidra, and we identify the encryption method has been used, exploitable techniques or payload, what they basically use. So all those things is part of the requirement. Then we basically look for another thing called IOC generation. In my next slide, I'm going to discuss what is IOC. So IOC is called as an indicator of compromise. It is an evidence of the system got hacked. Example, I can see the evidence of the malware in my system. So that is called as a IOC. So what kind of a changes is introduced in a registry, file hashes, IP addresses, evidence in the logs that can be used. So we share the IOCs with the threat intel platform to get the wider protection. And then finally we have a reporting. So these are the kind of a techniques we are using for the malware analysis. Mostly done by the L2 people and L3 people. It is confirmed by L1, but it is investigated by the L2. So that something is part of a requirement. Now next thing is called as the different sources of finding the information. So when you hunting for threats and all that, we use different source. So before I jump into detail, first understand the different type of websites we have. So first is called as surface web. Surface web is a visible part of the internet, easily accessible by browser, indexed by the search engine. In layman term, go to Google, whatever you search, that is a surface web. Then we have a deep web. Deep web is like private required credential, like Gmail. So you log in with Gmail with your password. Without password, you can't access, or some internal URLs. It's still accessible, but you need a password. Then we have a dark web. Dark web are like a anonymous, hidden or required special tool like Tor to open, and their websites are opened by the .onion extension. Okay, let's take an example. You go to the mall. Okay, so this is the mall we have. So when you enter into the mall, you can see a stores. They have given the name to the stores. So that is like a surface web. Some malls require some access controls. That is called deep web. But now you need to access some shady areas to buy some restricted items, which is not supposed. So they have agents. The agents are called as a darknet. They will take you to that location to get the restricted items. So the item that you're taking from that is called as a dark web. And the person who taking to there, that is called as a darknet. Okay. And dark web. So these are basically the different websites we have. When SOC analyst works, they mostly use the dark web information because they find more information from dark web. You can imagine 4% you're browsing from surface web, 96% actual data you will find in dark web. So for that, you need to use Tor browser. Like the way we have a Mozilla, same like we have a Tor browser. You install the browser which connect you to one restricted servers, and from there you can able to access those restricted sites. You cannot simply open those sites on Google. Now, if you want to think like an attacker, we have to understand the concept cyber kill chain. Okay, so that is my next slide, and that I have taken from a previous scrap video which gave you the great insight of a cyber kill chain, because you have to think like a hacker, so that you can able to block the attack as early as possible. So next video is all about cyber kill chain. Our next part is talk about the cyber kill chain. So let's start with the introduction of the cyber kill chain. Cyber kill chain is a framework which is part of the intelligence driven defense model, which is used to identify and prevent a cyber intrusion activity. And it is developed by Lockheed Martin Corporation. The same corporation was involved in a lot of innovations in past, which include the vertical like aerospace, arms, defense, information security, and technology corporation. Cyber kill chain build a 7 phases parameter by which they're trying to understand the behavior of the attacker to gain access to the organization. The 7th step of the cyber kill chain enhance visibility into an attack and enrich an analyst's understanding of the adversary mean enemy or attacker, tactics, techniques, and procedure. See, normally what happen if we talk about the traditional defensive posture is like that. Suppose we have a firewall. Okay, and this is my server, web server. Okay, so we created some kind of a rules in the firewall. So there is an attacker. Let's take an example. So there is an attacker. He discovered my information on the public forum, used the information, and from there he tried to attack my web server. The firewall also working on some static rules and all that, and based on that only it inspect the traffic. So attacker basically discover some sensitive information about the website or anything on the public forum, use the information by doing a social engineering, and by which he trying to gain access to the things. So we have to think from an attacker perspective. Okay, what phases attacker basically use? What phases attacker is basically understand? What phases through which he tried to gain access to the things, so that we can able to break those phases and we can limit the attack. So think from an attacker perspective, think like a hacker and build the defense. We know very well there is a website in which my company OS details configuration is there. And that is like a turning point for the hacker to use to hack against my server. So what I did, I report that information to the concerned authority and we have shut down that website. So by this way, we have limited the attack. So we think from an attacker perspective by which we're trying to reduce the impact. And that is what is covered in the cyber kill chain process. So in cyber kill chain, the model basically identify what the adversaries must complete in order to achieve their objectives. Stopping the attacker at any step interrupt the attack chain. As I said, we have a systematic way to gain access, right? So we just breaking the chain. I'm sure you heard about lot of trend about this COVID virus and all that, right? Kill the chain. So it should not replicate. Same thing here. Attacker using the multiple phases, multiple steps by which he trying to hack. So we just breaking those chain. So kill chain as a word, when I say cyber kill chain is a word which comes from the military concept, which is used to identify the structure of an attack. And it consists of the 4 phases: identification of target, dispatching of the forces to target, initiation of attack on the target, and destruction of the target. So 7 steps of cyber kill chain enhance visibility into an attack and also enrich analysts' understanding of the adversary, tactics, techniques, and procedures. So in this process, with the help of this methodology, we're trying to understand the tactics, techniques, and procedure used by attacker. And we can use the same techniques, tactic, procedure against the hacker only to stop this attack. Okay, so let's discuss about the phases of the cyber kill chain. So first phase in the cyber kill chain is called as a reconnaissance. Okay, reconnaissance. Normally what happens, any attacker gather information about the target. Let's take an example. There is a website, DNS services, email server is hosted on my DMZ. So this is my network. Okay, we have a 2 network here. One is called as an internal network. We have an internal network and we have a DMZ. So we have some systems in the DMZ which is basically hosted for the public communication. Now what happened is attacker try to discover the informations. Okay, he visits some third-party website. He visits some kind of forums from where he tried to collect the email address of the employees, collect the information related to the website, because there are so many websites are there which also store information about the configuration of the server, OS details, and all that. Okay, so attackers use that particular websites to collect more and more information about the configuration, like whois.sc. So if you go to the website, you will get the whois detail about the website, where you talk about the IP. Then there is a nstdomain.com we have, from where you get the information about the server hosting which kind of an operating system. So these are basically called as a initial phase we have, by which he gather the initial information about the target. And this information gathering is called as a reconnaissance. So we as a security analyst, we're thinking from their perspective and we reach out those websites and we're trying to take down those informations from those websites. So by this way, we can able to limit the attack. Clear, team? So reconnaissance is all about where the intruder select the target, research it, and attempt to identify vulnerability in the target network. Second phase is called as a weaponization. Weaponization, where the intruder create a remote access malware weapon such as virus, worm, backdoor, Trojan, and they try to deploy in one of the systems. Okay, that is called as a weaponization. Third is basically called as a delivery. Delivery is basically where the intruder or attacker transmit a weapon which is developed. So malware has been developed, and now we need to deliver that malware. So I identify, so as an attacker, I identify one of the employee who working in the company. His name is Ramesh. So I saw his profile on LinkedIn, I saw his profile on a Facebook and all that. So I sent him a phishing email. Okay, and I'm waiting for the person to click on the link. So what happened is he received an email, he click on the link, and by which the malware is basically downloaded in his system. And now that system, which is basically part of the internal network, able to help me to establish the connection. So that is basically called as a delivery. So delivery here, the attacker transmit a weapon mean malware, which is developed in the second stage, weaponization. Okay, so it transmit a weapon to the target via email attachment, website, or USB drives. Okay, then once you deliver, the next part is basically called as a exploitation. Exploitation is basically where the malware, whatever it is there, Trojan, backdoor and all that, it is trigger in that system. Okay, which take the action on the target network to exploit the vulnerability. Because when the person has download, when the person is basically download that particular malware, it is basically create a backdoor, and then through that backdoor I gain access to the system. So that is basically called as a exploitation. And then further I can use that system as a zombie, or I will use that system as a bastion host. From there I can able to attack the further system. So that is called as an installation. So malware weapon is install, which is access point, which is used by the intruder, and then I will use that particular channel as a command and control channel. Command and control channel is basically like a malware which enable the intruder to have a hands-on keyboard. So now I have a remote control over the system, and then further I can able to extract the data, retrieve the data from the network. So understand in this way, let me explain you. So there is an attacker. Attacker basically visit a LinkedIn website. He visit Facebook. He visit Twitter to collect the information about the ABC company, because my target is ABC. Okay, so from this particular source I got the information about the employees. Okay, how many employees we have, or what are the possible employees we are working in the ABC. I visit some website also, from where I got the information about the web configurations. I also get the information about the IP address. I got some information about the DNS. I also get the information about the company activities, the news media and all that. So this is basically called as a reconnaissance. Okay, initial information gathering. Based on that, I basically build the malware. See, if I want to hack any system remotely, I want to build a malware. So here the malware is called as a backdoor, or you can say it is also called as a Trojan. Okay, so I will create a Trojan, okay, which I need to deploy in any of the systems. So from the LinkedIn, Facebook and Twitter, I identify one person whose name is Ramesh. Okay, Ramesh. Now let's create a diagram. So this is the network diagram we have. We have a DMZ and we have an internal network. Ramesh is basically part of the internal network here. You're working on the desktop. So this is the Ramesh desktop. Okay, I discovered his profile, and now what I did as a hacker, I sent him a phishing email. I sent a phishing email. So this is basically the third step called as a delivery. Okay, so what he did, he clicked on the link because 90% of attacks is done through the social engineering only. So I identify Ramesh, I create a fake profile, and from the fake profile, I sent an email to Ramesh. Ramesh click on the link and the backdoor is basically downloaded in that system. So that is basically part of the delivery plus exploitation. Exploitation means it is triggered into the system. Now, once it's triggered, it is installed in the system. That is basically called as a fifth phase. And then it creates a reverse connection for the hacker. And now through that particular channel, I gain access to the system to control over the system. And from there, I gain access to further systems. So as a security analyst, we understood from that perspective how the hacker hack. So I can able to break the chain here. 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 So identify the attack points, okay, so that I can able to stop the attack on those points by which we can have a limited impact. That is what is called as a cyber kill chain methodology. So it's same example. If you notice, reconnaissance is all about research, identification, and selection of target. Weaponization is all about creating a backdoor, malware, and anything. Then delivery is a mechanism we decide how to deliver the malware into destination system. Once the malware is installed in the system, we're going to trigger that, which is install the malware in the system, through which I gain access to the system and extract the data from the system. So I have one case study here which give you visibility. So here you can see the reconnaissance. So within the weaponized, there is a PDF file was there. Okay, I sent that PDF file to the destination, one of the victim and all that. Okay, because I discovered the person is looking for the same PDF. So I built the same PDF and I sent this particular PDF and I encrypt this PDF with some encryption so that on a destination side, there is no antivirus to be able to detect that. So I basically deliver that particular file by email to the person. When person download the email, there was a shell code in that, which is called CV 2009-0658. When he basically run that shell, that is basically installed in a C drive with the name of ffsm32.exe. And then on my IP, we have established the command and control sessions. And then I extract the data from the system. So as a security analyst also, we can check these areas and identify the logs which give me the intrusion about the system activity. Understood? So this is the parameter we have used by which we have performed the attacks. So the next part is called as a indicator and the indicator life cycle that we need to understand. See, fundamental element of the intelligence in this model is the indicator. Indicator can be divided into three types. The first type is called as an atomic indicator. Atomic indicator are those which cannot be broken down into the smaller part and retain their meaning in the context of intrusion. Example like IP address, email address, vulnerabilities, identifier. These are called as atomic indicators. Second is basically called as a computed indicator. So computed indicators are those which are derived from the data involved in the incidents. The common computed indicators can be include your hash values, regular expressions which is used to perform the attacks. And third is called as a behavioral indicators. Behavioral indicators are the collection of the computed and atomic indicators which is subject to the qualification by the quantity and possibly combination of the logics. Example like there is an intruder who would initially use as a backdoor which is generated a network traffic matching at the rate of particular IP to the particular parameter. So here the atomic value has been used with the computed value has been used to perform the attack. So whenever any indicator of attack happen, it is a combination of all the three values by which it basically establishes the attacks. So we need to identify all these indicators to proactively protect the organization from the attacks. Clear? So now we need to understand the defensive cybersecurity posture based on the cyber kill chain methodology. So we have this process here which give you better visibility. Yeah. So this is called as a defensive posture that we can basically build based on a cyber kill chain methodology. My first perspective is the detect. Okay, detect basically mean we determine whether intrusion is present or not. One more important thing we need to understand from the detect perspective is we need to verify that, some attackers is looking around, or, we need to introduce some kind of a methodology by which we can able to analyze the behavior of the information parameters and all that. Example, you can enable the logs on the websites. So by this way, we get the information, okay, someone is trying to find any information from the website by sending some kind of a request and all that. You're getting a point. So that is how we can able to detect in advanced stage if someone is gathering any information. Then second is basically called as a deny. Deny is basically all about reduce the impact. Deny basically means prevent an attacker from gaining the information. Now we understood like this kind of information attacker can use, or this kind of a technique the attacker can use to perform an attack against the target network. So we need to block such kind of a things. So we need to apply some deny controls which prevent an attacker from gaining the information. Then we have a disrupt, where we're trying to stop or change the traffic, which is basically part of a disruptions. Okay, it means we build the topology in such a manner we can able to disrupt his connections and all that. Next is called as a degrade. Degrade is basically where the attacker command controls. So whatever the command controls he trying to create, we try to reduce the impact. We try to discard the channels. And next is basically called as a deceive. Deceive is basically where we interfere with the command control and check what kind of a data they're trying to send. And finally is called as a contain, where we're talking about the network segmentation changes. See, understand in this way, if someone is trying to sending a request to my websites and all that, I would like to know what kind of information they're sending to the website. Okay, so I want to detect that. Second is we can have a defense in depth in the organization by which I can able to deny the attacks. So that is called deny. Now third is called as a disrupt, means stop or change the outbound traffic. Outbound basically mean the traffic which is going from internal to external. Okay, so we understood very well there is a possibility that the hacker will basically send the phishing email to the employee of the organization. An employee click on the link, so there is a reverse connection is created. So we need a DLP in place, we need an endpoint DLP in place which try to prevent this particular action. That is why we called as a disrupt. Okay, then is called as a degrade. Degrade mean if he trying to initiate the connections and all that, DLP is already in place which try to stop the attack. And even it is basically able to establish the attack, I want a proxy by which I want to intercept what kind of a data they're sending. And finally, we can have a multiple network segmentation. So even the hacker hack into one system, maximum he can able to access till this network only. So this is basically called as a defending capability that you build, okay, based on the cyber kill chain process. See, defender can measure the performance as well as effectiveness of this action, and plan investment roadmap can be used to rectify any capability gap. Fundamentally, this approach is the essence of the intelligence driven in the C&D. Okay, so one example is USCNet. So USCNet investigation of the 2013, the target corporation data breach include the analysis based on the cyber kill chain only. Okay, they identify the 7 stage where the controls did not prevent or detect the progression of the attack, and according to that only they plan the functions. I have one diagram which give you visibility about how the controls can be placed in the detect, deny, disrupt, degrade, receive and contain. So this is the reference I have taken from the research paper of Lockheed Martin content. Okay, in the description box you can find the URL of the same. So example, as I said, during a reconnaissance, the hacker trying to gather the information. Might be they're trying to connect with the website, and from website they're trying to collect the information. So on the website, I enable the web analytics to get the idea about what kind of a behavior is happening on the website. Understood, team? Second is basically there is a possibility attacker preparing a malware and trying to send the malware. So to launch the malware, so we need some kind of a solution to detect the malware. So we install the NIDS. Okay, we provide the security awareness training to the employees. No one should be able to click on the links and all that. So by providing a security awareness training, we have vigilant the user so they can able to detect and notify immediately to the incident response team. If you're trying to install any kind of a malware, Trojan and all that, there is a HIDS can able to detect that. There is a HIDS able to detect the parameters, and NIDS will basically ensure no connection will go outside. And audit logs give me the idea about what went wrong. So from the detect point of view, these are the solution we can install to understand the pattern. Now you want to block the connection reconnaissance level, you can have a ACL, you can have a NIPS, network intrusion prevention system. You can patch the system so no one can able to exploit that. Okay, now you want to learn some new attack. You can basically have a honeypots here. You can have a DNS redirect. You can have a fake system configure here. Okay, so according to the methodology, you can able to place the solution by which you can learn the attacks and you can able to protect the organization from the further advanced behavior. So this matrix depicts the parameter of how the solutions can be placed and organized in the network. So this is all from my side, and if you find this video useful, do share in your network and do let me know what is the next video shall I make on the SOC section. If you still not subscribed to my channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss my future videos on a similar topic. Thank you so much. Goodbye. So normally any threat intelligence interview questions is always start with the basics, definitions and all that, because the interviewer want to know, do you know the basics? Okay, so they just want to understand that, okay, you have a basic understanding of the information security. And that is why I thought I will start this interview session with the basics. So normally the first question they will ask is, can you tell me about what do you understand from the word threat? Now different people give different definitions on the threat. Okay, so you have to be very confident, and according to that you need to answer the question. So if someone asks me what is threat, so threat is an action that compromise security. Okay, it is an action which compromise the security. Example, hacker. So hacker is a threat for the company who can discover the vulnerabilities in the system, they exploit, and through which he gain access to the system. Let's take an example. So we have a hacker here, malicious hacker. He discovered the weakness in the system. Weakness here is password issue, weak password. Okay, no patch. So hacker basically discovered this weakness, and then he exploit that weakness and then gain access to the system. And then when he gain access to the system, it is like a disclosure of a data, modification of the data, or anything else, which is basically the impact we have. So thin line difference between the threat and vulnerability is that threat is an action that is basically we perform, and vulnerability is a weakness which is exist in the assets. So here if you go by the response, your response can be threat is an action or event that potential to adversely impact organization operations, organization assets, or individual through an information system via unauthorized access, destruction, disclosure, modification of information, and denial of services. See, threat is always driven by three important factors: intent, opportunity, and capability. Okay, it's meant capability, but it is more like a capability. So intent, opportunity, capability. So as a security analyst, it is very important for you to understand what is the intent of the hacker. Like his intent is to have a financial parameter, or he want to have some kind of a political opportunity, he want to promote some social economic message. That might be the intent. Second is what kind of an opportunity he discovered so that he was very confident, and what is the capability he has by which he tried to exploit. So out of these three aspects, you generally have no control over the capability and intent. Okay, because it is their predictions. Okay, we cannot control their capability, we can't control the intent. What we can do is we can able to reduce the opportunity, which is called as a weakness. Okay, you can influence the third component, which is basically called as a weakness. So one more example is, suppose you set up the office and decided to initiate the work from office. You can hire guard, install locks, install cameras, gate reader, but unless you have something to think of someone else going to attack you, it's a waste of money. Might be thief or attacker find other technique to exploit, so it's a waste of money. So it is very important for you to first understand the intent and capability. Okay, so first you need to understand what is an opportunity available, and according to that you can able to prioritize. Okay, let's move to the next interview question. Okay, so what is threat intelligence? Before going to understand, or before going to, I will give you the response of threat intelligence. Let me give you a brief idea about what is threat intelligence. See, normally what happens if you're talking about the traditional security. Okay, let's take an example. We have 4 friends. Okay, we have 4 friends. Friend 1, friend 2, friend 3, and friend 4. His name is Ram, Shyam, Mahesh, and Suresh. And this is me. Now here what happened? Father of Ram called him and take him in a marriage, where without his information they confirm his marriage. He went for someone else's marriage as an event, but his marriage got fixed in that particular marriage. Same thing happened with the friends too. His dad, Shyam dad, called him for a marriage invitation. He went to that marriage, and later on it was got to know that his dad fixed his marriage in that marriage. Third thing happened with the same. He called, take him into marriage and fix. Same thing happened with him. So here I got this idea, which is called as a modus operandi. Okay, that dad is calling for the marriage, someone else's marriage, and there they're getting their marriage itself is fixed. So this is something I predict as a threat. This is something is a data I gather, and then I basically correlate this information, and then I apply my brain. If next time my uncle or my dad called me for any marriage, I will definitely not going to attend that marriage, because I know my marriage will get fixed there. So it's an incident for me, right? So same like we have houses in our society. House 1, house 2, house 3, house 4, and house 5. So 1, 2, 3, 4. We install the lock in every house. We install the camera in every house. So it is like a control, right? We can able to track and we can able to prevent. It's a traditional security control. Now what happened? There is a thief. Okay, he knocked the door and asked for the help. The guy came out from the house, unlocked the house, and greet him what he need. He covered up his mask and he basically shown his gun. And based on the gun, he basically loot the entire house. Okay, they looted the entire house. Same thing happened with this, same thing happened with this. Now after that, the cop has understood this pattern, and they have notified the 4th house that if someone is coming and telling, okay, they are coming from NGO, please help me, do not open the gate. Okay, if you find something suspicious, just notify us first. So here what happened, instead of we react on something, we predict here. If someone asks me this kind of a pattern, because we already have a lock, we have a camera, but they cannot predict such kind of a patterns. You getting my point? So here what happened, we have informed this mode of attack to everyone. Like, some houses got looted by this kind of a things and all that. So we informed everyone about this. So they understood this particular threat pattern. And then they basically got a lesson from this. Now any thief knock their door, they immediately call the cop, and cop will basically stop him before they rob the house. Because normally what happen about traditional security solution like firewall, SIEM, they work on the patterns. They create a rules. Source is any, destination is a web server, source port is any, destination port is 80. Now what happen if any attacker even sending a traffic on port number 80 might be sending an exploit, so firewall cannot able to block that. Okay, we sending a series of packets which is look like a normal traffic, but it is a DOS attack. Okay, multiple login attempts on the legitimate server from a legitimate user. But now we have captured this as a threat pattern. Okay, in advanced way, so that I can able to block them in an advanced level. So that is what is called as a threat intelligence. So before it occur, we can able to stop that. Understood, team? So what is threat intelligence? So threat intelligence is all about analysis of information related to the adversary who have the intent, opportunity, and capability to harm you. And threat intelligence is the data that is collected, processed, and analyzed to understand the threat actor motives, target and attack behavior. Apart from that, threat intelligence enable us to make a faster, more informed data-backed security decisions and change their behavior from a reactive to proactive in the fight against a threat actor. That is why it is called as an active defense. So now what happened? If any kind of a attack, if any kind of an attempt has been done, like numerous login attempt, number of packets, we already have a profile for similar kind of a pattern. If we found the similar kind of a pattern, we can able to block that. Let's take one scenario here. Okay, so example, like we have one antivirus company. Example, this is my antivirus company. Okay, one of the researcher has basically discovered the virus. Okay, and then they have submit that particular virus detail to the antivirus company. Antivirus company basically test that virus in their lab. Okay, so this is the virus we have, which is basically test in their lab, where they're trying to understand the content of the virus. Okay, we're trying to understand the context of the virus, how it works. And we also try to understand who published that. Okay, now then they basically notify everyone about this issue, but might be there is a possibility it will take him around 10 days. Okay, till 10 days there is no solution. People not aware about this. So there is a possibility hacker using a same virus to attack multiple things. So now what happened? They have created a threat profile for this. We call it as a feed. That this kind of a content we have, this is the context we have and published by this IP. If we get similar kind of a pattern, block it. Understood? So threat intelligence basically maintains such feeds, by which if something happen like that, they will notify firewall, they notify antivirus, they will block it. Okay, so that is why threat intelligence is called as an active defense. Next question. So question is, why threat intelligence is important today? So here interviewer asking this question because you want to understand, do you have a visibility about the threat intelligence, or you just simply went through some YouTube videos and based on that you prepare your knowledge. Okay. So here he just want to know, or she just want to know how much you are good in threat intelligence. So you need to give a response in a very positive manner. Okay. If you haven't worked on it, do some research why we need this solution. I gave you the idea already why we need this solution, right? Proactively, we can able to predict this pattern. We can able to block it. So you can say like that, it enables the cybersecurity stakeholders by disclosing the attacker motivation and approach, tactic and process. And second is it helps the security professional understand the decision-making process of the threat actor. Understood? Because if you take example of a traditional parameter, we have a firewall, we create a rule in the firewall. If the traffic is against the firewall, then only it block. But what about the pattern of attacks? What about the series of attack? Firewall will fail to recognize that because for firewall, it's a normal traffic. So here it will try to use a threat intelligence from where he getting all this information. He use that as a brain. And according to that, not only based on the traffic rule he will block, but also understand the pattern or context of the traffic and try to block. Okay, like numerous login is coming, it is a suspicious activity, so they will stop it before it happens. Okay, so that is why it helps the security professional understand the decision-making process of the threat actor. That is why threat intelligence is very important in the organization. Let's move to the next interview question. So next question is, who get most benefit from a threat intelligence? Okay, so we have a 4 major department who get most benefit from the threat intelligence. The most important team or department get benefit from the threat intelligence is a SOC, because they prioritize the incident based on a risk and impact to the organization. Okay, then we have a senior management because they understand the risk the organization faces and what the options are address their impact. Third, IT analysts they can use, because by this way they can able to optimize the prevention and detection capability and strengthen the defenses also. And last but not the least, the vulnerability management experts who can basically prioritize the most important vulnerability. Okay, let's move to the next interview question. Okay, so next interview question is, can you explain me about pyramid pain? Pyramid pain is very frequent question which is asked in a SOC interviews and all that. So I thought I will make one interview question on pyramid pain. So what is pyramid pain? So pyramid pain is a visual representation of a 6 different sort of attack indications grouped in an escalating order of a threat actor and security analysts work. Pyramid represent the different type of attack indicators you might use to detect an adversary activity and broken by how much pain it will be cause attacker when you are able to deny those indicator to them. So what happened here is each level, when we're talking about level 1, level 2, level 3, level 4, level 5, level 6, okay, each level of pyramid illustrate the different type of IOCs. IOCs basically stand for indicator of compromise, and you might employ it to detect an attacker activities. So these IOCs are characterized by the amount of pain or difficulty they will cause the adversary when you deny those IOC to them. Okay, so the pyramid of pain provide the security team comprehensive insight into the area they can investigate the IOCs and leverage the knowledge gained to develop the robust defensive capability. So example, like we have a solution here. Okay, in the solution, we basically block all the hash of virus, which is called signatures. And we also block the IPs, which is basically very suspicious. So attacker, it is easy for attacker to modify the hash of his existing virus. It is easy for the attacker to use any random IP, and by which they can able to bypass the solution. So in that case, the solution will not able to detect the new patterns. Okay. But if you're using, okay, if you're using the, because in this case, what happened is the hash value in IP is very dynamic. It's a volatile, which can be changed. Okay. Which can be changed. So attacker can basically modify and able to bypass, but instead of working on their files or IP address, if we work on their pattern of attacks, okay, here, we're trying to block based on their tools, okay, based on their pattern of attack. If we able to use that parameter, then it is difficult for the attacker to bypass. Example, like he's sending a first 3 packet as a harmless packet, and then from a 4th packet onward, it's sending a virus. So here we understood this pattern. First 3 will be the harmless packet in first 4. So this is the entire attack pattern we have, which is called as a TTP. So instead of working on a single files or IP address, we're trying to block the entire pattern. So if you basically have a solution which monitoring the behavior, and based on the behavior try to block that, then it is very difficult for the hacker or attacker to bypass, and that basically lead to the frustration. That's why we called as a pyramid of pain. It won't be much pain for the hacker on the hash value changes. It must have no changes on the IP address level, domain name level, even on the network level. But if you modify something or you detect based on the tools they're using or TTP or the patterns, okay, then it will be a painful for them. So that is called as a pyramid of pain. Okay, pyramid of pain. So where tools and techniques are very difficult to change, because we have only, suppose 100 frameworks are available in the market. Maximum he will use that frameworks only to perform the attack, and we basically created a signatures. We maintain the database of those framework patterns. So anything he will use as a framework to perform an attack, we can able to block it. Okay, so that is why threat intelligence primarily focus on the tools and TTP of their patterns. Okay, let's move to the next interview question. So it is always a question that, okay, how to integrate the threat intelligence. Okay, because if we take an example, we have a firewall. In firewall, we create a rule. Source is any, destination is a web server, source port is any, destination port is 80. Okay, so firewall will basically work on this rule. So now what happen if any traffic, so there is an attacker and this is the web server. So if attacker trying to establish the connection on the web server IP, and it is also established on the port number 80, for a firewall it is basically the common traffic, but here what happened, he's sending a multiple traffics. Okay, and by this way attacker can able to perform the DOS attacks. Okay, maximum what firewall can do, we can able to block the IPs, but can be able to understand these patterns. That is why he does not have a brain, he does not have a knowledge. That is why he take these feeds from some external source, and this external source is a threat intelligence, where he can tell firewall, okay, I will giving you further solution how to combat such kind of a patterns, instead of just working on the standard rules. Okay, it is same like you read everything from the book and based on that you went for the exam, but there will be some topic which is out of the book. So you need some kind of intelligence here to understand this question pattern, according to that answer that. So that is how the threat intelligence as a platform integrate with the things. So we have a threat research, okay, where we basically collecting the information from multiple websites who maintaining the threat patterns. We also have open source solutions, and that is something integrate with the threat platform, CrowdStrike and all that. Okay, nowadays we also have open source. Then threat platform is integrated with the SIEM and firewall. And according to that, they will try to block the things. So open source and threat feeds are basically collect information. Threat intelligence is basically manage those feeds, and it is integrated with the solutions by which we can able to proactively protect the organization from all kind of an attacks. Okay, let's move to the next question. So what is IOC? Frequent question asked in a SOC analyst or threat intelligence interview. So your response will be IOC act as a flag. Okay, IOC is act as a flags. Flag mean notification, okay? Notify flags that cybersecurity professional use to detect unusual activity that is a evidence or can lead to the future attacks. So security researchers use IOC to better analyze the particular malware techniques and behavior. So here are some indicators of compromised information security professional system administrator to watch out for. Example like unusual traffic going in and out of the network, that is a IOC. Unknown files, application processes in the system, that is a IOC. Suspicious activity in the administrator or privilege account we have. Okay, irrespective activity such as traffic in a countries and organization does not do business with it. Okay, unsuccessful login attempt. So these are the indicators of compromise we have. So we have maintained these profiles. Similar pattern happen, we'll block it. We notify the firewall based on this pattern, we'll block it. So this is basically called as an indicator of compromise. Okay. So indicator of compromise is act as a flag. Okay, which cybersecurity professionals use to detect the unusual activities and all that. Okay. Next question. So what is IOA? Indicator of attack. See, just like an antivirus, IOC based detection approach cannot detect the increasing threats from the malware free intrusion and zero-day exploit. So as a result, the next generation security solution like moving to the IOA based approach, like we have a CrowdStrike in that case. So that's why the IOA is also asked in the interviews. So indicator of attack, what is that? So it is focused on detecting the intent of what an attacker is trying to accomplish, regardless of the malware or exploit used in attack. See, sending a malware, sending an exploit is an indicator of compromise. But now in an advanced stage itself, we're trying to predict the pattern, because now we have a signature of indicator of compromise, right? So we can use that in a further advanced level and we can block it. So indicator of compromise serve for detection of security event. You can see the thin line difference between the IOA and IOC is that IOC serve for detection of security events, and compromises, whereas the indicator of attack serve for detection of intent of the attacker. So here the thin line difference is IOA work on the intent of attacker and IOC work on the detection of security events. Okay, so indicator of attack is provide an example of how the criminal would plan and undertake to rob a bank in the physical world. Okay, so so example like you have seen a lot of movies where they're collecting all the data. Okay, which is called a threat data, and then they apply the intel so they can able to prevent that incident to be happen. Understood? Like, you know, some terrorist people or some people are basically going to this place. Okay, so we know if they're going this place, they might try to attack there. So this is called as an indicator of attack. Would plan. Not happen, would plan. But yes, for the indicator of attack, which is like a preventative parameter, we need an indicator of compromised database. Okay, so in order to successfully contain and seize the attack, it is essential to know what the attacker is trying to accomplish. That is why the indicator of attack are important. So indicator of compromise helps the IT professionals and security professionals to detect an intrusion. But in order to stop that intrusion, your security need to know what the attacker is planning. So knowing the next step and intention of the attacker give the security team the upper hand. And that is why data gathered by indicator of compromise should be backed by the indicator of attack. Okay, so that is why IOA come into the picture. Let's move to the next interview question. Very frequent question, and I have seen lot of time people get confused with this question. What is the difference between data versus information versus intelligence? See, data is made up of distinct facts. Okay, so your response will be data is made up of distinct facts and statistics that are acquired as a foundation of subsequent research. Okay, example, your IP address, URL, hashes. Okay, but data does not tell us much without analysis. It is like a block data. Okay, IP address is a data, URL is a data, hashes is the data of the virus. Then second thing is called as a information. Group of data form the information. So information is a collection of data piece which is used to answer the certain query. Like example, how many time has my organization been mentioned on social media this month? So number of activity or data we have used that, and based on that we able to answer is how many time organization has been mentioned on social media this time. Okay, so, or how many time this IP address basically attack. So information is a collection of a data piece. So data form into information, and that information is basically used for intelligence. So intelligence examine the data information, discover the pattern and stories they may use to make the decisions. Because intelligence is a product of cycle of identifying the questions and goals and collecting a relevant data, processing, analyzing the data, and producing the actionable parameter. Example, like normally in the defense and all that, they have collected data that this person used to go there. Okay, they form the information, this person go there because he has some work there. So here we use the intelligence, and we understood might be we have seen in last 6 months he regularly going to that place, but he might be doing an attack there. Okay, so this is called as an intelligence. So data information, whatever was available, we use that and we correlate that. Understood, team? So that is the thin line difference: data, information, intelligence. IP address is the data. How the IP address basically attack is the information. Okay, how frequently the IP address is coming, that is the information. And based on that, we predicting the pattern that this can be a DOS attack, that is called as an intelligence. So according to that, we can able to block it. Okay, let's move to the next interview question. So what is threat intelligence feed? Same like when I'm upgrading my knowledge. Okay, I need to obtain this knowledge from multiple source. That is called as a feed. So same like threat intelligence platform need a feeds from where they have to update the threat patterns. If I'm able to block multiple IP address, virus and all that, I have collected this particular feeds. Same like when antivirus basically detecting a new virus, they have a feed from there, they have updated the signatures. So same like threat intelligence feed we have. So threat intelligence feed are the real-time stream of data that provide the information on the potential cyber threats and risk. Each threat intelligence feed may collect data from several sources. Example, open source data, customer telemetry, and crawling the internet. So from there, we will basically get the threat feeds. Let me show you the same diagram. This is the one. So this threat research or open source are the threat feeds only, which threat platform collect the data, and according to that, they can able to block or monitor the threats. Okay. So that is called the threat intelligence feed. But might be interview will ask, what is the important aspect in the threat intelligence feed? So the most important part in the threat intelligence feed is the integrity of the feed. Make sure you're collecting a feed from the right website or right server. Next question, what are the different type of threat intelligence we have? Okay, so we basically do the threat intelligence based on 3 types: strategic, operational, or tactical. Strategic basically focus on the ownership, senior management. They identify who and why they did. So we doing a strategic threat intelligence because it producing the strong strategic parameters. Because when we collecting a feed, we need to organize this feed, that this feed is a part of which category. So by this way, we can able to prioritize and manage the things. Okay, so strategic is basically producing start with asking about specific questions like, strong understanding of a socio-political business concept, how this basically threat create a geographical tension. This threat is basically creating a business troubles, how this threat basically used for the competitive advantage. Okay, so you can ask here which area of business may be impacted by this threat. Okay, so good strategic intelligence should provide insight into the risk associated with the certain other actions also. Okay, example like geopolitical issues, okay, monetary issues, okay, new initiative of the products. So that kind of information we get in a strategic threat intelligence. Second is basically called as a operational threat intelligence, which is focused on the understanding of adversarial capability. okay, which is used to conduct more targeted, and the interested party who work on the operational are threat hunters, SOC analysts, and vulnerability management. Third is basically called as the tactical, which is focused on performing a malware analysis. Okay, so they basically collecting a feeds and they checking the feeds, which is more mapped with the malware parameters and all that. Okay, and they basically ingesting atomic, static, and behavioral threat indicators into the defensive cybersecurity system. And major stakeholders for the tactical threat intelligence are SOC analysts, SIEM, and endpoint. And it is used daily by the SOC for detection. Like, whatever the new signature is coming, signature pattern is coming, that is part of a tactical. Okay, the tactical which impact any kind of an operations, we have a operations parameter, and anything which basically impact the business, that will be organized into the strategic threat intelligence. So it is very important for you to organize this particular data so that you can able to build the strong, robust solution. Okay, let's move to the next interview question. While reviewing threat feeds, what are the factors we need to verify? Here, the interviewer might test your knowledge, might test your experience. Okay, just collecting a data, just collecting a threat feeds does not make the solution robust. So whenever you're collecting a threat feeds, 3 areas you need to focus on. One is called data source. What is the data source we have from which you're collecting a data? Transparency of their information, how they basically collect and process, and how long data is relevant. Might be you are updating a irrelevant data or not updated data, so it make the threat intelligence solution ineffective. So it is very important whenever you're collecting a threat feeds and all that, data source, transparency, and how long data is relevant, that matters. Next is basically called as what are the different phases of the threat intelligence we have? That is a normal question which is asked by most of the interviewer and all that. So we have a first step is direction. The direction phase of the life cycle is when you set the goal for threat intelligence program. Example here, we talk about understanding of information assets and business process. You need to protect the potential impact of losing those assets and the type of threat intelligence that security organization required to protect the assets, and priorities about what to protect. Okay, because it's not something you just implement the threat intelligence in the organization. No, we have a parameter by which we need to organize the threat intelligence. That is what the first phase of the threat intelligence is, direction. The second is basically called as a collection. So collection is a process of gathering information to address the most important intelligence requirement. Okay, so information gathering can be occur organically through the variety of means. Example like pulling the metadata and logs from the internal network and security devices. We can subscribe to threats, data feeds from an industry organization and cybersecurity vendors. We can hold conversation and targeted interviews with the knowledgeable. Okay, sometimes we can basically make it as a automate process where the analysis can spend little time as possible collecting a data. Okay, and later they can evaluate. Third step is once you collect the data, you need to process the information. That is the next important thing we have. So processing is the transformation of the collected information into a format which is usable by the organization. So almost all raw data collected need to be processed in some manner, whether by human or machine. Nowadays we are using a tool by which we can do that. Most of the time it take in processing. Then we focus on the analysis. So in the analysis is a human process that turn the process information into the intelligence that can inform the decision. The most important phase of a threat intelligence is analysis. So depending upon the circumstances, this decision might involve whether to investigate a potential threat, what action to take immediately to block an attack, how strengthen the security control, how strengthen the security control parameters, how much investment is in additional security resources justified. So that is basically done in analysis. Okay, so in analysis mean whatever the data we have collected, we will do the intel. Then we have a dissemination. Next is called as a dissemination. Dissemination involves getting the finished intelligence output to the place which is needed to go. So what threat intelligence do they need? How can external information support their activity? How should the intelligence present to make it easily understandable? That is basically part of the dissemination. And last is basically called as a feedback. Feedback is another important thing we have, which is basically used to improve the functions and everything. That is basically called as a feedback. Okay, in feedback, as you have no doubt gathered, we believe that criticality important to understand your overall intelligence priority and requirement of security team that will be consuming the threat intelligence we have. So there is need to guide all the phase of intelligence life cycle and tell you what type of data to collect, how to process, enrich the data, how to analyze the information, to whom each type of intelligence must be disseminated. So all those things will be basically done in the feedback phase. Okay, how quickly we need to disseminate, how fast to respond to the incidents, everything come in the feedback stage. So these are the phases we have in the threat intelligence. Next is basically the question they mostly ask is, what is MITRE attack framework? Actually, it is not attack, it is stand for adversarial tactics, technique and common knowledge. That is called attack framework we say, but how to pronounce is MITRE. Okay, and it is not attack, we have a full form called adversarial tactics, techniques and common knowledge. So they mostly ask this question also. So what does this framework stand for? This is the comprehensive matrix of a tactics and technique designed for threat hunters, defenders and red team to classify the attacks, identify attack attributions and objective, and assess an organization risk. An organization uses this framework to identify security gaps and prioritize the mitigation based on the risk. So MITRE is basically focus, okay, on articulating how the detection occur rather than assigning a score to vendor capability. They also categorize each detection and capture, and detection are then organized according to the each techniques, and technique may have more than one detection if capability detect the technique in different way, and detection they observe are included in the result. So MITRE makes every effort to capture different detection, and vendor capability may be able to detect those procedure in which the MITRE did not capture the information. So ultimate goal of the MITRE framework is to basically designed to detect the patterns by which they can able to classify the attacks and identify those attributes and everything, and by which way they can able to assess the organization risk. Okay guys, this is all from my side for this session. If you find this video useful, do share in your network and do share feedback in a comment section, and let me know what is the next video you want me to make on the SOC Analyst, and do share me 2 samples of the threat intelligence solutions in the comment box. Okay, after understanding a threat hunting and threat intel topic, we need to understand how to investigate each and every packet, because Wireshark is a tool that you're using to capture the packets, right? And if you're working on the L1 and L2, your 90% time spent on the packet analysis. So you should know how to investigate packets. So we are taking one example is like, this is the one packet structure we have, which is a sample of the Wireshark packet we have captured. So first part is called as a frame 15. Okay, it's mentioned 1454 bytes on wire, 1454 bytes capture. So what is the meaning? It indicate the total size of frame captured on the network, including a header and payload. And 145 bytes, okay, capture 1162 byte. This is the number of byte Wireshark capture for analysis, which matching the full frame size. Now the second part is called Ethernet 2, because if you go by the OSI concept, it starts from the physical layer, then go to data link layer, right? So Ethernet is work on data link layer. So here you can see it mentioned VMware. This is the MAC address. Okay, this is the MAC address. So if you can see here 0.50, this is called as a source MAC address of the device that sent the packet. In this case, it is a form of virtual machine, and the destination is 0.0C, a physical address of the device that is a packet destination. This is also VMware virtual machine. The current IP version they're using IP version 4. So that is, they have clearly defined. And then they talk about here is a source port, destination port. So that's something they have, source port and destination port, that is already mentioned here. And along with that, they also talk about the header length, source port, destination port 80, web server they are establishing connection, because here you can see, just give me a second. So most of the cases we are investigating these particular ports. So we get the traffic understanding from where it is coming to where it is going. It also have another important information which is called as a stream index 0. Okay, stream index 0. It is just a high level information. And we're talking about next is called segment length. That is another important part we have. Because segment length define this, because transport layer divide the data into segment, right? So segment length is basically representing the segment state, the length of data carried out in TCP segment, which is excluding the header. Then we have a sequence number. Sequence number is the sequence number expected for the next packet from the sender. It accounts for 1400 bytes data in the packet, which is like 1 byte of the 6 system. And then we have an acknowledgement number. It indicates the sequence number the sender expect to receive next from the other side, and it acknowledges the receipt of all the bytes of the number. So this is something we talk about in the Wireshark packet analysis. Now we are moving to the next part to understand what kind of a platforms we have exactly. So here in the next section, we're going to discuss about top 5 platforms that you can use, or top 5 softwares that you can use alternate to Wireshark for packet analysis. Now we need to understand what are the alternate tool of Wireshark that we can use for packet analysis, because when you go for interviews and all that, they might ask on which particular tool you worked on. So we have a TCP dump. It's a command line packet analyzer. So in a Kali Linux and all that, you can see this tool, it is there. So that is something we have. Second, we called as a T-Shark. T-Shark is there. So T-Shark is another tool we are using, which is used for command line version of Wireshark. Then we have one thing you need to understand, TCP dump, it's a utility that you install. Okay, it's a utility that you install that use for the functions. And when you're talking about, it is lightweight, fast. It's best for quick capture, because Wireshark, it takes times to load and all that. That's the reason. Then we have a ngrap. Ngrap is basically network packet analyzer that we are using. And the best thing about ngrap is that you can able to focus on the patterns, and it can match the traffic based on regex. Regex is a sequence, and if you want to analyze the detailed payload traffics and all that, we can use ngrap. Then we have a next called as a this one. Just give me a second. We are using the concept called as a Zeek, which is formerly Bro, a powerful network monitoring for analysis framework. It generates also the detailed logs or script table for the custom detection rules. And then finally we have a Scapy. Scapy is something which is used in a multiple sections. Scapy we are using for the pen testing also, because it is like a utility you can interact with the packet to manipulate, and you can also allow the custom packet creation, and it is best for developers and advanced user building custom network tools. So that's something we are using. So pretty much I can say it is, so we don't have only Wireshark, we have other tools also which can be used according to the need. Now the threat hunters, to discover the initial information about the targets, they use different methods. So first is called as a open source intelligence. Whatever the public information there, from there they basically collect the information what is happening. So that is basically called as a OSINT. So gather information from publicly available. So they use a Google, Bing, DuckDuckGo, which is a dark website, social media, Twitter, threat intel platform like VirusTotal, Threat Crowd. I highly recommend visit Alien Vault OTX, one of the live website which capture the live feeds about the threats and everything. Then Security Blog, Curbs on Security, and Bleeping Computer for cybersecurity news. So these are the websites by which you can able to gather the public information, what kind of things happening in the market. Then for data analysis, like example, analyzing logs, network traffic, malware samples, use a tool like log analysis tool like grep, AWK, SED. For network, you can use Wireshark and TCP dump. Wireshark is a graphical, TCP is a utility, CMD based. Then for the malware analysis, live website is VirusTotal or any.run. If you want to discover any vulnerabilities and research about the vulnerabilities, you can use the website like CV, NVD, Exploit database. And if you want to do threat modeling, which is advanced threat analysis, then it is actually we do in that case when we, before building an application, we design the entire application, we identifying possible threats. So we do threat modeling, and one of the framework we are using in a threat modeling is Stride. So it's like, you're planning your house. You want to build a house, you decided to build a house. So you need to find a space. So before you find a land, you will basically assume, okay, if I build a office, if I build a house in this location, what happen if earthquake occur? What happen if someone attack? What happen if flood occur? So this is called threat modeling. We have not built the house, we're just doing analysis to make sure in reality it should not be happen. So threat modeling is something we perform in the application design. And along with that, we also we join to conferences and all that. From there also we get some information about the findings, like going to DEF CON, or nullcon. So we have multiple conferences by which we can able to get the more information. So it is always highly recommend that use conferences, because conferences basically give you the better informations about the targets, okay, or about the market trend. Okay, so now next is called as the investigating of the logs. See, when you're working as a SOC analyst, especially in the L1 and L2 position, you're going to investigate some basic logs on, so you're going to investigate some logs on regular basis. So one of the logs are called authentication logs. Okay, authentication logs. What is the meaning? It means if any hacker trying to attack the server, he tried to do brute force. He tried to guess username passwords. Okay, because if any password match, he can gain access to the system. So we have to see some event IDs like 4625, 4624, 4625. I can see some 50,000 4625. It means someone has already multiple login attempts. He got failed. It means in a 1 hour, if 50,000 attempts are there, it means someone doing brute force attacks. So 4625 use a failed login, and if you discover 4624, it means successful login. So sometime when you go for interview also, they ask what is the meaning of 4625, what is the impact of 4624. Second is called as a privilege escalation logs, a standard user in account added to the admin group. And for that, we have a log which is generated called 4728. If 4728 has been generated, it means someone has did the privilege escalation. Then we also look for the email security logs, you know, what kind of a SMTP traffic is going outside, what kind of a POP3 is coming. So that basically helpful for checking the account activities and all that. So these are basically different logs, more from authentication and privilege management. Now the next is called as a system and endpoint activities. So for that, we check the endpoint logs, endpoint like system logs. What we checking is we check the execution of unknown unsigned applications. So we detect the suspicious process like PowerShell.exe and CM.exes. So there's a possibility malware execution has been done. Then we have a FIM, file integrity monitoring. It is just creating a baseline of the system, and any kind of a deviation in the baseline, FIM basically track that. OSEC and all that are used for the FIM. So major changes if they're discovered in the host file, it's a concern. Next is called as a proxy logs. Proxy logs, so user visiting a malicious websites which is flagged by the threat intel feeds. So phishing or drive by the download attacks we have. So we access to high risk categories like known malware sites and all that. So because proxy logs give me visibility about what kind of sites has been open. And the last is called as a SIEM alerts. SIEM alerts is all about correlating events, showcasing multiple alerts, and alert trigger from multiple source. So these are things we have. Now another important thing that we will look for is that we talk about is the IOCs. Okay, it's a very interesting topic, IOC and IOA. See, vulnerability you find in your system. Vulnerability is something you find in your system, but you cannot predict the threats. Okay, so next is called as a IOC versus IOA, indicator of compromise and indicator of attacks. Today, a lot of companies subscribing to the IOCs and IOCs, they want to learn what are the type of threats we have, what is happening in the industry. Let's say example, antivirus. Antivirus maintain the database of virus signatures. Now just imagine if they don't update the virus signatures, can they able to detect the new attacks? No. So now the things are not limited to only virus signatures. We want to understand other attack signatures. Is it clear? So we collecting those evidences in advanced level so that I can able to protect the organization from all kind of an attacks. And this is where the feeds come, feed, which is called as a IOC and IOA. IOC stand for indicator of compromise and IOA stand for indicator of attack. So IOCs, if you go by the definition, it means that, okay, the artifacts or evidence that suggest a system has been breached or is under the attack. That is called as a IOC. IOA is like a during an attack. Okay, IOA is basically during an attack. So both are critical, no doubt in that. So if you take an example of the reference and all that, so IOC is basically post attack after the breach has occurred. So let's say example, we have a firewall and we have a system A, we have a system B. So there's an attack we have discovered in the firewall 1.1.1.1. I can see a lot of traffic is coming from 1.1.1. So that is called IOA, indicator of attacks. But is it a confirm? We have find the logs in one of the system that is called the IP, which is able to access one of the files that become the IOC. Okay, relative is coming to my house Okay, that's a IOA. But he picked one person from a house, that is a IOC. So IOC is an indicator of compromise, is a reactive, focus on post-attack evidence for detection and investigation. And examples can be my hashes of malicious file, IP address, or the domain associated with the known threats, or suspicious registry changes or log entry. Okay, so another thing, IOA is like a during an attack, sign of a malicious behavior, real-time detections like brute force attempt, lateral movement, and help to detect and stop the attacks. So when you're working on these feats and all that, it's very important to improvise a solid defense. Now, but sometimes what happen, it's not necessary they are true. Okay, it is not necessary they are always a true. So we need to identify, some unknown threats and all that, and sometimes it having a lot of errors. So to overcome that, we need to understand the next part, which is called different type of errors. So we have a different type of errors in the security. One is called true positive. Second is called as a true negative. One is called as a false positive, and one is called false negative. Let me explain you. True positive mean there is a virus, and antivirus detect that as a virus. True incident and positively detected by the tool. True negative basically mean there is no virus, that's why the antivirus doesn't detect any virus. False positive mean there is no antivirus, but antivirus detect as a virus. They're saying virus, but there is no virus. And false negative mean there is a virus, but tool doesn't identify. So for me as a security analyst, the biggest concern is increase of false negative. So here you can see true positive, correctly identify phishing emails. A phishing email is flagged and quarantined by the email security system. And by identifying this, we can able to prevent the potential compromise by stopping a real attack. True negative is correctly identifying a legitimate email as a safe, a regular work related email, and ensure uninterrupted communication reduce. False positive mean incorrectly flag a legitimate email. Tool discover it's a virus, but it is not a virus. So it is an important email from a client is flagged in quarantine phishing due to the misconfigure rule. So it delay the legitimate communication, causing the inconvenience, like just like a bomb warning and all that. Then we have a false negative. So fake calls we have for the bomb threats, right? That's the same thing. So false negative is failing to identify the phishing email as a malicious, and a phishing email disguised as an invoice from a trusted vendor bypass the email filter and allow the user to click on the malicious link. So it's very important. We need to reduce a false negative and increase a true positive. And that is only possible by doing a threat analysis or by learning the traffics, improving a defense and all that. So as a SOC analyst, you should know these kind of errors. So proactively you can work on those functions. So question is how companies doing the threat hunting or threat analysis and all that. So some let's take example. One of the user receive an email about the phishing email. Okay, so what he did, he copied the URL and search in a virus total, where he reviewed the reputation and assets IP. Then check the URL in a recorded future. There's a tool we have. Recorded future is a deep intelligence for IOC's threat and campaign, and checking is it a part of known phishing campaign or escalate the incident. And then we use a MISP. MISP is one of the popular open source tool we have. Okay, so that you can use, which is stand for malware information sharing platform. So with the help of MISP, we can collaborate and share the IOC for the broader protection. So that's something we are using. This is how we're doing a threat hunting. Now in the entire investigation, the most important part is managing the logs. Logs are track the accountability. Logs are tracking all the actions. So it's very important. We need to organize and manage the logs. So logs are the detailed records of event generated by the systems, and they serve as a digital footprints. So from a SOC analyst perspective, you need to focus on 4 types of logs. One is called as a system logs, which record the OS level event, like when the user login process starts and all that. Second, we have an application log. Whenever any application failure, database failures, database record activity captured in the application logs. Whenever there is a traffic flow, firewall activity, that is captured under the network logs. But security logs is very, very important. Now let's say example, user tried to log in with wrong password. So he attempted thrice. That captured in the security log. If we log in successfully, that also captured in the security logs. There is a folder we have, and that folder accessed by unauthorized user. That attempt also captured in the security logs. So as a SOC analyst, it's very important to investigate the security logs because that gives them a great visibility. Now here what happened is when you're doing a log analysis and all that, now what is the benefit we get actually? That's a question. Okay, it's a very good question because By doing importance of logs is it can be used for troubleshooting system issues. It can detect analyzing a security incident. More important, it can be used for the IOC, indicator of compromise, and we can able to build our defense solid. And sometimes we have to retain logs for the PCI DSS, HIPAA and GDPR compliance requirement. That is why in the organization, we have a concept called log management system. Now, why we need a log management system? Let me explain you. Now, let's say example, we have a firewall here. Okay. So we connected with a switch. We have a system A, we have a system B, we have a system C. Okay, so now what happened? There is a IP 1.1.1.1 was able to bypass the firewall. It went to this system, then it went to this system, then it went to this system. So manually we have to go to each and every system to collect and manage a log, which is a big task for us. And firewall kind of a device, they don't have a capacity to store and hold a large amount of logs. So what we do is we set up the log server. Log server. So log server is also called as syslogs. Name of the solution is syslog. So now when the packet passes through the firewall logs go to the syslog. If any activity happen, the system A, B, and C, that also logs go to the syslog. So now we have one centralized log, which maintain the data and all that. So from one centralized platform, I can able to manage everything. So, but one most important thing you need to remember, all should be configured with NTP, network time protocol, because NTP is a protocol which is used to sync up the times, because based on a time only you can recreate the same. So log collection. The benefit of log management is to enhance the security by detection threats early. We can speed up the troubleshootings and incident response, and more important, helping to meet the compliance requirement. So the key component of log management first is log collection, gather log from various sources like server, application. Then we have a dedicated store where we keep the logs. Then we parsing means converting log into common format. Then we analyze the log, because Windows generate in a different format. Linux generate the log in different format. So we need to parse that log. Then we analyze. Then we continuously observe the logs for critical events, and then we archive. When logs not in use, we can move the archive for the storage. So because we have to follow retention policy. But the problem is that when you're keeping the logs, when you're collecting a log, this log parsing or correlation log will take time. I'm looking for an automation which parses these logs. And this is where we introduce the concept of SIEM, Security Information Event Management. So SIEM is basically used to functionality. One is called data collection plus data analytics. How? Let's take an example. We have a firewall here, and here we are connecting with the switch. So we have a system A, we have a system B, we have a system C, and here we have a SIEM. So now what happened? There's an IP called 1.1.1. able to bypass the firewall. Firewall maintain the log, send to SIEM. And then that IP target A, B, C. A, B, C. All this information go to SIEM. So now we have one centralized server where we can keep logs. So it's a technology that provides real-time analysis, monitoring, management of security events and log generated by the device and all that. The full form itself says security information event management. Information that we collect which form the event which used to manage. So we have a multiple reason for using SIEM. Okay. So like example, it can provide you centralized log management. We can collect and store log from various sources like server. We can identify potential threats by exposing log data for unusual patterns. Then the logs can be used for incident response, and we also retaining a log for legal regulatory requirements. So what is the flow? This is the flow you need to understand. The first step is called data collection. Okay, let me explain you so you get a better visibility. As I said, this is my firewall. Okay, this is my firewall. We connect with the switch, and here we have a SIM. So we able to bypass the firewall. We went to system A, B, C. All this information go to SIEM. The first step is data collection. So SIEM collect logs and security event from multiple resources like firewall, IDS, application server, endpoint devices. And these logs are collected via agent or directly from the log source. In layman term, firewall send logs of a block IP to SIEM system. Then second step, we do the log parsing. Log parsing mean because system A is Windows, system B is Linux. So what we're doing is whatever the different set of logs we have, so all logs is go to SIEM. So we do the log parsing. So raw logs are parsed and converted into the consistent structure format for easier analysis. So different log format, which is like JSON, okay, or plain text, are normalized into the uniform structure. It seems like, we're converting varied log, window event log, Linux log into the standardized format. Then we do the log correlation. Log correlation is we correlate the log from different sources to identify the pattern relationship that indicate the potential threats. And it uses rules and algorithm to link all the unrelated events, like multiple failed login attempts followed by the successful one might indicate the brute force attack. So that's something we do. Then we have a real-time alerts. So real-time alerts is based on a predefined rule or behavior analysis. SIEM generate the alert for suspicious activity. Like alert is 10 failed login attempt detected from particular IP within a 1 minute. And then we have a dashboard. Here we have a dashboard. So SIEM provide a visual dashboard and generate the report to help the SOC team to monitor the environment. And this report showing the number of block IP by the firewall. And then we can use our investigation. So SOC analysis use SIEM to investigate incident by drilling down into logs, tracking into the attack chains, and more important, we also look for identifying the cause. So example like we have a tracing a malware infections back to the phishing email. That is possible. So the same thing we have discussed here, you can see. So data collection, log parsing, real-time alerts, okay, dashboard reporting, and we also using for the activities like incident investigation. So we have some popular tools. Splunk is there, which is a well popular customizable. Then IBM QRadar is there. Open source is Elasticsearch, and Micro Sentinel is a paid one, cloud native SIEM, and ArcSight is there. Vazeu is there. So these are basically we use. See, logs, as I said, investigate. So log investigation is a key step, okay, in identifying, understanding, and mitigating a security incident. So the steps that we take to investigating logs, define the incidents. We start by identifying what you are investigating. Okay. Then identify the relevant logs, determine which logs are relevant and all that. Then we use SIEM tool to search for key terms like timestamp or IOCs, like searching for the repeated failed login attempts. Then we analyze the pattern. Okay, look for the anomalies such as unusual login locations and all that. And then we document the findings. We record the keys insights, including a timeline and everything, and then take an action. So that something is there. So SIEM tool is using for Splunk, QRadar, Vazeo, and log analysis tool we are achieving Kibana, Kerilog, and packet capture tools we are using a Wireshark TCP dumps. So now I'm going to discuss about the forensic investigations, which is basically I've taken the old video as a reference point, which give the better visibility. So instead of starting with what is forensics or digital forensics, I thought let me give you a first brief idea about cyber crime. Okay, so when we say word cyber and when we say the word crime, what is that? When you're talking about cyber is a concept of, cyber is relating to or characteristics of the culture of computers, information technology, and virtual reality. So cyber is related to the network, cyber is related to the systems. And crime is basically called as an action or omission which constitutes an offense. So where computer is involved in committing a crime or computer was used to committing a crime, that is basically called as a cyber crime. So we have a different kind of an expertise who involved in the cyber crime investigation. In layman, I can say, suppose there is a candidate name is Rita. One day she received a threatening email that, okay, I will kill you. Okay, or I will do something bad. So this kind of an email Rita received. Now Rita, what she did, she report that issue to the police. Now what police did, police basically contact the cyber team. And cyber team basically investigated the email, from where the email comes, what is the IP address of the email, what is the source, what is the details. So here what happened, the computer and their associate details artifacts has been used to identify who sent the threatening email to Rita. See here, the Rita has not received any kind of physical threat. Okay, it means the person is not standing outside the gate and threatening Rita. She received an email, which is also an electronic email. It is not a postal email. It is an electronic email which she received on an email or in a mailbox. So based on that data which is received by Rita, we have investigated where we identify what can be the sender, who is the sender, from which IP address this email come. Then we contact that server. Then from the server, we identify the mail has been sent from this particular IP. Then we went to that system. But problem is that system is used by multiple people. Then we check the camera. From the camera, we identify on that particular time who was sitting on the computer. Then we took a picture. And this is how we have investigated and identify who sent an email to Rita. Okay, so this is basically where the computer has been used to identify and track, because in this particular condition, computer was used as a tool to commit a crime. Okay, so that is called as a cyber crime. So when we're talking about cyber crime, it has a two perspective. So in cyber crime, the computers are basically involved to commit the crime. So question is how? One condition is computer is a target. Now example, we have a company which is running a very critical servers. Every day from this particular server, we are generating $1,000 business. Now one of our enemies or one of our competitors, they hire hackers and they basically try to shut down the servers, because they know very well if the server is basically down, it will impact the business. It is actually a crime, because what you're doing here is you are manipulating my servers, you're shutting down my servers, and which impact my business, and it is a loss of money for me. So here in a cyber crime, computer was used as a target. Okay, so in this case, they have targeted my server. Now here what happened, hacker also using his computer, in which he using a tool to perform the attack. So here the computer was used as a mechanism. So that is why in the cyber crime, we say that computer as a target, where I'm targeting a computer to hack the computer, and computer as a use. It means I'm using my laptop to commit a crime. So that is basically usage of cyber crime. Now in the cyber crime, if you go by the process, we have a multiple type of cyber crime, but here I have categorized the cyber crime into three categories. One is called as a cyber trespass. Second is basically called as a cyber deception, and third is basically called as a cyber violence. So first is basically called as a cyber trespass. So cyber trespass is basically referred to act of crossing the boundaries of ownership in online environment or connect with the unauthorized network. One example I can give you. So this is basically the Wi-Fi shop we have. Coffee shop, sorry. This is the coffee shop we have. Okay, I want to send a threatening email to Rita. Definitely if I use my house IP or if I use my house internet to send an email, they can able to track the mail came from prep. Now what happened, I went to coffee shop. Okay, I took one coffee, and they have Wi-Fi, but they're not sharing me the username and password. So I basically try to hack the Wi-Fi network, use the Wi-Fi network to send an email. So here I have used some other organization Wi-Fi, and through that I was trying to hack. So that is called as a cyber trespass. Second is called as a cyber deception. Cyber deception is basically like a phishing, where I'm sending a phishing email to, collect more and more information about the user. Like I sent you a phishing email, hey, you won the lottery, and to claim the lottery, you need to share your account details and other information. So here what happened, I have collected your information. So that is called as a cyber deception. And third is called as a cyber violence. Now I want to promote some social message. I want to promote some economic message. Okay, I want to promote some religious message. So I know Facebook server, Yahoo server, Google server is basically receive huge traffic. So we hack into those servers and we promote our social economic message. That is why sometimes you notice whenever you try to browse some website, it will redirect to some kind of a social and economic message websites. Okay, so that is basically called as a cyber violence, where I have my intention to disrupt the society. I have an intention to compromise the society. Okay, like example, we have a SCADA plant, we have a ICS plant. ICS stands for Industrial Control System. Okay, in Middle East, you can see, in the US, you can see lot of machines are controlled by the computers. Okay, so here what we did is we hack into the computer networks. Okay, and by which we had disrupt their power plants, we disrupt their water plant. Okay, live example is I hack into one water plant okay, remotely, and I increase the chlorine level of the water, which basically create more poison, which is not become very injurious for the person to drink. So this is how I basically perform the cyber violence. So summary is that using someone's Wi-Fi, use the Wi-Fi and access the things, that is called cyber trespass. Cyber deception is basically a phishing campaign, and cyber violence is basically where we are disrupting the networks, disrupting the things, and it is lead to also someone human life. That's like DOS attack and DDoS attack. That is part of the cyber violence. So now we're going to discuss about the introduction of the digital forensic, because we hire forensic investigators, we hire specialized officers who investigate, who perform this attack, how this attack happened, and who can be the target, what is the motive for them. So we have a dedicated team. Okay, in every country there is a dedicated team who involved in investigating such kind of a computer's crime, and that is called as a forensic investigator. And that is my agenda in this particular session. So let's start with the introduction of digital forensics. Okay, so what is digital forensic? So when you're talking about digital and forensic, it means doing an investigation for a digital stuff. So even you go by the definition, digital forensic is a part of forensic science that focus on identifying, acquiring, processing, analyzing, and reporting on data stored electronically. As I said, when Rita, she received an email. So first we have contact Rita and ask for the email, and we have identified the email content, we identify the email header, and from there we got a high level information from which domain the email comes, what is the IP address of server, and what is the primary location. Then we basically contacted that particular companies and contacted and checked those servers from where the mail has been sent. And from there we got a IP, that was a sender IP was this particular host IP. So here what happened, we are identifying the electronic information, because if you're talking about general forensic investigation, if someone has killed someone, so we physically go there and collect the evidence, physical evidence. But here everything is digital, you cannot touch that. It is a logical. Email you cannot touch, email is a digital data. Okay, so you have to use specialized tools to extract the email, understand the data. You need to contact the server from where we have sent an email, we have to contact that. So here we are basically fighting with the systems, we are not fighting with the person. Here we are not identifying on a first stage which person did that. We are identifying which system was basically used to perform this crime, because once we identify the system, we will get the system owner details or the system user details. You're getting my point? So if the mail has been sent from cyber cafe at 10:15, but that system was used by multiple people, right? So from there we will involve the camera. In the camera it will capture the digital data that at 10:15 which person was sitting on that particular system. Then we will basically contact the person and find out, okay, why you send this email. So here everything is digital. That is why they say identifying the digital data, okay, acquiring the digital data, processing the data for the correlation, then analyzing the value, and then according to that we do the final report. But we have a different type of digital forensics. Like we have a computer forensics, like there was a computer was hacked, so we identify who hacked that. So there is an investigation involved in computer aspect. There was a mobile has been used for the threatening, the mobile has been used for sending a WhatsApp message, the mobile was involved in giving a threatening call. So we have investigated the mobiles and identified data from there. Then we have a network forensics, someone is basically doing multiple attacks on the networks. So we are dumping the firewall logs, we are identifying the IDS logs, intrusion detection systems. From there we get a visibility what kind of a traffic is coming in the network, from where, which is a source is involved. So that is called as a network forensics. And last but not the least, we have a hardware forensics. Example, like we purchase some hardware devices, like it can be my mobile as a hardware device, okay, router as a hardware device, a system as a hardware device. So sometime what happen, sometime it's possible that, okay, vendor basically embedded a malware in that. Sometime the user embedding some kind of a Trojan in the hardware. So we are trying to investigate, is this hardware is compromised? Okay, because there is a possibility if hardware is basically compromised, then it is a concern for us. Might be someone has given me one device with enabled with some mic and all that. So we need to investigate it is someone has tampered or something else. So we have a different type of digital forensics. Okay. So this is the introduction we have. So now we're going to understand about the forensic investigation process. So on a high level, different books talk about different forensic investigation process. So here I have categorized the forensic process in 4 stages. The first stage is collection, second is called as a examination, third is called as a analysis, and fourth is called as a reporting. Let me give an example. So suppose this is my internet. Okay. There is a firewall. And we have a switch. We have a system A. We have a system B. We have a system C. And we have a system D. Now there is a IP called 1.1.1.1. It is an attacker IP. This IP was able to bypass the firewall and it attacks system A, it attacks system B, it attacks system C, and it attacks system D. So we got this confirmation that there was a IP was able to penetrate into the firewall and able to hack into the internal network, and he was able to, or she was able to hack the IP, or the particular hacker was able to hack into the multiple system. So I want to investigate. So here the first step what I did, I collected the information from the firewall. I collected the information from a system A, B, C, D. So that is called as a data collection process. Now here what happened, we have collected all type of data. I'm not saying I'm collecting a specific type of data, but I have collected the all type of data. Now second step is called as a examination. Now examination is, as I said, we have collected all type of data, but I want to filter is 1.1.1.1. Okay, because from the firewall we collected 40 GB data, and from all the system overall we collected 40 GB data, but there is no need for 40 GB data to work on it. So I want to examine. So I will basically filtered only 1.1 data from this total 80 GB data. So I concluded around 2 GB of data, which is, or 1 GB of data related to the 1.1.1. So that is called as an examination. It means examination is a process of filtering out the information. Now once the information is filtered and we limit it to 1.1.1.logs, then we try to analyze how this event happened. Okay, so that is basically go to the analysis, and finally we basically report. So each and every step we're going to discuss in detail. Okay, so step 1 is collecting a data. All type of data we collect, we will not miss anything. Second step is basically called as an examination. I will try to correlate all the data related to 1.1.1. If the data is not related to the 1.1.1, I will basically keep aside. And then the filtered data, which is did in the examination stage, on that I will do the analysis to see how this entire incident happened. And finally, we basically called as a reporting. So this is basically the parameter we have. So we're going to discuss each and every step now in detail. One thing you need to remember in the forensic investigation, you need to work strongly on the documentation. So documentation should be start from the first phase itself. Okay, and make sure you should maintain the accuracy. So let's discuss each and every process in detail. See, when you're talking about first step, which is called as a data collection. So where we are identifying the data source and acquiring the data from them. But problem is that how to acquire the data. So when you're talking about data, we have a two type of data team. One is called as a volatile and one is called as a non-volatile. Okay, one is called as a volatile and one is called as a non-volatile. Sorry for my handwriting. Let me. Volatile and non-volatile. So whenever, like as I said, we have a system A, we have a system A, we have a system B, we have a system C, A, B, and C. And there was a hacker remotely, he was able to hack into the system. So always remember, whenever you're initiating a forensic investigation, never ever shut down the system. The reason is very simple, because if you shut down the system, you might lose the last access data. last access data which is reside in the memory. So one thing is that first disconnect the network. It means remove the network cable. And in the case of mobile forensics, put the phone in a airplane mode. Do not remove the SIM. Okay, don't shut down the phone. Remove the enable the airplane mode. Okay, some people what they do, they remove the SIM and then they enable the airplane mode. No, if you remove the SIM, you might lose the memory data. So better is keep the SIM on, but enable the airplane mode. Okay, and then do the investigation. Now when it comes to system here, like ABC was involved in the ransomware attack, or they were hacked remotely by the hacker, the first practice is remove the network cable after doing an impact analysis. Then the second important thing is obtain the volatile data. Volatile is basically mean very sensitive data, very it is not a static data, it's a dynamic data, because if you shut down the system, you might lose this data. Okay, if you shut down the system, you might lose this data. It's a very dynamic data. So there is a sequence in which we need to obtain the volatile data. First, we need to dump the memory, because content of memory is basically include your last access file, okay, open connections and everything. Then you have to dump the running process. Then you dump the open file data. Then you dump the network configuration, and then you dump the operating system time. So this is the sequence we have in which we need to obtain the data. Always remember. Okay, but non-volatile is what? You shut down the system and you can make a ghost image of that. That is called as a non-volatile. So always remember, whenever you obtaining a data or collecting a data, first you should focus on volatile data, and then you have to focus on the non-volatile data. Now you have collected all kind of information. Now second step is called as a examination. Examination is all about involving assessing and extracting a relevant piece of information from the collected data. So what we did, we collected all kind of information, but I need to focus on the particular IP. I need to focus on the particular pattern. I don't want anything else. I just want that important pattern. So I will try to extract the respective IPs. I will try to extract the particular pattern of traffic, and what is not relevant, I can ignore that. So that is basically called as a second step, which is called as a examination. And then once you basically examine, then you will basically try to do the analysis, how this incident happened, because now you have a filter data. So analysis should include identifying people, place, items, event, and determining how these elements are related to the conclusion can be reached. So that is called as analysis. And finally, you prepare the complete report. So during a reporting, you will compile all the data first, compile all the incidents, compile all the correlations. Then in the report, you should include the tools that you have used, because it's very important to give the information to your stakeholder, how you have obtained the data. Okay, who was involved in this crime? Who was involved in this investigation? What was their role? Any issue that occurred during the entire process? All challenges you can document in the report. Like one day what happened, I was doing an investigation of a server, but I was not able to access directly a server. I was not able to access some PI data because of the compliance and legal regulatory requirement. So I can notify this in a report that because of the compliance and legal regulatory requirement, we failed to obtain the reports. So audience consideration need to be considered. If you're giving this report to your technical manager, definitely the report will be very technical in nature. But if you're giving this report to the senior management, then remove all the data and talk about only business. Reporting should also include the actionable information, what can be done in the future. So many forensics incident response team hold the also formal review after each major event. And such review tend to include the serious consideration of possible improvement to guideline and procedure, and typically at least some minor changes are approved and implemented after each review. So that is basically part of the reporting. Okay, so this is the high level steps we have that we follow. Now the next thing is called as a chain of custody. Now what is chain of custody? See, I have obtained the evidence from this incident scene. Okay, I have obtained the evidence from this particular scene. This is the crime scene, like hard disk, data, systems and all that. So I am Prab Nair. Okay, I have obtained this evidence from this crime scene. Now I hand over this evidence to my colleague, which name is Kapil. Okay, Kapil hand over the evidence to Abhishar. Okay, so here what happens sequence we have in which we have hand over. And because Abhishar is the lawyer, Abhishar is basically representing the forensic team who going to the court and submit this evidence. So this is the chain we have followed. But they make sure there should be a one document we need to maintain, in which we need to maintain the information about who obtain the evidence, who hold the evidence in a current scenario, and what was the hash value. And that document is called as a chain of custody. Chain of custody is also talk about the sequence in which we have obtained the evidence. Okay, whatever the first evidence we have obtained, that will update in the document. What is the second evidence we have obtained? Document. When the evidence is hand over to other person, that is document. So it document the sequence of the possession, control, transfer, analysis, and disposal of things, including a physical or electronic evidence. An important aspect of evidence recording is the chain of custody. So here we have a item 1, we have a hard disk, we have given the description, model number, and all that. So it is released by Prab and received by Kapil, and we're giving the comment and everything. So this kind of a document we have which is attached with the evidence. And when we submit the evidence in the court, we need to submit this document also. So to prove the chain of custody, you will need to form the detail how the evidence was handled and every step of the way. Because one thing is that to testify the crime in the court, evidence is the only tool we have. Evidence is the only substance we have. If blah 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 person has hacked the email, or if the blah 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 the person sent an email to Rita, I need an evidence for that. So I went to a particular system, I got the camera records, and from there we able to identify at 12:15 that guy is the one who sent an email. So we seized the laptop, we seized the computer of the cyber cafe, we took the picture of the camera, we directly obtained the records from the camera. These all are evidence. But who obtain, when obtain, and when we have transferred, that need to document in one paper, and that is called as a chain of custody. So proof chain of custody, all examiner need to prepare to answer the following questions like proof of evidence. Okay, how did you acquire this evidence? When was the evidence was gathered? And who handled the evidence? Okay, so that's the point we have. But when we're talking about good evidence principle, let me give you a very good definition of what is evidence. So if you go by the Oxford Dictionary, evidence is a noun. Actually, okay. Now example, if someone has physically, if someone has killed one person, okay, one person has killed another person. So knife is the evidence. Fingerprint on the knife is evidence. That is okay when it comes to the general forensic investigation. But when it comes to a digital forensics, everything is data. Okay, camera records, IP records, IP address belong to a particular attacker. All these are basically evidence. So evidence is the information or sign indicating whether a belief or proposition is true or valid. Information used here to establish the facts in a legal investigation or admissible in the testimony in the law and court. That is what is called as an evidence. Okay, so here I will proposing my system logs. Here I am proposing the IP log. So that is an evidence. So evidence is the information which indicate whether belief or proposition is true, and information used to establish the facts in a legal investigation or admissible as a testimony in the law court. So question is, what is a evidence? What is a good evidence principle? The first thing is that make a copy of a system. See, never ever do the investigation on a live system. Always remember, suppose we have a server. This was the actual server which was hacked. So there is no point of doing a live investigation on the server. First, make a ghost copy. Okay, make a ghost copy and make a copy of the system, and then install the copy in another system and do the investigation. So that is the thing. So question is, what kind of a copy? So we do the bit by bit copy. Bit by bit copy is a great copy in which it will capture your deleted files. It will capture your Slack space. It capture your all the unhidden files and everything. So we always prefer, whenever you're creating a copy of any server, copy of any desktop, go for the bit by bit basis, not a file by file basis. And the media in which you're making a ghost image, making a copy of the system, that should have a write blocker. That should have a write blocker disk. Write blocker disk. Make sure secure the original and work on the copy and document everything, whether small to small or big to big, and do your best to collect data in an order of volatility, which we discussed, right? First we dump the memory data, then network connections and all that. So that is a good evidence principle we have. So whenever you drive any kind of an investigation strategy, we have some parameters to be understand. The first is that understand the investigation objectives and timeline. There are a lot of investigators, okay, what they do when they drive any kind of investigation without doing any analysis, they start the investigation. They don't understand the intent of the crime. They don't understand the motive of the hacker. They don't understand the purpose of the crime. So it is very important whenever you plan your investigation, understand the objectives. What is your timeline? What is the intent? Okay, second is make the list of resources that you want for the investigation. According to the skill set only, take the forensic investigators with you. Now example, like there was a enterprise which got hacked, and in that enterprise they're using a Apple Mac. So we need some forensic investigator who good in Mac. There's no point of taking a Windows forensic investigator, because we have a different way to do the forensic investigation in the Windows. We have a different way of doing a forensic investigation in the Linux. We have a different way to doing a forensic investigation in the Unix, or we have a different forensic investigation process we have in the network. So make sure after understanding the objective and have a clarity about what is happened, according to that, you need to plan the resource. Even the tools is also different. For Windows, we have a great tool which cannot be good in Linux. We have a good tools in Linux which cannot be great in Windows. So make sure you should understand the things and according to that plan the resources. 90% of the forensic teams do literally miserable on the second part. They do a lot of mistake. Third is identify the potential evidence source, because that is how you can able to establish the crime parameters. Hacking, like if the hacking initiated from a particular laptop, identifying IP is the most important priority for us at the first stage. Then second stage, we need to check who is the user who used the laptop. So it is very important to identify the potential evidence source and make sure when you're looking for the evidence source, look for the authenticity. Third is estimate the value and expense of getting each source of evidence. It's very important. I got one evidence directly from a server which got hacked, and I got one evidence which is provided by system administrator. Definitely I will trust that evidence which is directly obtained from the server. So we need to estimate the value. So sometimes we have a direct evidence and sometimes we have an indirect evidence. Okay, like someone told me that guy was sitting on the system, that is called as an indirect evidence. But we have a camera logs which talk about that day the person is sit on the system and did the hacking from there, so that is called as a direct evidence. Prioritize your evidence gathering. What is the important need, what is need to be reviewed later. So that is another important thing we have. And make a plan for first acquisition. Instead of directly investigating and all that, your 20 to 30% of priority is in a first stage when you're acquiring a data, because your entire investigation is depending upon the acquisition of a data. If you acquire the wrong data, based on that you do the wrong action, based on wrong action you will take a wrong decisions and the wrong person will feel guilty. So it's very important whatever you're doing during a time of acquisition, you should be thoroughly understand the things. Make sure you obtain the accurate data. So this will be your investigation strategy we have when you deal with any kind of a crime scene. So now there are some technical tools are basically used in a digital forensics. So that we're going to discuss in my next part. Okay, so now we're going to discuss about the different type of tools which is used in the forensic or digital forensic investigation. So one of the first tool we called as a Swift workstation. I'm sure you heard about Kali Linux. Now when you install the Kali Linux, okay, in any system, it install with multiple tools. It is like a OS, right? And within that OS, you can see the multiple further pen testing or secure testing tools. Same like Swift is like a workstation. Their image is available. You can download, you can mount, you can run that system, and that utilities. This workstation is basically include the multiple tools. Okay, so it is one of the popular one which is used for a forensic investigation, and it also consists several open source incident response tools also within that workstation. And one of the important feature of the Swift toolkit is that it has some utilities which is used to examine the raw disk. Okay, able to understand the multiple file systems. So example, we are running a system A, we are running a system B, and we are running a system C. So system A is running with Windows, system B is running with Linux, and system C is running with Mac. Each and every system is running with a different file system. So I install the Swift workstation on this system, which is my laptop. I'm an investigator, and then I basically connect with the systems and extract the data from there. So, or I can basically boot my system, boot this particular system with the Swift workstation as a live CD, and I can able to investigate these systems easily. So for me, investigating of a different file system will not be the challenge. And second toolkit that we're using is FTK, which is from the company called Access Data. So that toolkit, one of the important tool in the toolkit is called as a FTK imager. So when we say FTK imager, which means that we have a system A, we have a system B, we have a system C. So this was the system which is hacked remotely. Okay, so I want to make a ghost copy of the system. I want to make a copy of the system because we cannot do the investigation on the live system. So how to do that? In that case, popular tool we are using is FTK imager. So with the help of FTK imager, we can able to create a image of the complete system, and then I can basically copy that image or mount that image in other system, and then I will do the further investigation on that system. So these are the one of the popular tool we have. Along with that, we also have another one which is called as a digital evidence forensic toolkit. It is a well popular in the in a intelligence government activities. So, and the reason is that they have some tools which having a capability to open the encrypted files also and able to recover the deleted data. Okay, so that is why it is one of the popular utility we have, which is recommended by the different enforcement agencies also. Okay, but when we're dealing with the different type of data, okay, we need to make a image of the system, or we have a different type of extensions of the files. So one of the popular extensions we have is DD called as a data duplication. So it is also come with a DD utility which is used to copy the Linux system, and then we can create an image, and I can dump the image, I can mount the image in other system and do the investigation. So DD is another type of file we have. Then we have a AFF file format that is basically used in the forensic investigation. So it is an extensible open format for the storage of disk image, and it was created to be an open and extensible file format to store disk image and associate metadata. So AFF has a goal to create a disk image format that would not lock the user into proprietary format that may limit how or she may able to analyze that. And today it is a preferred tool for your gathering intelligence and resolving the security incident. It means if you make a ghost image, if you make an image in AFF format, suppose you make a copy of the system in an AFF format. So in that case, we can use this AFF utility with multiple forensic tools. We also have other different type of image like raw image, which is basically do the bit by bit copy. And the great advantage of bit by bit copy, it will capture the entire disk, entire volume without any deletion or addition. And raw image format was used by the DD also, but nowadays multiple forensics application also support that. It means if we have a system A, system B and system C, when I make a copy of the system and the image is raw image, so that raw image can be used by multiple forensic tool, because when we need to do the investigation on the system, definitely we are not doing an investigation in the live system. So we mount the image which is created from a system, and tool will read the image and according to that do the investigation. We also have other extension like DMP, dump, crash, MEM, VMEM and MDMP. So this is more like a memory dump data. So sometime when we need to review the memory and all that, these are the extensions in which we basically save the file. We also have a binary dumps for the memory, which called as a .bin dat file unallocated REC data or binary. So this is also is very useful when we need to investigate the open files and everything. Sometime if you want to investigate the virtual machine, we have an extension called VMDK. And when the FTK tool is creating image, they store the image in this particular format. So this is all from my side, team. If you find this video useful, do let me know in the comment box what is the next video you want me to make on forensics. I'm very happy to receive your feedbacks by which I can able to improve my video. And I'm sure if you're new to my channel, do subscribe to my channel and click on the bell icon to make sure you should not miss my future videos on a similar topic. And do let me know in the comment box what are the top popular forensic tool from your point of view which can be used for a forensic investigation apart from what is mentioned in the slides. Thank you for watching my video. Bye. Take care.
So team, whenever we basically get this information about a particular system got infected with the ransomware, or they have encrypted the file, or this system is under the ransomware attack and all that, the first thing we always need to do the discovery. Okay, this is basically called as an initial discovery. So in the initial discovery, suppose when you find some files and all that, you need to first identify what is the original or origin of the file. So here we need to identify how was the file was discovered. Example, is this file was delivered via email? Someone has used some external pen drive. So let's take example here is we have a system. Okay, so there was an employee who got one pen drive. He plugged the pen drive, and through that ransomware, a rat is basically deployed in the system, and then remotely hacker hack the system and encrypt the file. Or user receives some email, he download the email, from that the rat was execute and it give a persistent access to the remote system, and through that he hacked. So the first thing, whenever we confirm, okay, the system A was infected with the ransomware and ransomware attack was done successfully, we need to identify the source. Origin is basically very important, because by this way you can able to identify the author, you will identify the purpose, you will identify the motive and everything. The second most important thing when you're dealing with the initial discovery is the file behavior. So by the checking the system logs, security logs, you have to see, is this file execute automatically or it is triggered by the user? Okay, is there any noticeable changes in the system's behavior after the file was opened? So if you're running any kind of a file integrity monitoring software, you can able to compare against the previous state. So these are the two important things that you have to do in the initial stage to discover the ransomware and their associate properties. Now to understand the process, we have a two-way to analyze any ransomware. Okay, so there's our ransomware extension file we got in a system. So we have a two-way to analyze the ransomware. One is basically called as a static analysis, where we try to understand the ransomware structure and properties. In layman, I can say, suppose this is the file we have, okay, and it got encrypted. So we do the source code analysis of the file, we do the deep penetration into the file, we see the file structure, and from there we try to identify the origin and everything. On the second side, we also have a dynamic analysis. Dynamic analysis basically mean I will basically run this ransomware in a sandbox environment, and passively I'll try to observe the behavior of the ransomware. Okay, so these are the two important techniques we have that we have to follow. Okay, so in order to discuss in detail, let's start with the first part called static analysis. Okay, so you get a better visibility. So when we're talking about static analysis method, it means without executing a ransomware, we analyzing a ransomware properties. Example, like whenever we get any file, we always look for the file metadata. Now what is metadata? Data about the data is metadata. Example, when you create a file, you can see the last access date, last creation date, author name and all that. When you right click on the file properties, that is called as a file metadata. Okay, see, if you're looking for the accuracy, we always start with the static analysis first. So in the file metadata, we look for the file properties. We basically look for the last creation date. Okay, what is the author, what is the metadata, and we have a tools for that also. Example, one of the tool is called EXIF tool we have, and the procedure is basically what is does this tool is it extract the metadata from a ransomware executable files. And when we use this tool, we look for some important information like when was the last modified. So with the help of timestamp, we get the visibility when this attack happened. We look for the digital signature by which we can able to verify the authenticity of the file from where it got infected. And with the help of EXIF tool, we can able to identify the location of the file in the system where it is reside. We also look for the size of the file, which can be compared with your known good file. So example, this was the file was encrypted, and this was the origin of file that we took from a backup. So we can compare against, what is the current size of the file and what was the old file size. So by this way, we get a visibility what is the percentage of the size of ransomware is targeted the system. And with the help of last revision of version history and description, we can able to identify the file perspective. So file metadata is always a very good way to investigate any ransomware. Now second is basically called as a file signature. Okay, so we determine with the help of virus total. There's a website is called as a virus total. Let me check whether it is a known ransomware. So I will upload the one extension of the file in the VirusTotal website and check whether the signature is available for that. If signature is available, we also get the decryptor, and by which we can decrypt. So this is the way you can determine if file contain any known malware, okay, and all. So we use the MD5 sum, we use VirusTotal, we generate the hash and we compare against the stored hash value of the VirusTotal website, and if it match, and we can easily get the countermeasure. So initially it was used for WannaCry and all that. So that is another way to identify the pattern. One of the most effective way to identify the structure of the ransomware. We are not executing anything. We have a file, we're doing analysis of the file. The third way is called as a string analysis. Now I want your 2 minutes of attention here. In the first, we understand the metadata. In second, we basically use the hash and compare against the known hash value in the websites, from which we can able to identify, like, is it already there? So from there, we can also get the countermeasure action plan and everything. But sometimes what happens, we need to know the deep analysis of the file. And this is basically where you do the string analysis, one of the most effective way to investigate ransomware. So string is generally considered a data type, which is often implemented as an array data structure of bytes that store the sequence of element. So when you basically do the string analysis, we basically extract the readable strings from the file, which is check for the suspicious or revealing information. So we have a tool like string is a utility in the Linux. And the procedure is basically extract the readable strings from the ransomware executable files. So for your information, there will be one term has been used is called cryptography term. So cryptography term, like they will use a word called AES in the file. Okay, they will use RSA in the file. Okay, they will use a word called encryption. They will use the word decryption. So which basically give insight into the encryption method used. Nowadays we have a ChaCha20, that is a common tool that is used to encrypt, which use the RSA and AES. Then second most important thing, we also look for the file extension. Okay, file extension. So list of file extension that are ransomware target for encryption, we will check that. Third, the most important thing, very, very important thing when you're investigating a ransomware, check for the URLs. Okay, URLs of the remote server. Okay, example like this is the hacker and he using one system, and through that system, he gain access to the target system. So this is called your command control center. So sometimes what happens in the file, we can also get the information about the IP. Okay, we get the payment method details, we get the resource communication. So we look for that. Then we also look for the file path. File path is basically where it indicates the system files is there. Example, C drive, Windows system 32. So it can indicate which system file or directory the ransomware is currently interacting. Another important thing, we also look for the registry key. Okay, which basically give the indication of registry modification or check. Okay, we also have one more important thing which is missing here is called as a API calls. API call. So API call is like name of the window API function or other system call that can basically hint a ransomware functionality. So that also we can look for. We also look for keyword like Bitcoin, decryptor, which can also provide more context about the ransomware operations. Is it clear? So these things we have to do. So we can compare the exact string with the known ransomware sample or any indicator of compromise using a threat intel platform. We use also the extracted URL, IP or domain to gather more information about the ransomware infrastructure. And then we document the findings and we present for the analysis. So that is something we do. So summary here is static analysis is all about understand the ransomware structure and properties. Whereas the dynamic analysis is observe the ransomware runtime behavior by network activity and system interaction. Okay, remember one thing, while string analysis can provide the valuable initial insight, okay, the sophisticated ransomware techniques and everything, okay, but after doing a static analysis only, we do the dynamic analysis method. So dynamic analysis method is another type of technique that we use. So static is without running a file, just analyzing the properties, do the deep pen test into the file, we analyze the properties. But in the dynamic analysis, we try to execute that ransomware. We try to understand the pattern of the ransomware, how it works. Okay, and from there we try to get the understanding. So in the dynamic analysis, one thing we use is sandbox. Sandbox is just like a virtualization. So example like this is the machine we have. We run the ransomware in this and see how it works. Okay, based on a pattern, understanding and all that, we will prepare the action plan. Okay, why we run in a VM? Because if we run in a directly system and all that, it can infect the entire system. That is why we're running this in a sandbox, which is called as a secure environment. So if something has happened, we can just roll back and create a new environment. So we execute the file in a control environment where we observe the behavior, how it works. We also monitor the system changes. Okay, I will check the logs of this machine. I will check the system logs of the machine. So from there we get a visibility when it encrypting a file, how it works. So I will use the same methods. I will try to find the key patterns by which I can able to decrypt that. Okay, or I can basically prepare my action plan according to the pattern, how it activate. Is it clear? So tool like Cuckoo or Sandbox we have, where I will basically execute the ransomware in an isolated environment and we monitor the behaviors. That's what we do. So the ransomware attempt to reach a specific domain, they encrypt the file, they display the ransomware note. This is the passive thing we're going to observe. Okay, how it basically establish the connection, how it encrypt the files. Okay, so if we capture this activity, we can get the better visibility. See, one technique we have discussed about, run the ransomware file in a sandbox and then we analyze the behavior by checking the system logs and everything. We also have one more technique which is called as a process monitoring. Okay, so we use a tool like process monitoring to see the process, the file start or interact. Okay, so example like we are using Wireshark. Okay, so let's take example. This is the VM box we have and this is the file. Okay, so what we're going to see is like, this is basically the suppose called as a C2 center. C2 basically mean command and control server. It is a remote server that malware infected system used to communicate. So normally if you take example, if it's a hacker system, when he convinced the user to install one application, it create a reverse connection on this server only. And through this server, we control the system. So when we download any ransomware and all that, we'll parallelly run the Wireshark. And we check this file is targeting and connecting with which server IP. Okay. So by this, we get the idea about what are the IP addresses we have on which it's sending a data. What is a possible command to server. So we can basically block such IPs and C2 details on a firewall or threat intels. So that is also one technique we are using to proactively protect the organization from the further ransomware attacks. Is it clear? So that is called process monitoring. So as I said, in process monitoring, we also monitor the network traffics. That's the most important thing. We use Wireshark or we use TCP dump, by which you can capture the network traffic while the ransomware is running, and you can observe the ransomware reaching out to which particular IP. So you can able to block such IPs on your firewalls. You can block such C2 servers so that in future, it should not happen again. So this is all from my side, team. Do let me know how do you find this video, and do let me know shall I make more videos on the ransomware series. This is from my side, and do subscribe to my channel and click on the bell icon to make sure you should not miss my future videos on the same topic. Thank you. Good day. Bye.
Okay, as we discussed in the previous forensic investigations and attack, we are targeting more about password attack. Password attack mean finding a right password. So we have a different type of password attacks. First is called brute force. So what is brute force attack? Let's understand that. So brute force attack is like, this is the system we have, system A. Okay, so we are using a tool by which we're guessing a username password. Okay, we're actually guessing a username password. So that is basically called as a, you can say that is basically called as a brute force attack. We guess the username, we guess the password. Tool generate the username, tool generate the password. There's no limitation. And human is not involved here. Tool simply generating a username, generating a password, and based on that, we do the attempt. So countermeasure is account lockout policies. So if user attempting 3 times, 4 times, account should be blocked. Second is called as a dictionary attack. So here we maintain one source file. We maintain one file, and from the file we pick the password and do the authentication. We try to guess the things. But one disadvantage is that the password are limited to from that file only. If they don't find the password from the file, it doesn't work. But today, the modern technique that we are using is called as a password spraying. Now, password spraying attack is the attack where you use a single commonly used password across a multiple accounts. So I know in this system, I have 10 accounts. So we have a user A, B, C, D, E, F example. So what I'm going to do so far, what happened, we randomly guessing if we clear with the username, we're guessing a multiple password. So we're targeting a one user. But in this case, the same password that I guess, I'm targeting all the users. Like I will start with A, then I will enter the same password for B, enter the same password for C, enter the same password for D, enter the same password for E, enter the same password for F. So every time I'm guessing the same password. Is it clear? So the reason of introducing the password spraying attack is that, to avoid the triggering account lockout by spreading the attempt across the many accounts, and it target the organization with weak password policies. Because so far what happened, we targeting the same user with multiple password, account get locked. But now what happened, every time is a new session because we're guessing a new user. That is why it is the most effective from the attacker's perspective. See, when you're dealing with all the investigations and all that, okay, these all are called as an attacks. Okay, and that lead to the incident. So we have some definitions that you should be familiar with. So event is a regular occurrence or activity, or may not be indicated as an issue, but unexpected event that lead to the business objective, that is called as an incident. Problem is back to back it is happening, underlying issue causing repeated incident, like system getting down multiple times, that's a problem. And if we don't give attention to that further stage, we lost the customer, that's a disaster. And if we don't give the conditions to disaster and all that, it can lead to the crisis. And when you go for an interview, they will definitely going to ask you what is the difference between the event, incident and problem. So event is anything which impact the organization object in a positive manner. Anything which goes in a negative manner is called as an incident. The reason of this happening multiple times, it's a problem. And if we don't give attention to that, it lead to the disaster. And finally, if we don't give proper attention to all those things, it can lead to the crisis. So it's very important. You should know all these terms when you're working in the SOC. So as a SOC analyst, you should be familiar with the incident response process. Okay, so we have steps. The first step is preparation, where we establish the readiness, we develop the IRP, we conduct the training and simulations, we set up the tool, we inform people, okay, if you find this issue, report. But there is a SOP we have to follow, that is called preparation. Now user discover some suspicious activity in the system, he report that, and it go to the help desk, and from the help desk it go to the SOC L1. L1 asks some multiple question and confirm it's a true incident or it's a false. That is called as an identification. Yes, it's a incident. Isolate the system immediately. I don't want that to be spread to the system. That is called as a containment. Remove the virus, remove the virus and remove all the threat from the system, patch the system, that is called eradication. Restore system back to the production is called recovery. And then we have a lesson learned. In layman term, you can say the CrowdStrike issue which has happened. So team was already prepared any kind of incident. So they identify systems getting down, isolate the infected systems. Then they remove that file, remember, and then they restore the system back to the production for the business. And then finally we have a lesson learned. So objective of the identification, detect and determine whether an event is a security incident, that we can do with the help of monitoring, analyzing alert logs, verify the scope, classify the severity of the incident. Then we do the containment, limit the spread and impact of incident, where we isolate the affected system, disable the compromised account. Then we remove the root cause, where we identify, remove the malware, patch the vulnerability and remediate. And then recovery, restore the system back to the production. So rebuilding systems, restore the systems and monitor. And finally, we have a lesson learned. The ultimate goal of lesson learned is what is the lesson we have learned from this process and how to improve the overall incident response process. See, in this event, we got to know someone has reporting an incident in the morning. So we need one guy in the morning shift. So that is why lesson learned is all about improving the overall incident response process. So this is all from my side, team. A small gift from Prab Nair for a new year. And I'm sure those who making a journey in SOC Analyst, this video will definitely give you effort. Trust me guys, a lot of hard work has been behind this video. No, it's not a 30-40 minutes video. It's more than a 2-hour, 3-hour video. So I'm looking forward for your comments, because your comments really important for me, and let me know what should be my next video and what is the best thing you like about this video, and shall I continue my big video series in 2025. Happy New Year in advance, and without you I'm nothing, remember that. And my everyday 4 hours is always dedicated to my YouTube subscribers, which is not subscribers but gladiators. So do let me know your feedback. Your feedbacks are very important. And if you're not subscribed to channel, do subscribe to channel, because I'm bringing a lot of skill-based trainings, skill-based content on my YouTube channel. Thank you so much. Good day. Bye.